And I will get the training guide up. And with that, I'll share the screen. And now everybody should be able to see all of that. And we're going to finish up talking about some of those settings real quick. Still got a lot to get to, so we'll try to sort of rapid fire through it. Actually, I thought, well, this is fine. All right, now get into the telecat side of it. And once this finishes, mouse comes, there we go. And I'll load up our little file that we were playing around with yesterday. You don't need to, it doesn't have to be this same file. We're just going to use it for a doodle pad. So the first thing to do is to look over again those settings. And I think you wanted to take a look, Frank, at some of that the 3D arc issue again, if we want to look at that a little more depth, which we can take a look at. But we'll go to settings and Carlson configure, third guy down, general settings. That was this part over here in this lower right-hand corner, is that when we tell it to process, when we're wanting to turn 2D objects into 3D objects, you know, how do we do that? How do we direct it on how to transform that arc into a series of segmented chords? Okay. So again, I'm just going to draw a 2D so that I get a true arc. And all right, that'll work. So this would be, you can see I've got a segment. Those are, if you're not familiar with the grips, I've got the 3-point grip system on. So in 2D geometry, you see end point or you see vertex points and you see midpoint grips. Okay. And you'll see me also quite a lot just hover the mouse, and there's some different things you can do. I can just hover the mouse over and let it lock into the point. I'm not clicking any mouse buttons, I'm just hovering. And then you can come over here and do things like you could add a vertex, you know, and you can or you can also add a vertex from the point. But you can not only do that, but you can convert straight line segments into arcs, and you can convert arc segments into straight lines. Those are just some grip edit tools, and that's part of CAD. That's not Carlson. Anyway, now back to where we were. So if I've got this Let me do one more. There we go. If I've got this figure as a 2D figure, a straight piece of tangent, then an arc, and then a piece of tangent coming out of it. It doesn't have to be that, but I've got this 2D arc. And if I wanted to excuse me, transform that into a three-dimensional shape, I've got a couple of options. If I go to, I'm going to make a new layer here. And I'm going to call it 3D dash BRKLN for break line. And I'll make that cyan for the color. All right, so in civil, for instance, which if I switch to that, you can turn this into a 3D polyline by a number of ways. You can do this 2D to 3D polyline. You can do it from by a start and an end elevation, or you could have points along the way with different elevations. And so it reads that and tries to convert that into a 3D polyline. Now, I realize that's not what you're actually asking about, what you're wanting to figure out how to do it. But if we did that, or if somebody else does that and then hands you the file, that's really what you were looking at.
I
So
think that's what's happening.
yeah, so I'm going to go back to the settings, to Carlson configure, and I'm going to set that number up here for my, what do you call it, my maximum offset to 1, and show you that effect. Let me make sure I'm, get a sense of the distance that I'm looking at here. So 40, yeah, so you should be able to see that. Now, this is another reason, by the way, that, and you see I've got my settings for my lines and settings for my arcs. I'm using two different fonts. That's not on purpose. That's just because I hadn't done it. But here's the thing that when you ever do convert 2D to 3D line work, you sometimes will want to keep the originating 2D line maybe on a separate layer and then use the 3D to model with and then freeze that layer, because you want to be able to document sometimes or annotate these other pieces. And if that turns into a 3D series of connected chords, you no longer have a radius, you no longer have an arc length, you no longer have a delta. It's not, those kind of things would not be available. Okay, so that's that part. So now let's turn this into a 3D polyline. I'll just use start and stop elevation. So it'll be a constant, continuous grade all along its length. It wouldn't have to be that. I could have points to make it go up and down and up and down. It doesn't matter, but this will be the easiest part to do. So I'll say by start and end, I'm going to select the polyline. It asked me for that elevation. I'm going to say that's 101.5, let's call it. And it's going to go around over here to 103.24. Okay, now select a polyline to assign elevation to enter to end. So I said enter to end. All right, so now I've actually what I meant to do, let me undo that. I want to let's make a copy of that first. And I'll just stick it off here to the side. And now then I'll do that same 2D to 3D by, there are some of these other ones that you can convert to. They give you the option to put them on a different layer. Apparently that one doesn't. So that's how I make the copy. So I'll do 101.5 and it goes to 103.24. All right, so there now, let's make that a different color so you can see the difference. And let's put this guy back from there. to there. So there is with that that offset distance set to 1 foot. Okay. So you can see that that would make it, you know, a little bit uh, coarse in resolution. Okay. And so, and if you're talking about, you know, a 10,000 acre development, you know, and you're looking at it from 35,000 feet, it looks okay. You don't see the problem. But when you're out there on the ground trying to build that, um, your machinery that's doing this, whether you're using, you know, GPS guided uh, dozers and excavators and I don't know, I'm not in that industry, but do they have machine guided curb layout machinery? You know,
I
that
believe
can,
they do. The slip form has been
yeah, and it can read this surface and provide that. So if you were to give it this surface, the yellow one from the 3D, then it's going to build your curbs like that, and then you're going to not get paid, and that's going to be a problem. So you want that to be, you know, smooth enough to look like the original, but um, you know, not um, not wind up you also don't want it to be so many thousands of little points. So just illustrate again the difference. I'm going to make several copies here. Um, and we'll just sacrifice one after the other. But so there it was with the offset distance set too high. And if I set that to be what used to be the default, I don't know if this is still set like this. That's 0.0001.
not on
Uh,
mine. It was
okay.
a
All right, so we'll do it this way here. We'll select this. We'll just call it 100 and 101. All right, so now there it is. We'll make that yellow. So there's our 3D. And you can see, remember the difference in what we looked at a minute ago. And look at that. Each one of the, you know, that's how many segments, but that is, if you look at this in relation to its original, you can't really even see to you, like, look how tight I'm zoomed in to see. So that's really true to the original, but look how many little cords you got, and that's all got to get read by that equipment. So that makes it a little too um, difficult. Now, if you look at it the other way, I'm going to put this back to 0.02. But if I use my cord length, and let's say, let's use a 5-foot cord. And we'll go 100, 1, and then again, make that one yellow. And whereas it's not quite as severe as making the maximum offset big, as long as the curve's big enough, you know, and it's shallow enough, it's not so tight that these 5-foot segments would potentially work okay. All right, in this case. So, you know, just depending on whichever method that you prefer to use. Um, and comparatively, you can imagine when you set that number real small, you get, you know, itty bitty um, segments in this particular instance with this particular curve. So, um, you know, I would say, you know, choose a method. And again, what I've found is that these numbers work, give me the best balance. And I also prefer the minimum offset because it's tied to the arc regardless of the degree of curve. Okay. Whereas the chord length, I mean, they both are tied to the arc, but the chord length solution can vary in terms of how much it deviates from the arc depending on the degree of curvature of the arc. Whereas the offset is always going to be that far away from that arc. Um, so you're setting the offset. So that's really what we're after is how well does it fit the arc. The other side is you're setting the length of it, and so it's just going to lay those down at a certain length. It's just it really doesn't matter. One is not right, one is not better. That's just the way I think about what I want the system to do for me personally. It's just like a lot of highway designers, and I've done quite a bit of highway design work, but a lot of them will, when they think of curves, when they start designing, particularly, vertical curves, they start talking about K values. There's a number as part of those equations called a K value. It's basically just a ratio of incoming and outgoing grades that relates to the sight distances. So, but they know they have an inherent sense of what a numerical value of a K value is. I don't. I know what the formula is. I can calculate it, but I don't have a gut sense of what that would look like on the ground. So, and, there's people that will do the same thing with um, horizontal curves. They might have I don't know, maybe they think in terms of, what kind of how steep a curve would a radius be to fit? Whereas I can visualize curves better, horizontal curves, by thinking about the tangent length. So that way I can sort of estimate the distance back from the PI, and I know where the curve's going to start, and then I'll know where it's going to end, and then I can visualize the curved line in between it. I have a harder time visualizing the radius because at some point, you got to still find that point um, in your visual inspection where the radius of a certain length is going to intersect the other side. That's going to set the curved position. It's just a matter of preference. So that's all that this business is right here. Okay. So now the other issue is, let's do this. I'm going to put this maybe even higher up to 2. And I'll do this one right there. And make this yellow. Drink.
Yeah, I think you clarified that pretty good. I
Okay.
think I got what I needed on that one. I appreciate it.
Okay, sure. But the biggest thing is, what do you do about that when you get that from somebody? And the answer is, if you've got the original 2D stuff, then you would have to re-elevate that and then add that into the surface model. But if all they've given you is the resulting converted geometry, and they haven't retained that 2D geometry, then you're really sort of stuck with trying to use it. The other thing that you can do
I've just
is,
traced over it at this point and just done O snap really near and basically mimic that short chord length, and that's the best I
well,
could do for an arc. Or I've just
yeah,
made the 2D polyline.
yeah. Well, what you could do is, and this case happens to be just a 2 segment piece, but imagine there were 3 or 5 segments here. If you can find the first segment, the first one that occurs, you could trace over, like you said, make that first vertex your PC, and then find the last one, make that your PT, and then snap to any of the points, not any of this stuff, but any of these vertex points are going to lie on the original arc. So you could create an arc you know, much like this, you would draw, you know, let's say, let's draw a 2D polyline. I would start here to here, whoops, sorry, to here. And then I would maybe draw an arc. If my, what is, huh, I
I
guess we
probably would
have,
have done a 3-point arc. Yeah.
yeah. So use an arc and you would say, I would start here and it wants a second point. So any one of the points along it, just snap to it and then give the end point. And so, you know, the second point, so we'll switch to end and then, whoops. Oh, it needs a 2D point. Yeah. Okay. So convert it to a 2D first. Uh, just do it a
I think
3D.
that's what my problem was too. I was using a 3D point and it wouldn't do that. So I had to get just kind of close to it. But I can see if
Yeah.
I make it into a 2D, that'll solve that problem.
Yeah, you can do that to make it into 3D, or you could even, if you draw, I'm going to draw an arc. Do you know how to use dot filters?
I don't think I have.
Okay, so a dot filter is if you type, like it's asking you for a point, we're going to actually, I'm going to tell it, you know, where to start. I'm going to, you know, it's not going to let me start on that 3D. So I can start on the end of that one because that's 2D. But to make sure that I get only the XY values of these 3D points, I want to say, let's see if I can do it with this filter. I'm going to say dot Z, and it wants to know this. No, that's not right. Let's do it. Sorry, I did it the other way around. So I do an arc, and I'm going to start on the dot XY. So that means read the XY coordinate value of something. So I'm going to take that point, and it goes, okay, now look at the command line. It says, now still need the Z. And if I can do that, okay. And now my second point will be the dot XY of that. Still need Z, we'll make it 0. There we go, it's gonna work. And then we need the dot XY of this and need a Z of 0. All right, so there we go. So you can either convert that from 3D down to 2D, or you can use dot filters where you can tell, and dot filters can be either a dot X, in which case it would say, okay, I still need the Y and the Z, or you could say dot XY, which means, okay, I read the XY, I need the Z, or you could say dot Y or dot Z, and you need the other coordinates and it'll prompt you for them. And you can either type in the value, or let's say you had some other 3D line work over here that was at a different elevation. And so you want this to come along here and you want it to go here in XY. And so you would say dot XY, you would pick that endpoint and it says still needs Z. Well, you could come over and pick the endpoint or the midpoint or intersection or anything else that has elevation. So you could pick all three of those. You just, with dot filters, you start it off with a dot and you type in which, however many of the XYZ placeholders that you want to use by your first pick. And so it's really a nice way to edit some elevations sometimes if you've got geometry that you're going to be snapping to and you need to make handy. Okay. All right. So like I said, if all you have been given is this stuff and you haven't been given that 2D, you'd have to recreate them if you want, you know, if you need to get back to that. And then throw away the 3D and re-elevate that 2D with a smaller value there. Okay. So let's go
All right,
back and
thanks.
finish. Yep. So let's go finish this up. Let me put this back before I forget it. And let's talk about this linking. So you've got this thing called object linking. And what this does is it sets the behavior of the way certain things are going to behave. And um, and they're pretty self-explanatory as to what it does. You're going to link points with the coordinate file, which is what you typically want to do. Now I look up here at the top stripe of the application and I see Carlson Civil 2025 with IntelliCAD 12, not for that's my license. And then the CRD coordinate file that I have is called class example 1. My drawing file is called class example 1. So I know that I've got the right coordinate file associated here with these points. So that part's pretty good. And then if any changes that I make to points in my drawing are going to reflect in my coordinate file. Now you notice from yesterday when we moved some points around, it prompted you. Hey, you've moved your point. Hey, this point differs from the location. Which one do you want to use? That kind of stuff. So that kind of behavior is actually fairly new that it would prompt you. It used to always, it would follow this setting. So if the linking was on, and if you moved the point in the drawing, it automatically moved the point in the coordinate file, didn't tell you about it. If the linking was off and you moved the point, it did not update the value in the coordinate file and didn't tell you about it. Now, you can imagine this kind of being a problem because this linking is not a toggle switch that works for things that you have already in the drawing. None of these are. These are all toggles that work for from this point forward. This is what I want to happen. So any new points in this case would be linked. Set some points, and I can come back in here and uncheck this and set some points, and they're no longer linked. Now, because of the problem with the coordinates that it caused, Carlson gives you that warning regardless of what this switch here is set to. Okay, so that part doesn't matter as much as it used to.
When
But
would you
here,
link a line with a point?
why would you?
When would you? Yeah.
Oh, when would you? Well, let's say you've laid out, points along the edge of a parking lot, maybe.
All right,
And
or maybe top a curve. I get it.
yeah,
Okay.
yeah. So then when the point moves, it'll pull the line work with it. But here's the problem that came about and why they've got that warning now is this is machine specific. It is not drawing file specific. This setting, any of these settings, is what is in play on this machine. So when we explained that at a class down in Charlotte, North Carolina, way back in, I want to say 07 or somewhere like that. It's a fairly large surveying firm. I don't know, 10 or 12 crews and corresponding number of office staff kind of thing. And so they all came, they had a nice training room and they all had laptops in there for the training. So the supervisor, the head of the survey department, his eyes got real big and he goes, "Oh my gosh, I want everybody right now, get up, go back to your offices and come back and tell me what your machine is set to." So they all did that. They came back and some had it on and some had it off. And here was the problem because they all worked on the same files. So, Joe Blow over in cubicle, 123, he's working around with his points and he's got the linking on because he knows if he moves the point, he doesn't have to stop and update his CRD file. But Mary Smith over in, the next hallway over, she works with her links off because her way of working is to, well, I get them in the drawing and see where they are, and then I can move them around, get them out of the way. If they're in my way visually, I'll just move them around because I know I can always go back to the CRD file and recreate it, put it back where it's supposed to be. Well, that's what the guy said when they came back with these all at different settings. He goes, well, that explains the last lawsuit. And he said, what's happening is they had guys that would get a whole cluster of points around a suspected property corner. And they zoom in there and they try to resolve based on, other evidence and whatever stuff they're looking for in their deed resolutions and such. And the guys that, and none of them were even aware of what the linking did. They didn't consciously necessarily make any of those choices. Somebody did at some point, but and so they're just, he was used to being able to, his thoughts were that, okay, the CRD is the Bible. I'll be able to go back to it for the guaranteed source values. And so he would zoom in around that cluster of points and they'd be in his way. He'd just grab them and scoot them just a little bit out of the way so he could see what's underneath. And it's just that little bit. If he's working on a file, when that point was originally drawn in the file, if that linking was on and he was thinking it wasn't, it's going to affect the CRD file. And so he's now just started to shift those point values. And so, they would draw that and use that new location, that slightly shifted location as the property corner. And so you can imagine, it wound up getting into some conflicts and people having problems with their deeds. So that's why you now have all those warnings for that one. Now, the idea of linking line work with points is when you draw line work in Carlson, you're perfectly free to use the CAD tools to draw your line work. You can draw lines, you can draw polylines. And I will tell you, Carlson prefers polylines to anything else. I don't know how long it's been since I've drawn a line. I draw polylines exclusively, even single segments. I'll draw them as polylines because Carlson works with polylines more so their commands require them than they do with line work. You still wind up with them, and there's routines to convert them into polylines if you want. Even circles you can convert into a polyline, which is just two arc segments of the line. But let's see, what I was trying to say is, so you're perfectly free to draw with any other technique the geometry that you're working with. But when you do that with Carlson, for instance, with we make sure I was afraid of 02. All right, and now okay, and exit. So like if I were to draw this using, or if I were to draw a polyline, let's see where I've got, there's 0.9, there's 8, there's let's go 7, 8, 9. So if I wanted to go to 0.789, I can just draw a polyline, just use a P-line command, all right? Standard old CAD polyline. And I go, okay, well, I got my point snapping. I'll go 7 to 8 to 9. And that's fine. And I think now if I move this point, so if I say yes, update the coordinate. Now notice that line did not move, even under a regen. So that's just a standard polyline. But when you draw with a Carlson, draw 2D polyline, 3D, whatever, it doesn't matter. And I say, okay, notice the prompt. As opposed to the AutoCAD version of the command, which said pick a point, or, you can obviously you can type a coordinate separated by commas, or pick a point on the screen. But Carlson says pick a point or point number. That's the big difference right there that Carlson offers. There's other nice things too. You can follow other line work and continue and extend and all that stuff. But it's this point numbers. So I can, using this Carlson creation tool now, I can just type 7, 8-9, which means go from 7 to 8 to 9 and hit enter, and it draws it. Now, if I move that point, it pulls the line with it. Okay, that's the linking. Now, here's what does not happen. I can't select the line and move the line, and it pulls the point. Okay, and even after a regen, the line stays over here, but anything that affects that point, I'm just going to double click it and edit that point. And you notice when you're doing that, you've got all this stuff here too, these tabs across the top. But I'm just going to edit this point and maybe, let's just call it, I'm going to change its description. Notice there are two description fields here. One is for the description in the drawing. One is the description in the coordinate file. That's a little bit of field to finish peeking out from the curtain. Okay, because the point can have a description here, and if you create it with field to finish codes, it can give you a different description here. That's all that reason why you've got two. So I'm just going to say that. Once I've modified that with a CRD file edit, the line will reconnect itself. So if you say, all right, I really meant to put that over here at that endpoint, okay, that's fine. But then do anything, and it might even be anything. Let's just, let's take out the new and see. Okay, no, it's got to, I guess you have to do something that affects that particular point. So, and then that will pull that back. So so any kind of slight change to that point is going to reconnect that line. That's how that linking works. It's really, it says link line works with points. It doesn't say link points with line work. So it's a one-way link. So if you change the line, it's not going to pull a point, but if the point then gets edited or repositioned or anything, it will relink that line. So think of this in terms of doing boundary resolution as a surveyor. You might not want to link your line work with points. You can still create lines with points and all that, and then tweak around your points. And that original line stays where it is, even if you've created it with points, either point numbers, or you could also have done that snap to the points and all that, as long as you're using that point snap to where it's recognizing that you're using a Carlson point. So it's going to do that linking if it's on. If it's off, then the line, even though you've gone through points, and then you can move your points around, the line stays put, and you can go back and just grip edit your line and reattach them to the points if you want to later. So that is
my quick concern with the 3D polyline, and correct me if I'm wrong, would be if you're doing the boundary lines on the deed and the 2D line, that's your boundary, is 100 feet, but you shot the PK nails or the rebar and you gave them Z elevations, and now you drew a line connecting those from the Z elevations, and they're 50 feet vertical difference. You have to double check, because when you go to identify the bearing and distance on that line, it's not going to be 100 feet, right?
Yeah, if you're correct, if you're using 3D.
3D points.
Yeah, but well, even if you're using 3D points, now there's ways around that. Let's see, I've got an elevation there, a significant difference, 100 feet, and that's down to 0. So that'll be a significant difference. Let's do that with a 3D. So if I draw a 3D polyline, 7 to 9. Okay, now, so that's, and you can see I no longer have the midpoint grips. That's another way. And then looking at my properties, I see it's a 3D polyline. So there it is. Now, if I were to annotate that, I don't think, let me see. So I'm going to annotate that. Now there are those numbers. So 5381. All right, so keep in mind what that is. Now I'm going to draw a 2D polyline. 7 to 9. And now there's that one. So let me take these original 3D text and let's move them just down below here. And now let's auto annotate that, which will be the 2D. And you see the distances are exactly the same. That's because on that annotation, it knows to project that into 2D space and give you that horizontal distance.
Okay.
Okay. Yeah, there's other ways that you can get that 3D distance if you want to see that as well. But so that really doesn't have the effect that you feared it would. And it's good to, and it's always good to double check everything you're doing with it too. But, and you can also, and notice I haven't changed the point elevations. I didn't make them anything else. And I can see, in 3D, that's obviously read the elevations. Okay, but the annotation of it, if I'm using the annotation command, will do it. But if I just look at the data, if I just look at the segments, like if I do a standard distance, if I pick a point there and a point there, that reads a distance of 277.263. So you can see that's reading the 3D distance. So let me get rid of that guy and do that distance now from here to here. What's going? Did I get rid of the wrong one? Must have had. How many do I have now? Just got the one. Okay, so now if I do that distance, yeah, now my distance is back to 147.83.96. 147, yeah, 147.84. Right there's my number. So yeah, that does matter if you're measuring something or if you're but the annotation command will honor it as planar distances. Okay, so it's a good point to check things like that, but it's a good way to do it. Notice also on there, draw 2D, is you have this option right here. You can set the elevation to something specific, and it will be at that elevation. Or you can say, set the elevation by the first point. So it will read the elevation of the first point and then keep that 2D polyline at that constant elevation. You can do it either of those ways. If you do a 3D, let me do that options. You got a number of options here on a 3D where you can prompt for the elevation or slope. And then you can prompt for coordinate point elevations and add a certain value to it. Like if you want to set something on the elevation of the points and then drop it all 4 feet, like you're creating a water line, you want to be 4 feet in the ground at all those points, you could put a -4 in there, for instance. But here is under these prompts, and either one of these two, if I prompt for elevations, whether this is on or not, when I go to those points, it's going to tell me what the elevation is and prompt me. I can then change it to 0 if I want. Okay, same thing, I could prompt for the point elevations. Even though they have elevations, it was going to stop and ask me, and I can set them to 0, or I can set them all to 100. So in effect, creating what behaves like a 2D polyline, it still is a 3D polyline, but it just happens to be planar at that stage. Okay, so there's a number of ways to sort of control all this stuff. You can also, while you're drawing a 3D polyline, you can have it also draw a 2D polyline, put it on a separate layer if you'd like. Okay, so we will draw, that's sort of like field to finish works. And I can even use a surface model. Let's say I've already built my surface. I've got an existing surface file. And if I go through these points, it's going to read the surface for setting the 3D line. and it's going to also create a 2D polyline right along with it. Okay, and so, you know, again, all these options. And the reason you want to do that again is for things like this arc to keep. So if you're going around an arc and you can create a 3D arc with the draw 3D, but again, when it creates it, it does all those little segments. It doesn't actually create a 3D arc. There's really no such thing. And so, but while you're doing a dual 2D polyline, it will generate it for you. Okay. And I wonder, that's a good question. Let's see what this will do here in a minute. Get rid of not that one, just those 2Ds. And that's an excellent question. I wonder if this will happen. If I do a 3D polyline and I say, draw a dual 2D polyline, put it on a different layer. And I'm going to say, okay, and I'm going to just snap. And then I'm going to snap and I'm going to choose arc. Okay, and so now, see, it's already segmenting as it's doing this draw. I can either do the radius point, a radius length, an arc length, a chord, second point undo, or the end point of the arc. So if I go here and then finish out here, aha, that has recreated that 2D arc. So our discussion we talked about later where you'd have to go and trace over it, do it that way. Draw it with a draw 3D polyline. So you're going to trace right over top of that original 3D polyline. And when you get to the PC, switch it to arc, show it to PT, and then keep going. But have this option set to draw it on a dual 2D polyline. And yeah, you can have your color set to by layer or whatever so you can see something different. And so then when you've recreated, then now you've got two 3D you'll have two 3D polylines. See, I've got two of them, the one that I traced over and that one. But I wind up with a 2D being recreated. So yeah, interesting little option. Hadn't ever thought about that application of that, but that's a good way to do it. And that's that little switch right there. Now there's another little switch in both of these draw commands I want to tell you about that it's real easy to overlook and miss. But when you're drawing, let's just go to a 2D. You have this switch right here that says autocorrect for 90-degree corners. If that's on, because maybe we're drawing buildings out here and we gotta go and we do a little building. And so if I'm within a certain tolerance, let's see if I can find it here. Yeah, see how that snapped over to that? And if I get right here and I'm gonna, I exceeded my tolerance there. Let's see if I can get, all right, autocorrect is on for 2D. So I'll go here to here and just slightly there, it snaps it back. And I'll go, you know, just slight there. See how it's snapping to be right angles? So if I do that, now if you're outside the tolerance of that angle, and you can't set that tolerance, you just see, but that has now forced that to be rectangular back here on these corners. That's fine and that's useful and helpful if what you're doing is setting that as geometry that you want to force into those 90-degree corners. But then later on, if you run the command again, it's easy to overlook the fact that you had that on. So just be aware of that option. And if it's on and you don't want it on the next time because you're really getting precise and it's going to be exactly where you want it to go and you don't want it to do that, then uncheck it. Okay. So these options are very helpful and very important. And sometimes if you've done this right here, don't show options on startup, then I'll just repeat that command. It goes right into asking me for the points, so I can start doing this. If I want to see those options back, then all you do is down here on the command line, you choose O for options. So that'll bring that back up. I like to have them because even when they pop up, it's just one more, I hit the enter key or I hit the OK to start the command. And then if I repeat it, I just say OK and go on. So be aware of those switches in that option tab. And if you turn the options off and you want them back on, it's available down there on the command line. Okay. So enough of that part. Let's talk one last little bit of linking here. And that's labels with line work. So again, if that's on, if you, again, we'll just draw this, and labels are talking about annotation, not if you just type text, but you have to actually annotate the geometry. And so there it is, right? Now linking labels, now it can also be a close figure, and the area would be linked. And so when I change that, because linking is on, it recomputes and redraws those elements. Now there's one couple of things that sort of trip it up. Like if I add a vertex here, maybe put one over here. You see what I did? I had originally the 3 annotations. Now this segment over here is no longer annotated. It's only doing those 3. So I would have to then just go back and re-auto annotate. And in your settings, you've got it to, in your general settings, you've told it to previous labels right here. You can erase or retain or prompt before. So if I just erase those and then choose, it will redo those additional labels. So, but any kind of changes, they're going to follow along with it. Now, again, keep in mind, all of these are going to be dependent on the state of the switch at the time the geometry was created, whether it's a point or a line or center lines, that kind of stuff. If it's on and created, it behaves that way, even if somebody, if you come in here and then uncheck, link labels with line work, uncheck this kind of stuff here. Now, if I go and try to do this, moving this point around, it's still going to recompute those labels because when it was created, the linking was on. So if I wanted that to no longer be linked to those labels, I would have to recreate that polyline with that linking turned off. And so then the linking would not work. And the corollary is also true, is if it's off when it was created, if I then go back and turn it on, it doesn't magically then link up stuff that's already created to have them linked. Their state is set based on what these switches are at the time they're created, okay? Now, the last 3 here, linking line work with center line is a really nice little powerful two-way linking. I'll show you a quick demonstration of that, but the last 2 here, group the point entities. Remember, we talked about the points. And those points are these entities. I have at that location, there is a CAD point, and I also have this graphic block of the symbol, and I have this attributed block of the point number, elevation, and description. So I've got 3 entities that make up a Carlson point. And that's what it says, group them. So if I click any one of those entities, I'm going to group that. And so then if I can manipulate it by here, I can just move the point. Or in IntelliCAD, even with them grouped, I also see the grips for the attributes, and I can adjust those as I need individually, and yet the point stays right where that dot is showing for the point. Okay, so now in AutoCAD, for instance, if I've got these points here, let me give this a symbol. All right, so there it's got all of those same things, the attributes and the symbol. There's a point there in the middle. But when I select that, you see, I don't get all those individual grips. I get this one thing. And if I move that, that's going to move the point, and off it's going to go, wherever I created it. So the grouping looks different in the AutoCAD side. Now, Chris, one of the things that you can do though is if you did your settings here that said, if we uncheck the group point entities, now here's what's going to happen. I'm going to redraw point 232. So I'm going to take that same, what does it say? 232, enter. All right, so there's now 232 recreated. And if I select it now I get those individual grips that I can edit separately. Okay. But the problem also is, I think if I don't grip that, no, I still selected it, and yet it's reading that as just the block. In that case, it's just the attribute block. And I can tell that up here, it just says block reference. If I select the symbol, that's also just the block. And so if I select that symbol and then erase it, well, my point is still there, but my symbol is now gone, but it didn't pull this with it because it didn't grip this whole thing together, didn't group the whole thing together. So here's another option to do instead is under Carlson configure. If I'm going to go back, and I like to keep them grouped, I will draw locate number 232 again. Okay, so now when I select it, I get this in a central location. Now that is coming about based on an AutoCAD option. So if I right click and look at my options, I think it's going to be under selection. It might be under user preferences. Let me see here. Selection. Now, right here, under selection in your options, see where it says object grouping? So if I uncheck that, now, when I select it, I get the behavior like I get in IntelliCAD. I can individually rearrange these attributes by just grabbing their grips. And if I grab this one, for instance, it's going to take the whole, let me see. No, that's still, yeah, I'm moving that entire attribute separate from the symbol. If I choose that, yeah, that still keeps that separated, but yeah, it's still, if I uncheck that on the selection tab, that object grouping, that apparently, yeah, it used to in other versions, it would separate out the individual grips, but still keep the thing grouped based on the Carlson switch. Apparently that no longer applies. So I would still recommend keeping it grouped so that if you do want to move something, you just grab a part and you take care of the whole thing. But you can also, if you wanted to move those individual attributes separately, instead of doing the grips, just go to the points menu, and everything down below this little line has to do with those attributes. So you can actually move point attributes. So now select the attribute you want to move. I'll just select that one, move it around, give it a rotation. Select that one, put it, over here, give it a rotation. Maybe take that one, put it there, and maybe turn that up. And then while that's there, let's just move it up sort of like it would be. And if I freeze these twos off, and that could be a spot elevation, that kind of stuff. So you still have access to it. You just need to do it from these attribute places. You can also, move attributes with the leader. So if I take this, it's going to, do something like that. So if you've got points real tight, you can, do that kind of stuff. And then it's supposed to, if I redraw that, yeah, so it will re-honor, I mean, it will honor that placement. So if I just erase everything from the drawing and then relocate a point, okay, so it had to be, it had to have been done. And if you recreated it, reads that fact that you've moved it and it honors that same movement of those attributes. There's some other commands that also will recreate uh, points, Carlson points. And if you've rearranged these attributes, it will actually prompt you on the command line. Do you want to maintain those attribute offsets? And you would simply say yes or no. Okay. So that's a couple of ways those are linked. Now, let's do a real quick one. I'm going to keep my little center line, or my little polyline out there. There's my original polyline. I'm going to turn that into a center line. This is how linking line work with center lines work. If I go up to the center line menu and I'm going to say polyline to center line file. And when I do that, I need to give this one an alignment name. I'll just call it Main Street. It doesn't have to be a street. These could be sewer layouts or whatever. So it says, select the polyline that represents the center line. It also tells you on the line above that it should have been drawn in the direction of increasing stations. No problem, even if it's not. It shows you the direction it was created, and it gives you the option down here to reverse it. But if everything's like you like it, there's a beginning station. You can give it a different station name. So off we go. Just take it as it is. And now it is a centerline file. Now that wouldn't be a very smooth ride on a road. So you would need to put some curves in there, and you can do that the CAD way by using a fillet command. Or if you just now well, first of all, let's draw another 2D polyline over here on the side, but don't turn it into a centerline file. If I just double click this because it's a polyline, notice what comes up on the command line is the CAD p-edit command, an edit p line. But because I've turned this one into a polyline or into a center line, if I select it and look in properties, I see that it's just a polyline. It doesn't say anything about being a center line. But if you double click it, because I turned it into a center line, it loads up the center line file editor. Very same editor as if you went to centerline edit or centerline editor and you chose the file. Okay, that's the very same thing that happens when you double click it. Now, here's the linking part. So I'm going to put some curves in. I can sit on each incoming line down here. I'm going to fit a curve. And I'm going to give this a 50-foot radius if I've got enough distance. And see, it does. It computes all the other stuff about it. I'll say, okay. And you can look up speed tables, the whole bit. So I'll say, okay. You go back and put 50 feet in there and say, okay. So I put a 50-foot curve in. Maybe I'm gonna change that curve to, let's make it a little smaller. Let's make it a 20-foot curve. Obviously not a very good road design. And then let's put in another curve in there. We'll make that one 35 feet and see what that looks like. So that puts that one in. We'll come down here. We will leave that one alone. Let's just save and exit. Now keep your eye on the drawing. So as soon as I made that change, it changed that. If I then just do a CAD fillet with a radius of say 25 feet and pick here and here, it put that in there. Now, if I double click it, you see how that curve is now in there, and it is 25-foot radius. So that linking is very handy, I think. I like to have it that way. And the same thing applies. Centerline, if you station the polyline and centerline file, there it labels now. I haven't set the sizing and everything correctly, but there's my station values. Starts here at 0, ends at 232, and I could have the intermediate ticks and all that. Let me just repeat that and let's load up some settings. There we go. So I've got my stationing. There's the tick. There's a 1 + 0, the 150, the 2 + 0, 0, and all the PCs and PTs. Now, because of all this linking that's going on, remember labels are linked, centerline files are linked. So if I take this and just grip edit it, a little bit out here, my curve changed. Notice all of that stuff changed. And there's the original where that arc used to go through. But now it is, get into the editor, save and exit. Yeah, so now it reset those labels. So if I pull this PT point and moved it out here a ways. Okay, so now I've just grip edited it, so it changed the positioning. The labeling doesn't immediately update with that until I actually go into the editor, save and exit, and now it'll shift everything back and recreate the labels. All right, so that's how linking works. And again, keep in mind that when you have that on or off, that right, never mind. Now, let's go back to that because I thought that used to work. So if I take this and let's move that up slightly to nearest here. Yeah, no, it's, I guess, let me because I had my label linking off. So if I now re-station the polyline center line, all right, there it is. Now if I move this, let's just put that back right there on that one. Let's maybe pull this off a little bit like that. Okay, now I still need to go back and save and exit, and it recomputes that back to the switch. It might also be that that switch would be effective. I would have had to recreated this with those switches on. But in any case, keep your eye on that, how those link, whether you want them to or not. And again, there's no right answer. I work with them best knowing that they are linked myself in my particular workflows. You may not. You may have other needs. Why this thing got reset here. 0.02 max offset linking. Okay. And exit. Now, yeah, okay, we're back where I need them. So, and again, keep the important concept in mind that linking applies at the time the entity was created, whatever you're working with. So if it was off when it was created, it stays off. If it's on when it was created, it stays on. There's some other little things you can do, like file, drawing utilities. You can come down here and say remove extended data, extended entity data, then that would say take that away from being a center line. It would take, so that would, and remove reactors. So if I removed the reactor from that center line, now when I double click it, it's still linked as a center line. But if I join utilities, let's remove the extended entity data from that object. Now when I double click it, it's just a polyline. See, it's no longer linked. Okay. But for all of you Land Desktop fans, what can we do? Let's just throw that away and go up here and let's draw the centerline file because we have saved it to an external file. We can label the centerline stations. I'll set that to match the same settings. I'll say, okay, there's my file. It's going to recreate that. Now it went on a different layer. That's why it's a different color. And it should, my C road center line, I should, have my layer for road C dash. Let's do it that way. C road center line. Yeah, I would have made that instead of that a center line. And, you get the idea. My LT scale, still set to 1. So maybe a center line 2 would have been a different choice, a better choice. All right. So that's how all that kind of stuff works. So that's the thorough immersion into the settings. And anytime you're experiencing problems, here's a perfect example. I got it to work this time. Now, remember I told you yesterday that sometimes all of this kind of work will throw out a stray point down around 0, 0. So I did a zoom extents. I double clicked the wheel. And when I do that, everything goes way up here. So I've got something somewhere down here that's causing that to happen. And again, I can simply select this and I see, well, I've actually got 2 points. So 2 things that I did through stray points down here at 0, 0 is probably some intermittent step in the middle of one of those commands that got interrupted. And so it left it where it was. You can just select those and delete them, or you could do that, edit, erase outside, and then just give it where everything is safe, and then go back to zoom extents and it comes back to the way it was. Okay, so whenever you experience that, always check down there, and you've usually got some kind of stray entity, and it's often a point that's down at 0, 0. So you can get rid of them either of those 2 ways if you want. Okay, so any question on any of that so far? I think
All
we're
good.
good. Okie doke, perfect. All right, so let's move ahead then into what we were talking about. Now, we've talked about the next part of the training. We typically are going to talk about these points. Now, we've been doing this all along, so I'm going to sort of skim this part a little bit better for you, so we won't take as much time to work with these points. But there's a discussion here starting on page 11 that talks about points, Carlson points. And it just says up here at the top, Carlson performs its work using basic CAD entities like points, lines, polylines, etc. But these tools make those behave like intelligent objects, like we just did the center line example. So that really, there's nothing that IntelliCAD or AutoCAD knows about that object that tells it it's a center line. It's Carlson in the background that's doing that kind of thing. So when we talk about points, we need to understand, what it is we're talking about. There's really sort of 3 different distinct instances of points or point-like data. And so if you look at that drawing there on point 11, it's a polyline with vertex points labeled A, B, C, and D. And the question there above that little block says, are there points at those locations? And if that's all you have is that drawn polyline, the answer to that question is no, there are not points at those locations. There are vertices, each one of those locations being a vertex of that drawing, of that entity, but there are no really point entities. Now you can put points on them. You can draw locate points, snap to the endpoints, and it drops a point right where it is. And if it's a 3D object, it reads the elevation and sets that into your point. Or you could even do a CAD point command and drop a point on it, but it wouldn't show up as a Carlson point. Okay, so, here's, and that talks about it down here, said, so to have points at these locations, using straight CAD tools, you issue the point command, when prompted, snap to the endpoints, and you've got a point. But then you don't notice, because if you're, especially unless you've turned on the point symbols, and that's that PD mode or point display mode. But as we work with our data as surveyors or engineers, and we want to think of those as points, we need to put Carlson points on those particular structures. And they would be, up here's that little distinction. There's a CAD point, and here's a Carlson point object, which has a point number, elevation, description, and a symbol. There's also that little point sitting right under it, and it shows you those examples right here. Here it is with no node displayed. Here it is with the node turned on with that PD mode display. Okay. So now this was something here in the book on page 12 for the IntelliCAD crowd, that there used to be a problem. I think they fixed this. But if you go to that settings explorer and look under the general category under points, this draw locate points, it used to have, so I'm going to go to settings, and I'm going to go to my settings explorer. And again, just a different interface of all the different settings in the program. So I can't shorten that window up a little bit. Okay. So I'm going to look under, and these are your different modules. So let's look under general, and let's find points. I'll collapse these guys down. See, this is basically various categories and stuff. And so I'll come here at my draw locate points. Now, right here, there used to be in the older versions, there was a setting right down here under decimals, the number of decimals, and it's right here, number 12. That's the number of decimals that right now ours are set to 2. The default is for 3, and that is the number of decimals to display in your elevation labels. It doesn't tell you that here, but that's sort of just, looking at all of just the numeric settings. Now, they used to have that set by default to this variable called LUPREC, which stands for linear units precision. And that would be the same precision that you would set in your units command, just a CAD command set units, and you would tell it how many decimals to display. And so that would be the number of decimals that the label would show. And if you didn't change the default, it would say LUPREC, and it should read that variable and set that value in the current value. The problem was it, for whatever reason, did not ever read that variable correctly. So they've now changed it to a number to start with, and it's independent of that that setting. And that setting is, if I just type units and hit enter, that's this setting right here. So see, mine now says display precision of 4. So if I look either at my status bar coordinates, or if I just do an ID for a point, you see down here I'm getting these. Or if I select any kind of data, look at these fields here for those values, it's putting 4 decimal places, and that's based on that units command. But my elevations are set for those 2 decimal points. And you could go to that, I double clicked it, go to settings. Now there's the number of decimals. Now this one is not what gets displayed here, but it's just how many gets shown up here. Okay, that's all.
So
Here is
when you
okay.
change that in the settings explorer to 2, because mine is at the default, and I
Okay.
close it, will it continue on every job when I open it, or will that be a setting that has to be changed every time?
Very good question. I think it continues. I think it sticks.
Okay, I'll check that out. I don't know if no offense.
Yeah. So now the one thing is if, and again, under settings, the number of decimals that governs what you see in this box, but it also has this elevation decimal. So I could change that to, let's put it up here to this big number here. We'll say, okay. And so now that works on an individual point basis. If I were to redraw 0.7, it would go back. To where it was. But if I change that in either in that settings dialog box, or I think can I do it here? Under draw locate. No, I can, oh yeah, right here, decimals. So if I do it there, and then let's draw them all. So now they're all at, the number of decimals that we display. And I could go into any individual one and change that to be something separate, but it doesn't fix that unless you go to your, I think it's also available under point defaults. Can you set it? No, apparently you can't under defaults. But when you go to draw locate points is where you can change that value here now with that pull down right over here under decimals. You can put that back to wherever you like it. And let's just draw points. And now that will stick until you change it there or change it in that settings box. And I think and this should answer, I'll go to that settings, explorer again, points, draw locate. So this is what affects the draw locate command. Decimals, let's put that to 5. And we will now exit that and let's draw locate points and let's see if it's changed it here. Yeah, see it changed it to 5 right there. So that links it from either location. And we just draw them all over again. That's fine. All right. So yeah, that settings explorer lets you sort of drill down into a command without having to go and run that particular command to set it. But it sometimes is a little bit less than clear because again, if we look at, here's our draw locate point command, it just says decimals. Well, that's the name of the field in the dialog box when we run this command. If we do station, where we labeled that station and offset, I don't even know where that would be. It would be under civil, possibly for sure, center line. Label, that's a right of way. I want to label or station the polyline center line. Now these are, again, just the fields in the dialog boxes. So you can see where I want to label the start and end stations, yes or no. No is the default. I had it turned on. Here's, I want to label any odd stations is on. I turned it off, that kind of stuff. So you don't really get a lot of sense of what these mean here, but it gathers it all in one place and you can do those separately. You can run a report and see, it'll just list out those for you, that kind of stuff. All right. So there's your linking. And let's now talk about the rest of this point exercise business. Now, we would normally load up this file. We're going to We could just be in any particular file. We can stay where we are. I'm just going to zoom out here, select everything and delete it all. And I'm going to now go to my points menu and I'm going to set the coordinate file. I'm going to change to a different file. This is going to be exercise 1 coordinates. I'll open that. Nothing happens here. I list my points. I'll hit all, and there they are. They are 22 different points. Notice the coordinate values are, some are negative. They were just arbitrarily done. All right, so now if I wanted to see those points, I would come back and locate my points. And now I think I turned off in my defaults to center. Maybe I still have it on. There's another little switch right here. You can fix these overlapping point attributes, and that's if points are real close together and the attributes overlap, it can go through a whole routine of sliding those around to try to miss each other. It's a pretty powerful little tool, but it takes a little processing. I generally draw them, and then I see if I got a problem. I'll come in here and just individually move something. Now, none of these points have descriptions, so that's you just got numeric point numbers and elevations. There's 1, 2, 3, 4, 5. Now you can remember from what we've been doing, if you draw anything 2D or 3D, let's draw a 2D polyline, and it says pick a point or a point number. Now you can just do, mosey your way around, and let's now start using point numbers. Let's say 1-5. So that's going to go 1 to 2 to 3 to 4 to 5. So it works with a range. Now let's come up here and go, let's say 10 to 6. So if I say 10 to 6, notice it honors that sequence and just draws it in reverse order, because I said go from 10 down to 6. So 10, 9, 8, 7, 6. So that's the real convenience, especially if you've got a bunch of points and you need to connect all that stuff up together. You don't have to try to snap to the points. You can just use the point number. And again, if you've done that, if you had linking on, and if these points are going to move, the line work's going to follow with it. Okay. So, and again, that's a 2D polyline. It's drawn down at 0. So you can see the points are up there in the air and the line's down there at 0. All right, so, and that's really the essence of this little exercise, is just to allow you to draw some points using point numbers, and 2D polylines versus 3D polylines. If I drew using the Carlson command, draw 3D polyline, and I'm going to just make it a different color. I'm going to not draw a dual 2D polyline with it, and I'll just go say 15 to 18, 15 to 18. And so there went 15, 16, 17, 18. Now, if I don't want to use a continued sequence, if I want to go say from 19 to 21 to 22, I want to skip something, I would do them just individually. 19, just individual number, and then 21, and then 22, or I could say 19-22, whatever else, and it skips that. So individual points, just a point number, enter, and a range of points, you put a dash between them. Now, used to be, I don't know that it is in Carlson. Now you can see that's 3D up at those elevations. Now, I don't know that in Carlson if it worked this way. We'll try it real quick. It might have been Land Desktop, and Frank, you can verify. If I wanted to draw, let's say from 1 to 4 to 5, let's say 1 to 4 through 8, and then 10, and then 12. So if I draw a 2D polyline, it used to be you could enter it like this. I would say 1, comma, 4-8, comma, 10, comma, 12. I don't know that that works. I think when it does it here, it thinks I'm trying to type in a coordinate value. We'll see. Oh, let me see. 1. I went from 1 to 4 to 5 to 6 to 7 to 8 to 10 to 12. Look at that Carlson does do it. All right, so again, either way, I could have done this by typing 1, enter, 4-8, enter, 10, enter, 12, enter, or the way I did it, if you can see, I'll roll this back. Right here is I did it all lined up on the command line as 1 comma 4-8 comma 10 comma 12. Now, if I were just doing that as like, here's where I think the problem is. If I'm doing a 3D polyline and I did that, if I wanted to go from 1 to 4 to 7, I said 1 comma 4 comma 7. See, that's where it read that as me typing in an XYZ coordinate. So it started me down here at X of 1, a Y of 4, and a Z of 7 as my starting point. So it didn't work in that regard because that was ambiguous to it. It's reading that as a point entry. So if I'd had one other thing, like if I just repeat that command, and I went to 1 comma 4 comma 7 and then say comma 10, then it reads it as, it recognizes that I'm not typing a coordinate, I'm typing a range, a sequence of points here. So be aware of that little distinction. If you just type a number comma number as a 2D, it's reading as X comma Y. You could even have the third one. And even though it's 2D, it would ignore that Z elevation. So that entry right there with commas in normal CAD speak, if it's either 2 or 3 numbers separated by commas, it interprets it as you typing in the actual real coordinate in the file. But
Would
if
you, can you confuse it by doing 1 and then using 4 twice if you only had the 3 numbers like 1, 4, 4, 7, where
yeah, you could, but what happens is you wind up with a vertex doubled up on top of itself.
okay,
So
that's what I was afraid of.
unnecessarily complicated your geometry a little bit. And then you could go back and, reduce vertices and all that crap. But the easiest thing to do is if it's going to be a problem, just do 1, enter, 4, enter, 7, enter, and you've done the same type of thing. So it's just an idiosyncrasy. I'm glad that Carlson allows you to do it as a series of once you get past the 2 or 3 numbers separated by commas. Now, the other thing is if let's say 0.4, let's change its point number from 4 to 4A. Okay, so now so if I draw that 3D line, if I say 1 comma 4A comma 7, yeah, see that recognizes 4A is not a CAD coordinate. It knows that's a point number. So it went from 1 to 4A to 7. So that's, a slight workaround. It's just something to be aware of, but to take advantage of if it's going to be helpful. Okay. So that's really the essence of that little exercise in the book. The next one, and we do want to go through this one, is to use point groups. Particularly those of you who do surveying. So now let me see. Oh, here's a couple of things on this next page in the book, page 14, a couple of notes here. So, and we talked about this one already. If you don't see this little options box coming up when you're drawing the command, if that had been unchecked, you just choose options from the command line, and then that would bring that back up available for you. So show options on startup, you just type O from the command line, and then you'd recheck that on there if you want that on. Now, this other one here is that we drew, I think the command we gave was draw 1 to 22. And so at 1, 2, 3, 4, all the way around to 22. Now, here we're talking about, using a whole lot of point numbers and saying, it'd have been tedious to have to pick each of those locations with a snap or whatever else. And that here's the note. Here's what this note refers to as the important thing to take notice of is right here. Even if you don't have your points in the drawing, it's just blank. If you have a coordinate file associated with the drawing, you can draw those points. I mean, you can draw the figures. So if I'm just going to come here and get rid of everything, and I'll draw another 2D, 3D polyline, and I'm just going to type 1 to 22, and it reads from the coordinate file where those points are. It's created this, but nothing has been shown here except for this one 3D polyline. Now that brings up a question. There's where point 1 was, point 2 was here. If I edit point 2, I'm going to go to my points menu and I'm going to choose edit points. So I bring up the editor. I'm going to change point 2 and I'm going to move it. Instead of 1016, I'm just going to call that 1000 in my northing. And let's call it negative 300. Negative 300. And oh heck, let's put it down to an even 100 elevation. All right, so I'm going to save that. I hit the save button and I'm going to exit it and I'm going to see save changes. Yes. Yeah, see that did not move that point. So if I draw locate my points now, point 2 is not going to be. Yeah, see that moved, but the line didn't move. Now, if I move that and update, yeah, see, so to have that linking on with link line work with points, the points do need to be in the drawing when you do it. But the fact that you can actually read points from the coordinate file without having them displayed for other commands that look for points or point numbers, is a potential advantage. Okay. So with that out of the way, let's go back and talk about point groups. And point groups is just a means of organizing our points. Actually, what we're going to do is I'll set up the stage here, and then we'll take our mid-morning break. So we're going to actually open up another file called Civil Demo, and we're going to set our coordinate file to exercise 2-point groups. And you're going to see a little small subdivision, houses and driveways and streets and stuff. So when we do that, let's go ahead and close this file. No need to save it. And let's open from our data set. Here's my data sets for fundamentals class. I'll make sure I'm pointing to the right location. And I'm going to find that civil demo. And there it is. And right now, notice up here in our title block, it says CRD none, because there's no coordinate file that was set here when I just opened the drawing file. I have to set that. So I'll go to points, set coordinate file, and I'm going to set that to exercise 2-point groups. So now you see it's up here showing you what is used. It's a different from the drawing name, so it doesn't have to match. There it is. I can even list my points. I'm not going to draw them all. So, but there they are, different types of descriptions, etc. One of the things I did want to point to is if I set the coordinate file, one of those examples in the settings is we had a little graphic preview allowed. And if I look at these, look over here at this little data preview. Now, you don't see graphics for the points, but you see statistics, the point range, the total number of points. There's 22 in that first one. There's point range went 1 to 103, and there's 15 points. That's the one I was playing around with. There's the one we're working with, 1 to 44. So if I that's another way to help you see that. So that was also under our Carlson configure general. That's it right down here where it says enable file selection graphic preview. That's what that is. Now it's not graphic in the case of points, but if I were to go to my centerline editor and I'm trying to find a file, I can select a file, and there's that last centerline that I had worked on. We did some edits to. Shows you the starting and ending station, and then it draws the actual line. Same thing would show with profiles. You would see it in profile view. In surfaces, you would see at least the boundary of the surface. Sometimes you'll see the whole thing colored in if you've got, certain colors set for your triangles and such. So that's a nice little feature, I think, to help you verify that you're looking at the right file. Again, a reason that I like to use Carlson's dialog. All right. So we're going to take a break. We'll come back at 11 o'clock, and we will go through a couple of little quick examples of using point groups, and also a couple of little edits that we're going to get into. Like, you notice there's a property line missing between lots 78 and 79. What are some techniques to create that? So we get into a little bit of survey work, like or just sometimes you can think of it as just geometric work, and how would you evenly split those two lots so you can do, like sliding side areas and hinged areas and all that kind of stuff to match, um, to split them in half, or just looking at the geometry of it. So that's what we'll do when we come back at 11 o'clock. And then we will um, start into the most important part, I think, of all this is learning how to model our surfaces and how to verify them. Okay. Questions? Anything? All
Oh,
right.
all
No.
good. Thanks.
Good for you. Good for you, Chris.
I'm all set.
Okay. Good, good, good. I'll stop our share, and I will now pause our recording. And we're going to be talking about point groups next. So as you may imagine, and you may have looked ahead, point grouping is a means of dealing with a range of points, and sometimes they're discontinuous in their range. So instead of trying to type, 1 through 50, we might have to, skip over a few in a certain range. But if the ones that we're interested in are all, common, maybe a common description or some kind of commonality that we can put them in a group, we can refer to that range of points by the group itself. So that's what we'll be doing. We've got our little drawing open here. We've got these points. And just to show you where these points are, let's go ahead to the points menu. If you've not done yet, set your coordinate file to the, right now, oh, what didn't happen? Apparently I didn't set it. Mine's pointed to civil demo, but I want to set my coordinate file to be exercise 2 point groups. There we go. So coordinate file, exercise 2 point groups. We'll see up the top. We look at our points. We've got these points. And there they are. And you see some of these different descriptions. I've got boundary points, and I've got a boundary radius point. I've got building points. I've got edge of pavement points also with some radius points. And there's more building points. And I've got property corner. So P-core and boundary would be similar. It would be property corner type points. But the boundary points are the ones all along the outside edges of the boundary. So that's what we have. And just to show you where they are, let's just go ahead and draw them all. We're going to draw locate points. We'll just put them here on label points. We'll choose this. We'll just use a generic. And notice, by the way, that, I've got some customized points that we created as blocks for like springs and, wetlands and that kind of stuff that we did for a specific project. So, and you can do that. And you've got all kinds of different categories. You can go to that community and download additional points, all kinds of different things you can do there. NCS, you see they're grouped by sort of into folders and things for the power industry, things for the National CAD Standards site points, different things that apply here. But anyway, I'm going to go back to just my standard points, and I'm going to scroll down and choose this X. And they'll go, all of them will go on layer PNTS, and I'm just going to say draw all, and you're going to see them all come in. And there they are. I've got some of these radius points are way out here. Notice that ugly text. That was that text style called PTXT. I'm going to change that. Either type style and hit enter, or go to your little explorer and find your text styles, find that. And I'm going to come over here to the font category. And instead of using TXT, I'm going to set mine up to use that Calibri Light. I like that one. There we go. So there's a bunch of points. Now notice what we've got. We've got points all along. Here's one called boundary that's on that outside boundary. Here's one called P-core, that's a property corner, that's the end of this line here. Now the reason it doesn't say boundary is because when I select this boundary line, there is not a point. You see where the grips are? There's a vertex there, that's a midpoint, and that's an arc. And it comes up here to that vertex. That's why that says boundary. And these P-core points are on that line, but they are the ends of these lines. They are not actually the endpoints or the vertices of the boundary. Those are the only ones that say BDY. All of the little intersecting property corners say that. Now, sometimes you'll get a case where they are one and the same. That is a property corner, but it's also a boundary vertex. I don't know if you got some case like that, but like here's one that's boundary, but yeah, the lot comes over to here. So anyway, these points were created using a quick Kogo command under survey. I'm gonna switch back to survey, and it's actually under Kogo, and down at the bottom it says create points from entities. And I think maybe when we were talking over our first introductory, saying hello, getting to know what we're looking for session, one of you, I think, may have mentioned that you wanted to know about how to, put points onto things in the drawing and how to get them in and out. Maybe Frank, you were talking about that, but so when you could set these points by doing a, draw, locate, and snapping to the endpoints, and work your way around it. Or you could do this one and say, create points from entities, and you could tell it to draw points or not. If you don't draw them, they just go into the file. Separate layers or not, locate on the real Z or not, prompt for elevations, all the things like draw, locate does. And then you're going to put them on things that you select, geometry that you select out of the drawing. So you could put things, let's say, I'm going to put them on this little stream center line that runs down the road here. And let's see, let's put these on, let's see, same description for all points. We'll call that stream. Let's see, that should be fine. We'll say, okay, let me change the symbol to be, we'll just use a plus instead of an X. All right, it's fine. So stream will be the description, or you can ask for a description at each point. We'll just use the same description. We typed it in, called it stream. We'll say, okay. Which entities to process? Well, whatever it is you're trying to find, you can have points, faces, inserts, that's pieces of text. So you can find the insert points of text or blocks, circles, centroids of polylines, etc. skip radius points if you're on an arc if you want, skip midpoints if you don't want to put midpoints on, otherwise it drops a point there. Avoid any duplicates, draw the new points, and draw any existing points that match. So I'll say okay, and now it prompts you to select the entities. I'm just going to select this stream right here and hit enter. And so there now you can see the points along that polyline. It also happen to be where the contours cross, and that's just the way they created the file. And this happens to be a 3D. I look at my vertices here. I'm at vertex 1, which is up here, and that has an elevation of 841, 40, 39, 38, and then 37 and a half.
What command was that under again?
That was Kogo, create
Kogo.
points from entities, okay? Now, notice I did not see any elevations show up there. Okay, the point still has an elevation, but it was set to not display the label. So I'm going to just edit these particular points just by double clicking them and setting the label. And that could have been, you know, we could have prevented that. Or I could just redraw those points. That'd be fine too, either one. And then finally, there's the labels. That happened because under create points from entities, I said, draw the points, use that symbol, no separation, elevation settings. I didn't have this checked. I should have had that checked right there. If I wanted to see them, that would have done it. Okay. So, so there's our points. We got a bunch of points. We look at those points in our list. We'll look at all of them, and you can see all of those, and down at the bottom, you'll see those string points have been created. Okay, now let's talk about point groups. First of all, to unclutter our drawing, I'm going to go to points menu. I'm going to erase points. Do I want to select them from the screen or use a group or by point number? I'm just going to say take them from the screen. I'll just grab everything here, hit enter. And now it says, all right, do you also want to delete those from the coordinate file? I'm going to say no, keep the points in the file. And then, well, of those you selected, do you want to delete the symbols or the attributes or both? Let's take both. So now they're all gone from our drawing. Okay, they're still in the file. And so let's go to the points menu now, and let's choose the point group manager. And here we've got a little dialog box, and it's got little menus inside. I can create a new group, edit the group, delete, copy, import, and from points, insert into drawing. Once I have these groups created, I can then just by group name, put them in the drawing right straight from here, draw a 2D polyline, draw a 3D, you know, all these different commands that I can do, export them into different files. These buttons down here also do the same thing. There's create a new group. So let's create a group, and let's just do, we'll call this group name, and we don't need to do this, but just to show you, let's just call it all. And for our description, that was all points. And we've got two choices, include or exclude. So I'm going to include all, checked on. I'm going to exclude, there's no extra filtering. And I'm just going to save. All right, so there's now all, and that has all my points in it. Let's create a next group. Let's create an exterior boundary group. So I'm going to call this one EXT space BDY, exterior boundary. And you don't have to give it these full description. You don't have to give it anything at all if you don't want. So now I'm going to uncheck include all, and I'm only going to include certain points. Now I'm going to do this by description. Notice you can use elevation range, make them from a list of points that you just select manually out of your list of points. But I'm going to go by description. And you can set by selection. If you had them out in the drawing, you could pick one of the points and it would read that description and put that here. But I'm going to set from the list because I don't have them in my drawing. And remember, I had some of those as boundary points and some of them as P-core points. So those are the interior property corners. So I'm just going to choose BDY. If I say that and say OK, and then save, now I've got exterior boundary points, and those are all of those BDY points. You see them in my list here. Now to edit that group, either hit that button or just double click the group name, and it's right back where you set it. Now, if I put BDY asterisk, that means any description that starts with BDY and ends with anything else, and that now also gets my BDY rad points, okay? So this is responsive to wildcards, and you can put them anywhere in what you're doing. So if I had like a description called EXT BDY and had another one called INT BDY, I would put, you know, an asterisk in the front, and then it would find any point descriptions that start with anything but have BDY in the middle, and then you can put anything after. So the two wildcards that it works with are asterisks and question mark. And a question mark means whatever this description is, and then there's a space, RADPT. So they're placeholders for anything that happens after that. So if you look at that, I've said, all right, BDY, and then things that have anything that fill out those little placeholders for that those additional characters, 5 or 6 question marks that I put in there. All right, so the wildcard issue works. I could just put BDY, which is what I really wanted, and save. Now notice you can type those in there. You don't have to pick them from the list, but you got them. There's my exterior boundary points, okay? Now, let's make another group, and let's call this one property corners. Prop core. Those would be my property corners. And I'm going to uncheck include all, and I'm going to, by description, set from the list, or I could type since I know what it is, but I'm going to set a BDY, and I'm also going to scroll down here and set P-core. So I'm going to control click, so that gets me both of those selected. There's BDY and P-core. And I'll say okay. So now you see it puts in there BDY comma PCOR. I save that and I look at my property corner list. Well, I've got all the boundary points, which are also property corners, and P-core, which are those, because those are all of my property corners. So even though exterior boundary, these points 1 through 15 are in exterior boundary, they are also in property corners. So a point can belong to multiple groups. It doesn't matter. I'm going to now create another one. We'll call this one house corners. Let's say it's house corners. Uncheck the include all, check that, and we'll select the building. There's one, just one of those. You only need the one, doesn't matter. And if I look at that list again, make sure there's nothing else. There's building. Yeah, I don't have any other building. I'll say okay and save. And I'll create one more group, and I'll call this one road points. In my road points. Uncheck include. Under description, I'm just going to type EOP. I'll put star so that I can get the radius points if I need them. So there's EOP and EOP rad point. Okay, so I just typed it. You can do it either of those ways. Now, that's all we really need for that. One of the things you can do is under include and exclude, you can start with an include all condition and then go to the exclude and say, well, I want to do everything except my building points. And then this would be, you know, all but buildings. Save. And now all but buildings, you see I've got every one of those points in there except for the BLDG points. I've got stream points. It reminded me I need to create one called stream if I wanted to do that. And just come down here for a description. I know what it is. I can just type it and save. So now I've got all of these different groups. Now I can do things like exterior boundary, and I can go to my points and I can say insert into the drawing. If I do that, there they drew the points, I'll say okay. And now you see the points are drawn there. Okay. Let me go back to points, erase points from the screen, all. Finish my selection. No, don't delete them. Erase both the symbols there. Okay, so we've got that done. Now, what else can you do with these? If I go to points and I list my points, let's say I needed to list my property corners in a table over on the side. So my range of points, notice I've got this point groups. If I click that button, or if I click this button, I can select them out of the list of points. But if I click point groups, these are my boundary points or my property corners. Okay, so I'll say okay. And you can even filter that group based on a description. So you could, you know, further filter it based on this group, but I'm going to take all of the points that are in this point group. I'll say, okay, there now is my report, includes the boundary points and the property corner points. I could then, you know, dump that out here to my drawing down here and you know, and again, right now it's just a piece of in text. You can edit that and, you know, change the fonts and change the, you know, I can delete that and, you know, do everything with that you would typically do. Maybe get rid of these lines, you know, maybe underline your headings, just, you know, whatever you wanted to do with that as a listing for your coordinates. I would probably, you know, set my decimals down to 2, and I would, now in this particular case, I'm not sure if these would all, yeah, it looks like they would all. So I'd have to go in here and, you know, sort of scooch these over so they line up on the edges. So it's not really using tabs. You see, if I go here, they're just spaces. So, yeah, you can do a couple little things there, or alternately, if you list your points, do a group, it's already pointed to the group there, it's still the same. But down here at the bottom, I'm going to say, let's use the report formatter. Okay, and I'll say okay. And now I'm going to get point number, northern, eastern elevation, and description. That's going to be how they list. I can display it, and there it is, my headings over what they are. I can look at it as a spreadsheet. I can export that then to various formats, including Excel, or I even have a, I think I've got, yeah, I've got an Excel tab. So I can create a new spreadsheet, and I'll just export that, and it's going to go out here and actually put it into Excel for me. So there's all kinds of ways you can do that with differing you know, different settings on whether you're using the report formatter, and I'm going to, don't save that, or just using the standard report. So when you, if you run that report again, now it still sticks with that report formatter. So if I just want to use the report viewer in Carlson, I'll uncheck that and come back to where we were before. Okay. So a number of options there on any of your reports, and that's true for any reports that you have. Now, what else can you do then? You can go to points. Let's go to coordinate file utilities, and that brings up this little guy. And the buttons on the left work with the file itself, the coordinate file itself, whereas the ones on the right tend to work with individual points and groups of points. So I could list the points, delete them. What else can I do? So I can set descriptions. So if I wanted to set descriptions for that prop corner right here, which are now BDY and PCore, I would say, choose that description, and then I would give it a new description, and it would go into the points themselves in the coordinate file and change those descriptions to whatever I type here. Okay, and you can do either add that as a prefix, replace it, or append it as a suffix. So, if you added that as that, you would say corners dash, and you apply that. Now, also you could, if you had them drawn in the drawing, you wanted to update the drawing description, you could do that as well, but you could apply that. And now I've updated those 36 points. I'll exit. Let's list the points now. Let's just list them all. And you'll see I've got corners dash boundary. Now, boundary rad point was not included in the group, remember. The radius points weren't, but the boundary points were, and the PCore points were. So that is how that part worked. Okay, different things you can do with the group. You can also, let's say we wanted to stake out the houses. Now we've got all the building points and they're all just dropped on the building corners. So if we wanted to stake that out and send that out into the field, and we didn't want to bother with those extra points for them, we could export a text or ASCII file or import and export coordinate points. So if you do the import, if you do it as a text or ASCII file, you can choose these different formats. User defined, you can tell it how it wants to go, okay? But if you, instead of doing that one, if you import export coordinate points, you can export points from this current file. So if I do that, now this is going to keep them as Carlson points. So I'm going to export this to a new file, and I'm going to call this house points for stakeout. And I'll say, go ahead. And now what do I want to do? I'm going to choose a group. I'm going to choose my house points, house core, say okay. And I can add a certain range to the point numbers. Let's put 1,000 on all those point numbers. You can store, merge, and all kinds of stuff. But it's just going to be I'm going to export them to a new group. I can even create a point group from whatever I choose here. I've already got the group, so no need. I'll say okay, and now if I'm looking at exercise 2 point groups, that's still the same, but if I open the coordinate file that I just made, house points for stakeout, and now list those points all, there's all my points, my building points, and they start with 1016 and go down here to 1144. So those were the things I can do with that group. I'm going to exit that. I'm going to now go back and choose my exercise 2 point groups coordinate file. It's now sitting here open. So those are a number of things that you can do with those groups. You can even do this. Let's go ahead and just exit this. And again, you can update the drawing from the coordinate file. That's the same as we're going to do here at the next little step. I'm going to exit that. And let's go to the points menu and draw locate points. And here's a little trick for you. I want to draw the property corners as little circles on all of the property corners. Okay. To do that right now, I'm going to change this symbol. So I'm going to hit my set button, and I'm going to use that circle for a property corner. But notice one thing here, if I do just the circle, it's going to draw the circle and you'll see the line work under it. But there's a category up here called points plus wipeout. So these are going to be points that have a wipeout as part of that block, and it's going to hide the lines over top of it, or the lines underneath it. So it looks like I've trimmed off the line work on the edges, but I haven't really. They still go to the corners. So if I do that, and I'm going to put these on a layer here called P-Core for property corner. I'm going to use that symbol, but I'm going to not draw the descriptions, not draw the elevations, and not draw the point numbers. I'm just going to drop circles on a layer called P-Core, and I'm going to draw a point group of my property corner group, what happened to my group? Property corner, something happened to my point groups. Let's go back to point group manager. I think I said that. Well, that was interesting. Oh, I remember I put that prefix on those. So that was, let me see, what was that called? Corners dash. Okay, so I'm going to put a corners dash. So there's now my corners boundary. Need to also get, let's see, corners dash. Just make that star. Save that. So now I've got corners BDY and corners P-Core. There we go. Now I've got that. My exterior boundary is going to be start with anything, end with BDY. And now I've got my corners BDY, no radius points. Anything else I screwed up here? Let's see. Nope, we're good to go. All right. So now there's my group. Let's go back to draw locate points. We've got everything set before. We've got our descriptions off, our elevations are off. And if they do have elevations, I'll just put these down at 0. So I'll uncheck the locate on Z, uncheck my point numbers, put it on this layer, and I'm going to draw the group called property corners. I'll say, okay. And it did it right there. They are. And now our circles look like stop signs because of that little view res variable. It's setting down to 100. I'm going to set it up to 20,000. So now they look like circles, and you can see the wipeout, which can't be circular. It has to have segmented pieces. That's just the way the CAD system works. But you're seeing the actual frame of it. So I'm going to do another command called wipe out F for frame, wipe out frame. And there's 3 choices. You can set it to not display, or you can set it to display and not plot, or you can set it to display and plot. So if I just make it 0, and then do a regen all, REA, and then it turns those frames off, even though they're still there, okay? So when I plot this drawing, it's going to have all my corners, which are right now, because my P-Core layer got created from the last layer designation. I'm going to change its color to be white here. So there's now all my property corners are set based on that group. Now notice there's one here because that exterior boundary has an arc that ends here. So this part of lot 81 has an arc portion and then a tangent portion right in here. So indeed it is a property corner, even though there's no interior lot line going to it. So that's another creative use of your point groups. Now, one thing too to be aware of, when these lines or when these points are drawn, they're the last ones drawn, so their order in the drawing is on the top. If you do something that modifies, say, this line here, let's maybe simply change it from a continuous line style to, let's use this border line style as an exterior. And let's do its line weight, give it a little thicker line weight so you can see it here. And then I'm going to double click down here to turn on my line weights. So that might be my exterior boundary. Now, look what happened. Well, in that case, it didn't. But sometimes you'll run a command if you've modified the geometry of it, and the points no longer look like they hide the line underneath it. That's because this got placed on the top. So all you would do is if you select one of your points, right click and choose select similar. So it's going to find all of those different points along here. And then you can right click and choose draw order and bring it to the front. So that now puts them back over top of that line. Now it doesn't do it by elevation, it just simply does it by the order in which it is in the drawing. So if it's frontmost, that circle and the wipeout that's part of it will display over top of the things that are underneath it. So it looks like you've trimmed out the line work, but you haven't sacrificed the actual geometry. That used to be the way we would do it. We would use those to trim and then trim inside the circle, which ruins the lengths of our lines and makes them discontinuous. So there we've got it. Now notice right in here, this one didn't draw. That's because that was left out of our coordinate list. It's not there. So what would you do to fix that? We actually need to create a point, and we would go to draw locate point, and we're going to snap to that endpoint. We might as well keep that same thing there. It will take the next point number, and I think that'll be good. Go in that layer. I'm going to give it a description, no elevation. We use the point number, and we got the symbol. I think everything's good to go. And I'm going to now just screen pick. I'm going to snap to that endpoint. And we need to call that, let's just call it P core. Okay, so it put the symbol in place. Now hit enter to finish that command. Now let's go back and look at our groups. And because our property corner definition said anything that starts with corners dash anything. Now I didn't have that description here, but if I do in here corners with anything, comma, P-core, I've now, if I look at my property corners, I see corners, boundary, corners, P-core, and I should see that last one right there. So that's now part of that group based on that. And at this point, you can, if you want to not have to redraw that, you can go to points and you can erase those point attributes, and it just erases them out of the drawing. It leaves you with the point. You could have frozen those layers, but you might need those layers thawed for some other purpose. Okay, so a couple of things, ways that you can do these. And these points were created, by the way, just like I said, from this create points from entities when I first set this up and created the coordinate file. Now you've got road points, which are all along the roadway here. They're not on the center line, I don't think. So if I draw, locate, I'll go ahead and turn on everything here. Let's set to a different symbol. I'm going to go back to my standard points. Let's just choose a plus mark. We'll put this on road points. And we'll draw a group. And there are my road points. Say, okay, now that gets the radius points as well. So the road points are around this blue envelope. They're not on the center line geometry, which is where you would typically expect them to be. So you could, just create point entities and put them on the center line and call those a center line point group. Same type of thing. So I do have this point because it happens to also be the radius point of this geometry that was created. Okay. House points are there as well. I'm going to now go back to erase my points. This time I'm going to erase by group. And I'm going to choose those road points. Say okay. Delete from the coordinate file. Nope. Delete point symbols. Yep. Now they're cleared out of my drawing. I'm ready to go to publication with my corners all set. Okay. I'll save my drawing. And now we need to talk about what happens in here. Why didn't that 78, 79, that line is missing? So there's a couple of ways to create this. If this boundary here, if that arc point ended right there, I could use its midpoint. Otherwise, its midpoint is way over here. So I really need the middle of this piece of this arc to connect up to the middle of this piece of this arc. And you can see how that arc goes all the way over to here. So I can't really use those midpoints, but you can do a number of things. You can simply draw, and let's just, we'll change the color here. I'm going to just draw a couple of 2D polys. I'll repeat that command and go from here to here. And then I could draw one more time. I'm going to snap to the end point of, the midpoint of that line I just drew to the midpoint of this line I just drew. And then I'm going to trim and extend. So I'm going to select that line, right click and trim. I'll get that guy, trim him off. Now I'll come over here and I'm going to shift. Well, no, I haven't selected the other one yet. So I'll select that and I can extend that line there. Okay. Then I would delete these two little guidelines. And I want that to match that. So I've got a tool for that up here in my toolbar that says match properties. And that's on my standard toolbar. And it looks like a little whisk broom. And it's also available under edit, probably right down here, match properties. And something else to point out here on this menu while we're talking about. When you see these commands listed in your menu, notice here under tools, I've got these different things here. 4 of the 5 have little icons next to them. This one does not. If you see an icon next to a command, that tells you, and here's another under erase. See, I've only got 3 and there's the delete. They don't have icons on them. So when you do see an icon, that means that it lives on a toolbar somewhere. It doesn't tell you which toolbar it's on. Okay, but I'm going to choose match properties now. And it says select the entities to copy from. So I'm going to select that guy. Select the entities to copy to, or settings. And if you look at the settings, you can tell it what properties you want to copy. So I'm going to have it match that one. So now that is on the same layer, same weight, same line style, et cetera, et cetera. I would then need to add these particular points. I'm going to draw locate points, and this time I'm going to put that again on layer P core. I'll set my points and wipeouts and use the circle. I'll not use description, elevation, and point number. I'm going to screen pick. I'll pick here and I'll pick here. So now because I didn't prompt for elevation, they didn't draw. but I can come back and just double click. Oh, sorry, no, it didn't do what I was expecting. It actually did not create a point. It just dropped a symbol in. So let me take those back out. And let's draw locate points again. So what I needed to do is I still needed to give it a description or at least a point number, something that makes it into a point. I'm going to screen pick now that. I'll give it, there's my description, P core. I'll go there, same description. I'll now finish the command, erase my point attributes, take them out. But 151 and 152, if I go back to my point group manager and I look at my property corners, you should see them now in our list because our definition said use that comma P core, and it automatically joins that group based on its description. I didn't have to come back and add it. It automatically did it because it met the requirements. Okay. So that's one way to do that. Another way to do that division line, I'll just keep the points there, is if you draw a line, let's draw a, well, first of all, let's set this to be our current layer. So I'm going to, I'm not sure where it is under the menus, but on my toolbar, I have this little command under my entity properties toolbar where you can pull this down. I've got this button called make object layer current. So if I choose that, I'll now pick that. So now that's the layer. I'm on layer lot lines. And so now if I draw a 2D polyline, instead of this green and everything, I'm going to use the current properties. So I'll say, okay, and I want to go from the center of this circle. And if I had that radius point plotted, I could just use that point number. But I'm going to come up here and grab my center point. It's on. So if I go to the center, now it's finding the midpoint and the endpoint first. So I need to choose specifically the center. So I'll go here, and once that word pops up, it actually starts from the center of that point, from the center of that arc. Now these arcs happen to be parallel or concentric rather. So it wouldn't work if the geometry didn't work out, but I want to draw from that radius of this point. If I want to draw up to this arc, I need to draw it perpendicular. So I'll draw it perpendicular to that arc. Why is it giving me that? If I'm perpendicular, no perpendicular found. Is that a 3D? No, it's an arc. All right, so if I draw on my 2D from the center of this arc, and I want to draw perpendicular to this arc, why is it not finding that? It's strange. If I draw from here, perpendicular to that arc, see, it finds it. Okay, I think I know what's going on. So when you draw like that, for whatever reason, this is probably an IntelliCAD thing. So I'm going to draw from the center of this arc. I think we have to be able to see that starting point to then be able to find this perpendicularity. There it is. Well, and to be able to see it, that's inconvenient. Perpendicular, there it is. So it now found the perpendicular midpoint. Those things may not be concentric after all, come to think about it. Okay, so probably not a good, wait, if those were concentric arcs, here I can test it and I can, yeah, see, it looks like it's supposed to be. Well, let's see, let's draw again. Let's go from the center of, whoops, from the center of this arc of itself to perpendicular of itself. No, see, it's not. Yeah, that's really strange. It should snap right to that location, but apparently it won't do it unless you are you have that starting point visible on the screen. And then it's not. Yeah, so that should be the radius point. It should jump into the, well, actually every point along there is perpendicular. I'd say there. Anyway, something about the geometry there is not working out. All right, so we did that by drawing those two little guidelines and snap midpoint to midpoint. There's another sort of way you can do that without having to draw the guidelines. If you draw a 2D polyline again, we want to find the midpoint between these two corners, okay? Not the midpoint of this arc because it goes on over. So instead of drawing the lines and snapping, we have one of our snap options is mid between 2 points. So it's going to prompt you for the point. So I'm going to choose that. And I'm going to start from this point to this point. That's my ends. So that's now the midpoint of that connecting line. And I'm going to draw that up to, again, midpoint between 2 points. I'll grab that point and that point. And now you're back to needing to trim and extend just like we did before. And you can do that by grips, or you can do that by, however you, if you do it by grip, you have to make sure you're on that extension, and then you would bring it there, or you could do it from intersection, that kind of stuff. You could now do this extend. Let's get on there till we get the extension, and we want to, find that and extend it out to where they intersect in the middle. So now again, there's a case the line's over top of the points. So I'm just going to select that point and that point, right click, draw order to the front. Okay. So that's a number. Now there's a number of ways under the surveying tools that if I had this as a singular lot, a singular fixed, singular polyline, an enclosure that took both of those 78 and 79s. So if I did this, I'm going to isolate the lot line layers. So I'm going to view, isolate layer, which is right here, and that's the icon that's up here. It's in my layers toolbar. So I'll isolate the layer, and I'm going to isolate this and this. I think that's the same layer as that, but just in case I get them all. So now I've got those layers. Now this layer is lot lines. This layer is perimeter, and so is this perimeter. So really, I want to change this layer to, I want to call that's my road footprint. That's the grading outside of that road design. So I'm going to make a new layer and just call it grading footprint. And I'll keep it that same color. Say, okay, I'll now select this and call that grading footprint. And now I'll restore the layers back and I'll re-isolate layers, and I want to get the perimeter and the lot lines. All right, so there we go. So now what I want to do is split this line or split this lot into two equal halves, and that would be something on our survey menu, in our survey module rather, and we go to our area layout, and we can do that by, let's see, we want to adjust areas using a sliding side, well, that would be perpendicular, or an aerial radial from a curve. Let's do that. We define the area by points or by a closed polyline. Well, let's choose points and see if we can do that. So here's our first point. Curve, for a curve to radiate from, let's see. Enter for curve to radiate from or next point. So let's choose enter to be that curve to radiate from. Select the curve to radiate from here. Point that defines the direction would be here. We don't know the units. Let's see. Let me try that. Adjust areas, radial from curve. Select by points. Let's choose that point. Curve, pick a point on the curve. Let's turn my snapping off. Take the endpoint of that. No, okay, I've got to define the curve, and that is from there. Okay. So let's repeat that command. We'll do it by points. There's our first point. And we'll do curve. The point on the curve is end point of here to the end point of the curve, which will be here. And now the next point would be here, another curve, and that's going to be the end point of here. Whoops, sorry. One more time. So if I do this by points, I'll start here, do curve, point on the curve, I give it my endpoint, and my end of the curve is this endpoint, okay? Now there's my next point, and again, another curve, point on the curve is this endpoint. The endpoint of the curve is now that endpoint, and now the next point would be here. And now the curve to radiate from, if I hit enter, I will radiate from that curve. This is not, sorry, 10,000. Yeah, I'm not, I'd have to look up the help system on that regard. If we did a sliding side, bearing area cutoff, nope, sliding side area. let's do this. I want to create a closed polyline. That may be part of it instead of trying to define it by points. So if I wanted to create the line, a closed polyline that follows this geometry. Remember we talked about on the first day the difference between draw shrink wrap, which was the outside in, and the draw boundary poly, which was from the inside out, like we're doing a hatch. So let's draw a boundary polyline, and we will just keep it on the current layer. We'll say, okay, we'll click in the interior. So now it has created a closed polyline here. We'll give it a different color. So we can see a different color, different weight. All right, so now that, and let's find out what that area is. So if we look at that area, single area, we select it here. And we put it up here. That's 25,900 square feet. So half of that, half of 25 is 12 and a half, half of 900 is 450. So that'd be what, 12,950? So that's our target area. Now, if we do our adjust areas, let's do a, if I do a sliding side, it keeps that. If I do a hinge side, it holds that. Still needs to be radial from curb. Want. So if we select by line work, target area was 12,950. Draw areas, let's just use the sidelines only. Square feet. Say okay, select the curve to radiate from. There. Select the back polyline, which is that. Selected the wrong line here, 12,950. So select the curve to radiate from that curve. Select the back polyline, which is that line. No. Well, anyway, I guess we could look that up and figure out how to do it. That's actually part of our survey exercises where we could, split that in between. But you could do it geometrically like we did it before earlier, just going to those midpoints and creating that line. I don't know why radius didn't work. All right, so now that I've got this as a figure, the other thing that I can do is, if I draw that as a 2D polyline, now I can use midpoint to midpoint because those arcs end where they go. I can now get rid of this line, restore my layers, and now you see it's right where it's supposed to be. Again, selecting my points, draw order, bring them to the front, and that has now set that up. I'll delete that, and let's one last little bit of isolation. If I did an area layout area by interior point, I'll pick a point here, and there's that 12,950. Keep the closed polyline, nope. And then I could just keep doing that for each one of these. No, and then here's another one that'll be, looks like they're all sort of 12,950. Now, obviously this one's going to be slightly different because it's a little bigger line, but these three were all those kind of things. And so we could go through and label that accordingly. I'll now erase, and I'm going to choose my selection with an F, meaning draw a line through, do a fence. So I didn't have to window, I could just do a selection different way. Restoring my layers, and we're again good to go for publishing our map. Okay, so that should get us now where we're going to jump into the really fun stuff and model these surfaces, and then we'll go through that putting it all together exercise where we work on that workflow. Okay, so you can save that drawing here if you want. We'll break for lunch, and in keeping with our, let me just go ahead and stop the share here. Keep with our intent to try to squeeze in some more content. Let's go ahead and come back at 12:30 if that gives everybody enough time. That's not your full 30 minutes, but is that okay for everybody?
Yeah, that works.
Okay, so we'll see everybody back at 12:30. Chris, that's good with you?
Yep.
Okie doke. I'll see you at 12:30. And we're going to talk next about my what I think is probably the I get on the right. There we go. What I think is going to be probably one of the foundational skill sets that we really need in working with this software. So starting on page 18 is the discussion about terrain modeling. Now, what we've got in here is a discussion about how we model terrains. Now, first of all, let me find out, Frank, I presume you're probably fairly familiar with the process. You understand what break lines are and things like that based on the fact that you've used Land Desktop?
I do, yeah. I'm familiar with the everything on that part for a while.
Okay, so you're good there. Now, Chris, I'm wondering if you're familiar with this process, or is that maybe part of what you came here to learn and find out about? So I need to sort of adjust my levels.
But yeah, I don't know what's going on here.
Okay. All right. So Frank, we're going to go over some old ground here for us. So what we need to do to create terrains or surface models, and I'll leave this reading to you on your own, but this basically tells a little bit of the process, and it extends down through here in the modeling process. So it's only about, 7 or 8 pages. And it's, I mean, their entire college courses on this single topic. So, it's really sort of condensed. But really, what it is that we're trying to do is we are creating a data structure, a surface file that is composed of things we select from our drawing that represent some surface. In our particular case, let's focus right now on building an existing ground surface. And what we would do with that surface then is maybe hand that off to the design engineers and say, okay, here's where you're starting from. Use that, and then you're going to do your design, and you're going to make your separate surfaces, and then you're going to compare the two, and that's going to give you, earthwork volumes and differences, amounts of cut and fill, all those kinds of things that we're working toward. But how we do that is through a process called triangulation. And that is talked about right up in here, that this is a process here called triangulation. And what that means is we're going to use triangles to represent little facets of that surface that represent, in our case, the ground. It can be anything, a building, whatever, but those are going to be little planes in the surface. And we use a triangle because it takes 3 points at a minimum to define a plane in space. So any 2 points will define a line, but 3 points, if you consider them together, will define a plane or a piece of a plane in 3-dimensional space. Okay. you then stitch all those triangles up together because they all match on all their edges, and each of those individual planes joins together edge to edge, and you get the entire site. And so it makes a fabric of the data. So if you look at this little picture here, I've got 4 points of elevations: 100, 110, another one at 100, another one at 110. So what is the elevation, say right in here? Well, we look at it by inspection and say, well, that'd be somewhere around 105 because it goes from 100 to 110, okay? So, you know, that would be okay, but the whole point of making this fabric is so we could take any point in between anything that's drawn in our drawing, and we can query that surface and find out what that elevation is supposed to be because it has defined a plane based on these triangles that form, okay? Now, in the case of these 4 points, these surface models are created from anything that you select that has elevation, assuming you've got the ignore zero switch turned on. So anything that has elevation on it and forms a point, whether it is an actual point entity or a Carlson point, or maybe it's just a vertex in the 3D polyline, any of those things are candidates. And it also considers line work that we have previously drawn into the model that represent, a line of just continuous linear change in elevation. There's no ups and downs in between it. Otherwise, it would have additional vertices along that line. So what happens is it looks at each of the points and it starts to try to create these triangles. It does all this in memory. So if it sits on a point, it knows its elevation. It's going to look 360 degrees all the way around itself, and it's going to find other points. And it goes, oh, over here's one at 110. So I'm going to assume that if I'm standing here at this northwest corner at 100, I look over here and I see this point at the northeast corner, it's at 110. So I'm going to assume that a line between those 2 points represents that continuous linear change in grade. So midway up that line is 105. And I keep looking around and look and try to connect up to other points. Now, once it connects a line, either in memory or if one's previously drawn in the drawing, if it hits that line, it can't go past that line. That's called a break line. That's going to break our triangulation. That's going to keep it from looking across and seeing it. So in the case of, let's say these 4 points and there's no lines drawn yet. And so let's say we're starting down here at this point 110 in the southwest corner. And I start looking around myself. I look up here and I see this point of 100. Okay, I'll draw that line. Halfway between is 105. And I keep looking around and I see, okay, here's 110. And so I'm going to, now they have to be the same elevation. So I'll connect that line. So that's that elevation all along that line. And it keeps looking around and it sees this point over here in the southeast corner at 100. So it draws that line and assumes that the, halfway down is the 105. So now I have drawn this left edge, this middle diagonal, and this bottom edge. I go to the next point. Maybe I go up here to this point. Now, again, all this is happening in memory. The computer's doing it. I start looking around. I see this 110, so I can connect that line. Okay, I start looking around. I could see this 100, except for the fact that this diagonal line was created when I was down here on this point. So I can't see past that line. I can't see anything on the other side of it. So I don't draw a line across there. So I keep looking around and I see this point down here. Well, it already drew the line when I was standing down here, so I don't need to connect that. And it would keep looking around and connect to other points out here. So it does this all around and following certain algorithm called Delaunay's criterion. And so if this triangle edge here gets formed first, that prevents this point 100 from looking over here and seeing this point 100. But consider this. If I look on the next page here, these are those same 4 points. But what if I started over here first, drawing my points? I look up here, I see that point, and I draw that line. I look over here to see this point, I draw that line. Look up here to see that and draw that line. Now, when I get to this point, I can't see this point across from it. I can't draw that line anymore. So these same 4 points could form those 2 triangles, just like these points formed these 2 triangles. So the diagonal either went this way or that way. If I have these 2 triangles forming like this, what does this look like on the ground? It looks like a ridge line at elevation 110 that falls off to the northwest and drops down to a point of 100. It also falls off that ridge line to the southeast and sets a point of 100. However, if I look at this version of it, where that line formed first, I've got this line across here that is the bottom of a valley at elevation 100, and it rises up to its left or to the southwest and has a high point of 110. It rises to the right or to the northeast and has a high point of 110. So those 4 points could form either a valley at elevation 100 or a ridge at elevation 110. Now, obviously, only one of those conditions is actual out there on the ground. And so what we need to do is, when we're surveying, for instance, is we need to recognize the fact that, if this is indeed a ridge structure, we're going to pre-draw this line along the ridge top so that we keep any points on this side from looking across and finding points on this side and forming triangles. Conversely, if we had the fact that it was a valley, we're going to connect those all in the center line of that valley so that these high points on this side can't look across and connect to high points on that side. So we have to pre-draw that line that we want to use to correctly model our data. Now, a lot of people who do this and don't understand that concept, they think that, well, if I just get, a couple hundred points along this line down here, that's going to make all my triangles form down to those points. And sometimes that'll be correct, but it's just luck. It's just pure dumb luck that you won't get one that jumps across. It just depends on the order that they're processed in. So that's why we pre-draw them. And here's a perfect example. I use this all the time, is when you're doing something like a curb structure. Here I have all these points that I surveyed. I've got A and B that are on the edge of the pavement, C and D are on the gutter line, E and F are on the top of the curb, and G and H are on the back of the curb. So to come back in from the field, having only brought in the points, if I haven't connected lines through those points, I run the risk of having a triangle edge form from A to E, which would essentially fill in the gutter, all right? Same thing from C to G, that would chop out that top part of the curb because we're telling it that it changes from C to G. And if we haven't drawn this line in here, we run that risk of creating triangles like this. And again, a lot of people's approach is to, well, let's just come down here. I'm going to get the back, the top, the face, the edge of pavement. And then I'm going to go up here 25 feet, get the back, the top, the face, and the edge of pavement. And they usually luck out because they're clustered here and they'll form correctly there, maybe up here. But again, it's just pure dumb luck because it doesn't guarantee that you won't get these things from happening like this. So what we have to do correctly, we get those points, we recognize what structure they're on, and we draw the lines in between. So we draw a line that goes through A and B, we draw a line that goes through C and D, a line that goes through E and F, and a line that goes through G and H. And with those lines in place, then when we tell it to triangulate point B, if it's looking around itself, it can see point A, so it draws that line. It can also see point C, so it draws that line, but it can't see point F or point G or point H because there's a line there and a line here. It can't cross those to see those other points. So that forces the triangles to lie in the planes that are defined by that line work that goes through those points. And that line work has to be three-dimensional, by the way. It doesn't work by proximity, Frank. If you recall that from Land Desktop, I think you could use proximity break lines.
You could, yeah. I didn't use those that often though.
Yeah, so so just keep in mind that we have to elevate those lines to go through those points when we're creating our break lines. So and that's really the essence of everything. It looks at all the points and it looks at any three-dimensional line work, including the vertices along those lines in case they're not surveyed points, but you've, modified them or created them or whatever. And those are then going to form the corners of all the triangles that form. So another example, let's take see if I can find a picture of just some contours. Okay, here's an example down here, and you'll see this in our data file. Here's a file of just some drawn contours. Okay, and so what happens is, and we can use contour lines to define a surface because they have elevation, but everything along each of those contour lines has the same elevation. And so what happens as let's say I'm stepping on this light green line right here. I'm at this point. Well, I'm going to look around and maybe see this point, and I can create that line. That's fine. I see this other point here. It's already drawn as an edge there, so that's going to be okay. But this line being between these two lines keeps this line from looking across and directly connecting to the other line. That's fine as far as that goes. However, when we get to a place like right here at the crown, or especially over here on the curb edges, if I come down here and I see this point and I see this point and that point, and I'm looking back here and I'm making those triangles, those are all good. But when I get here and I'm looking around myself, I can look over here and see another point on that same line. So it's going to possibly connect a line in there, but that has the same elevation as where I'm standing to evaluate. So I've got an edge there, an edge there, an edge there, and I could also create an edge across. So I close off that little feature and I say everything along that line has the same elevation. But we know, because of the way the contours are shaped, that if this road is running downhill, then I know that right in here is actually lower than up here on the contour line. So the line connecting these 2 points across that V shape, if I say that's the same elevation, well, it makes that entire triangle in there flat, that same elevation, but it's not. It's supposed to be lower down here. So I need to create a line from this peak down this way to this peak or whatever else I can connect and say that's how it changes. It goes from that elevation to this elevation. So midway between the two is the middle of that elevation, not going across here. So I'd have to draw those edges in just like those were curb lines, okay, to keep that from happening. You can see it may be better represented up here where it's a little more spread out. So points along this, yeah, you know what? I'm sorry. I keep forgetting I have this. Now you can follow my mouse a little better. I apologize. And I always want to try to turn it. It's something I've started using new. So if I'm walking along this polyline, reading all the vertex points, and I'm back in here and I look across, these are fine. I look across this way and these are fine. But once I get up here and I get too far away to start forming these lines, the computer might then sit here and look across and find that point along itself, and it would flatten out those little nose-shaped contours. So you get a flat one in here and a flat one in here and a flat one in here. So if I take a profile down that happens to be a ridge top, but if I take a profile along that, it's going to go you know, flat and then drop, then flat and then drop, then flat and then drop. Well, actually it'd be flat and then drop, flat and then drop, or dropped and flat, dropped and flat along a ridge. So that's the danger that we run into when we try to model a surface from just drawn contours. And if you look right up here in the middle, here's a contour. It says, all right, it's this elevation all along its length. And something in between here should be between this elevation and this elevation. You know, if I connected all these lines in here, I would see that. But if I don't, I could have triangle edges that form across here, making this whole area flat, and that wouldn't be correct. Now, some people do that and they walk off with it and they don't get any errors reported from the computer, but and so they think they've done it correctly. But what happens is that it's just improperly representing that surface. So we're going to learn a little bit about how we create the break lines. And one of which is, if you're originating all this data out in the field, you have to recognize when you're on those structures that represent those lines, capture them as break lines, or either capture the points, come back in the office and connect the points up with 3D lines to set those break lines in place. Now, a break line is really a simple kind of thing. The you know, what we were taught in school, that break lines are areas along which a grade, why they it was break line. But there's a simpler way to think of it, because here's where this is how I misunderstood that concept. And if we talk about here, it's on page 20. Think about what we learned in school about break lines. The books all told us they represent lines along a break in grade, and that's exactly what they are. But pretend you are surveying across a little stream channel and you're running cross sections. So you survey a point up on the flat, you come down, you get a point on the top of the bank, get that point. Then you go down to the bottom of the bank, you get that point, you go across the stream to the other bank, you get that point. Cover the back, go point on the other side. So to me, I always initially thought of that line of cross-section points because the grade broke at all those points. It broke at the top, it broke at the bottom, it broke at the other bank, it broke at the top, the other top, it broke at the other thing. So I was always thinking about those things sort of 90 degrees out of phase. The actual break line is the line that connects all the points that are along the top of the bank. And another break line would be the points that connect, or the line that connects all the points along the bottom of the bank. The other break line is across on the other bank. The other break line is across on the other top of that bank on the other side. So the line, the break line, is actually the barrier that you can't cross. And so the easiest way to think about what a break line is it's just, they're just edges. And so the rule is this: if it's an edge on the ground, we need to make that an edge in the data. So we're going to draw those things in when we need to, okay? And there's a number of ways of doing that. We can use field to finish to help us do, like if we shoot a curb point, the computer is set up to recognize the descriptions of edge of pavement and connect all the edge of pavement points and the gutter points and the top of curbs and the back of curbs, things like that. So that can be done sort of automatically. You've got another situation like in this type of data where this was compiled photogrammetrically, and they went through and put that little floating dot down on the model and snapped a point and traced out all that line work. And they also went into some of these bare areas and just got some spot elevations. And so they've created
all the break lines and all the spots, and then we would use that to model our surface. Okay, and then it will generate the contours. So really what we should be thinking about is contours are really the output of having made a surface. They should not be used as the input to create a surface, because you run into that flats issue. You also run into the fact that everywhere between any two given contour lines is assumed to be linearly changing in grade, and it may not. It may go down a little bit and up a little bit, just not enough to trigger another contour line. So we lose that definition if we use contours as our source data. Sometimes, however, that's all we have, and we have to use it and have to live with it and supplement it as best we can. So we'll learn how to do some of those things as well. We can also need to learn to look at things in 3 dimensions so we can evaluate whether they are correct. So here's a case. I'm looking at this little roadway and driveway and come around. That's this over here in my data. So if I spin this up in 3D and look at it, I see that all of these road edges and this driveway edge and this stream center line, they are down at, and they're elevated at 3D elevation. And they then look like they're apparently good data, especially the edges of this long road here. They're going to keep these edges here. That's along the road cut at the top. And over here's another one on the other side, another road cut across the top. If I didn't have those road edges in there, it would let points form across top to top, and it would assume that road cut is missing and it's all filled in. So I need to make sure that that line work is present to interrupt or break that triangulation process from top to top across that feature. So when I look at it and I look at this and I say, okay, that looks good, but sometimes you'll get data that even in plan view, like right over here, looks good, looks okay. But if I spin it up, I may see, they kept all the roads down at 0 and the stream down at 0. They're not elevated like they should be. And so that would cause that problem across the top here, because it can't, like I said, it can't use that line down at 0. And again, Frank, that's your proximity break line. It won't allow you to use it for that. So you would have to elevate that. Now, there are ways to do that. If you get some kind of data that's done that way, you can elevate that in the civil module in your 3D data menu. You can turn a 2D to a 3D by screen entities, and everywhere it intersects any of that other line work, it will set the elevation of that 2D line at it puts a new vertex in at that elevation. So that's, one way that you could do it. You could have drawn contour lines. You can draw your crown line, your edge of pavement line, and then say, okay, read all the contours, and everywhere you cross the contour, set that elevation. So that then would step down each of the contours and set those accordingly, and they'd be correct if you did it that way. However, sometimes we get, and most often we'll get data sets that are just too big, like, something over here. We can't go through that and we can, I've done it before. Well, you draw all the break lines in, all the contours, you fix all those nose areas, put the edges in, and then you model the surface. Well, that's quite a process. So hopefully you're going to have the data that includes that 3D break line information, and out of that same file, and we'll look at this file in a minute, we actually do have that line work, that the break lines that form that surface, as well as some individual points that you can see over here, the individual points. And here you can see these long black lines are the break lines, and you see the drawn contours that they also delivered, but those are, again, the output of the process. So I wouldn't use those to build my surface. I would only use these elevated lines and these points. And then when I create my contours, they'll match what they delivered. Those are just drawn polylines at elevation. And if I have that other data, that's going to be my best approach to using it. Okay, so let's take a look at how that's done, how to use the viewer, how to build a surface. We're gonna go through this pretty quickly. So let's open a file. And the file I want you to open is called Sample from T3 Global. And we're going to open that file. And when it comes up, it's going to look like this. There's our data set. And we have a number of things in this file. If we look at, now I'm going to go up here to my inquiry menu, and I'm going to turn on my drawing inspector on and off. So I've turned it on. And I'm now going to right click the mouse and I'm going to choose this options dialog, and I'm going to turn on the things I want to see. Well, I'm going to uncheck elevation. I'm just going to look at the layer names, for instance, and make sure you have enabled tag display on so it pops up at the cursor. And I'm going to say, okay, and I'm just going to hover the mouse. I don't have to click anything. And I see, well, there's a contour line. It's on a layer called V Topo MAJR from major. Here's V Topo minor. And I go over here and I see this white line here, and I look at that, and it's on a layer called V Topo BKLN. Big clue, that's a break line. That's a 3D line that I would then use for that. I've got these curbs over here, V Topo break line. And you got, you know, the posts and the utilities, power poles, signs, things like that. Now, I've got a couple of little things going on in here. I've got one spot. Right in here. You see this pink line that sort of, you can see it mostly lines underneath it. And if I select that line and this line, you see it goes, it follows the curbs all the way around, but it's directly underneath these white break lines. So they missed that, you know, really that point should be up to there and this point should be up to there. So it's just a slight error in what they did. But these purple ones underneath, that's on a layer called V Road Curb. And again, there's a V Topo break line. Well, the V Road Curb, if I go back, right click, turn on my options dialog and display elevation. Now, when I'm looking at the white line, you see that elevation is continuously changing. But if I look at the purple line here, you see it says elevation 0. So that's the part where they drew all of the 2D lines in the drawing down at 0 elevation. And you're going to see it here pretty dramatically. I'm going to zoom out a little bit, hold the shift key, press and hold the wheel and push it up. So you can see the things that have elevation and the things that don't. Okay. Down there is those ones that don't. These are all at 0. And even the edges of the road are shown as 0. That's on a layer called V Road Outline. Same over here, this curb structure. It's all at elevation 0. But I'm going to go back to my top view now, and I realize that, well, all of those edges, and you can see down here where they come out, if I were to freeze off that break line layer, you would see those drawn lines underneath them at 2D. So make sure that we're going to be using our 3D data. So I'm going to go to view. And I'm going to freeze layer by pick, and I'm just going to pick one of these white lines.
Hey, Ken, when I was trying to get into that inspector part of it, I have layer inspector down the bottom, and then I lost my command line.
Okay. Go ahead and choose exit from the layer inspector. And that
Okay.
should put you back. And then go up to inquiry and choose drawing inspector.
Inquiry.
It's right below layer inspector.
Okay, and then just
Yeah,
it
and
says
that's just
on.
toggle. It turns it on and off, and it'll tell you that it's on or off. And if you see if it's on, you're going to see a double cursor. You'll see the X, the crosshairs, and you'll see an arrow like a
I do.
Windows. Okay. Now you can right click and choose what you want to see individually here, or choose the options dialog so you can turn them at multiples at a time.
Okay, and then the left, that what you have on your left side of your screen with properties,
Yes.
Is that just the layer property ones?
Yeah,
What-
no, that's just my properties palette that I have up. If you
Okay.
don't have yours showing, if it be something like this and you've taken properties, let me just turn
Okay.
that off. Okay.
All right, perfect. All right, no,
Just-
no,
If
I'm
you
good.
select something in the drawing and right click and choose properties, and that box will pop up, and it may be floating, you can dock it on the side. I always keep it up there because, and I always keep it open because I use it so often. So that's what I typically do.
Okay.
Oops, let's see, back to that. What was this? Oh, that was my help. I went back to that over the break and I used that cutoff area by radial line, and I was just picking the points in the wrong order, so it works. Just read the help system and it'll help you out. So now I've frozen off all the break lines and I see this line work, but the only part that has elevation, again, see the contours are drawn at elevation. This stuff is not. This stuff is all down here at 0. In fact, if I hit the front on the cube, down here's all my zeros, up here's my elevations. Okay. I'm going to now come up here, and to get to the top, I'm going to click this button up here because that's pointing to that top face. That puts me back in the top view. All right, so now I'm going to turn off that drawing inspector. I just see that I've got a number of different things that I can be using. So I'm going to go back to inquiry and choose drawing inspector on off again. So it now turns it off. It tells me that on the command line. So now you notice it can run in the middle of running other commands. So you can leave it on, but sometimes it just gets in the way as you hover the mouse over things. All right, so we've got a number of things delivered to us from this aerial mapping firm called T3 Global. And our first instinct might be to say, well, I need to build an existing model, an existing terrain out of this data. They've drawn the contours, so let me use the contours to create my data. Now, if I do that, what's going to happen is you're going to see, like right in here, on this contour to this contour, you're going to get to these points in here, and they're going to start closing off these as flat triangles. Okay. And we need a way to prevent that from happening if we don't have that 3D data. We do, we'll use that eventually to get the surface correct. But here's what happens when you don't do things like that. So let's go to our surface menu. And let's choose triangulate and contour. Now this is a combination command. It's going to triangulate our data, and it can also draw contours for us if we want. You can do that as one step. I generally don't do that until I looked at my surface and I'm happy with it. And then I go back to surface and I choose contour from tin file. That's the contouring part of this combination command. So that's the way I generally approach that. So let's look at that, and we're going to see how we can evaluate the surface that got built. So I'm going to choose triangulate and contour. You got a number of things. You can draw this stuff into the drawing if you want to see it. There's no need to, and I'll show you why in just a second when we look at our 3D viewer, is that we can see all that in the viewer and the computer puts it in there from memory from reading our surface. But the first thing we want to do is to write the triangulation file. So we turn that on, we hit select, and we're going to call this EG from CTRS, existing grade from contours. And we'll save that. So that's now going to be the file that we create. And we're not going to draw any of these things in here into our drawing. We're going to uncheck this box right here that says use inclusion and exclusion areas. So we could have drawn polylines as long as they're closed polylines. Is it only include within this boundary or multiple, it can be more than one, and then exclude things that we don't know about, like the outlines of a pond or a building outline. We don't know what the ground is like underneath those particular structures necessarily, but we'll leave that turned off for right now. And notice it has now within, and I think also, Chris, your version has it,
do you see that shrink wrap perimeter reduction in your dialog box?
Where am I getting to that dialog box?
We go to surface menu, triangulate and contour.
And then which one am I looking for?
So it's right down here. I unchecked this use inclusion exclusion and it says shrink wrap perimeter reduction. Do you have that option?
I do. It's currently
Okay,
grayed out.
That's okay, because you've got this box above it checked on. If you uncheck that, that should ungray.
It is. Yep.
Okay. So now, did you select and write a file? You should see a file name underneath it here. That was my EG from Contours. If you don't
Right.
see a line that tells you that file name, hit the select button and give it a file name.
Yep. I'm gonna do that. Yep.
Okay. Now, what we're going to do here is this shrink wrap reduction in older versions. Obviously yours and you're using 2023, so it had happened at that stage. But that used to not be part of this command. We used to have to go out to the draw menu and draw a shrink wrap boundary and set the boundary first. And then we would use that as an inclusion exclusion area. But this is a shortcut. It lets you let the computer do that internally. And if I say none on the reduction, I want you to see what happens. We're going to try this. There's choices of none, low, medium, and high. And that is a perimeter reduction. What that means is when it does that, it computes the entire surface first, including all these long skinny triangles out in here that are going to be part of that triangulation. And then it says, well, how much do you want me to go around this perimeter and start reducing those long edge triangles? If you say none, it's going to do none, and you'll see what happens when we do that. And we will, though, have on to ignore zero elevations. And you can also limit your triangle length with interior and exterior, but sometimes that can get a little dicey. You'll knock something out that you need. I'm going to leave those sitting at about 2,000 and go. And I'm going to uncheck this densify break lines. No need to do that again. You could do that independently of this process, and you could densify lines. That means you're going to add intermediate vertices in the line work at a certain interval. Okay, you can do that separately, and it modifies the lines that you do that to. But if you do it here, it only does it in memory, and it doesn't hog up our drawing with all those extra vertices. Okay. So now, leaving everything unchecked except these two boxes, let's go to the contour tab, and if this is checked on, uncheck it. We're not going to draw the contours yet because we have the means to see what they look like another way in memory. Therefore, if you're not drawing contours, your labels tab will be completely gray. And then on the selection tab, and I recommend that you look at this from time to time, make sure there's nothing checked on, because you can limit what you want to consider if you turn these on. So if I only want to look at CAD points, but not any 2D polylines or Carlson points or any lines, I can see 2D or CAD points and 3D polylines. So I can turn those on and off that if I want to use that. And there again, elevation text, I can have text and it can read the number and decide that's the elevation of that point, wherever that insertion point is. So I'm going to make sure that that is checked off, and these are all grayed out or unchecked. Okay, that's just a means of filtering your data. Just like this ignore zero, when I select everything, there's plenty of stuff that's drawn down at zero elevation. If I don't have that on, it's going to make a mess out of my data. In fact, let's uncheck it and just see what happens. And we're going to say, okay, reading the prompts, it says select entities, but read the line above to ask figure out what it's asking for. It says select the data you want to triangulate. So if I get everything, off it runs. I get some interesting issues, some 1,300 feet errors. I'm gonna exit that though, just to show you what's happened when I did not ignore 0. So I'm gonna go to View, 3D View, and this time I'm gonna choose Surface File Viewer. And I'm gonna find that file. There you see the outline of it. I'm gonna open it up. So it's going to come in and draw some monstrosity. I'll turn this little icon off and you can see these are the triangles that formed, which did not didn't ignore zeros. So it went along and read those things that are on the top, but it also jumped down here and read all that stuff at 0. So that was the bad approach. That's why we have that switch in there. So I'm going to exit this and we're going to go back and run that command again, surface menu, triangulate and contour. And this time we're going to check on to ignore 0 elevations. And now we're going to say, okay. It's okay to overwrite? Yes. Now select the entity. So I'll just grab everything again. Hit enter and good, no errors. And it tells you that it wrote the triangulation file, gave you the file name. Now, a lot of people, and some of the people that actually train this software, they say, hey, congratulations, you just built existing ground, go on to the next step. Well, they're skipping over the part where we need to look at what we just built and see if it's correct. We didn't get any computer errors, but did we model this correctly? Remember, there's curbs, there's edges of pavement, there's all kinds of, there's a retaining wall up here. So if I look at that, I'm going to go back to View, 3D View, Surface File Viewer, and I'm going to grab that surface file and open it. And now we've ignored the zeros. I'll color this in so you can see it as a continuous, and you can see some of the stuff is there. I'll drag this light around, keep it sort of in the northwest area. That's like the sun, and this is your the earth, and you're positioning the sun to cast shadows down and to the right. So I can see this little pond here and this indented pond here. I see this raised perch. But look at what I also see here is if I, and we'll talk about navigating around in this in a minute, but if I'm going to zoom over here and I look down the edge of this road, you see all those little flat areas? Let me go to my settings tab and I'm going to turn on the triangle edges. So these are the triangles that formed. And if I go back to my view control, go back to plan view, you see, I also formed a bunch of triangles out in here in this empty space. Turn that off and see. So those triangles out here. Now, why did they form out here? And if you remember, our data just went like this. You can see the outline of the data. But so there's something here, there's a point, a little stray point out in there that it's picking up. But when it's looking at all that data that we selected and it sits on that point, remember, it looks around itself 360 degrees and it's sitting down here and it can look around. Oh, I find that point up there. So I'm going to draw that triangle. Well, those are invalid triangles. So we're going to need, and same thing down here. I'm sitting down here and I can look up here and see all of those points. So I'm going to just start drawing those triangles. Well, we don't really know that that's what the ground does in that area, right? And it most likely does not do that. Okay, it doesn't change from here all the way down to here in one continuous linear change. So those are just triangles that we really don't want to be part of our data. And that's what we are going to control with this boundary. So I'm going to exit our viewer a minute. And again, we'll come back to that. I'm going to actually come up here and find this stray point. Let's see, they're on different layers. Let me see what this one is on. B-site structure. All right, I'm just going to create, those are structure points. I'm going to just erase those points so you can see these long triangles without the points being part of it. So if I repeat my process, I'm going to repeat a recent command. I'm going to do ctry, that's triangulate and contour. Grab the data or verify it's okay to overwrite, and then grab the data. Built the surface, I'll go back to view it. Now I'm going to switch to using these view commands from my surface toolbar, and it's the one that looks like right there. There's 3 different viewing, or 4: surface inspector, 3D viewer, surface flyover, and a surface file viewer. So I'm going to choose that. That's the same as choosing view, 3D view, surface file viewer. I'll pick my surface file, open that up. And now there you see those triangles are forming, you know, all the way around there, but they're forming out here in the middle. Now, Frank, if your experience, if you are a triangle editor, if you like to edit your surface files, when you are in this viewer and looking at it, if you choose this arrow, you've got these 10 edits that you can do. You can do like removing triangles, or you can swap 10 edges, you can add break lines, you can remove a point, you can do all those things, and then it'll prompt you to save it and all that kind of crap. But again, what we want to do is to fix the data that caused the problem in the first place. So let's go back out and see, well, what caused those? And if I do that, and if I draw the shrink wrap that it created in memory, I'm going to draw this shrink wrap boundary. I'll let it go across gaps so it goes across the ends. And I'm going to put that on a layer. And I'm just going to call it V-topo-BDY for existing topo boundary. I'll say okay. I'll say it's a 2D polyline. And I'm going to set this perimeter reduction to none. I'll say, okay, now I'm going to shrink wrap all this data that we've been looking at. And there is the perimeter. I'm going to change that layer called V topo boundary. I'll make it, say, yellow and give it some weight so you can see it. Turn on my line weight. So that's what happens. Now,
I have a quick question for you. Do you use line weights for plotting, or do you use like a pen?
No, I do. But you can also use pen assignments, or you can also select that particular polyline and give it an actual width, which is right in here, this global width or segmented width.
Okay.
And that keeps it a consistent width, no matter what scale you're plotting. That would be the ground unit width of that line. I don't like to use those. I generally will set my line weight and just make it something reasonable. Neither one is correct or incorrect, but that's generally how that works. So now, if we look at this resulting polyline, you see when it when it did a draw shrink wrap, it actually triangulated all of this stuff in memory before it went on to do the rest of our command. And it made all those triangles, and then it read the answer that we gave it for perimeter reduction. We said none. So we said, all right, keep all of those triangles that you found and don't do any reduction. So it just went around where it found it and left it at that. Now I've also got, I think there's a point out in here too. Okay, that is a valid point. All right, so you may notice, if you're looking around, if you can see, and you probably can't see it on my screen, but on yours, you may have these little pink dots all over the place down here. These are those actual CAD points. They're not Carlson points, but they're CAD points. And if I turn on, I'll go to settings, point style, and let's set that point to be a little X mark. We'll make it a size of the screen, a percentage of the screen. So there's those little X's. And if I do a regen, let me repeat that, make it an absolute size. Make it a little bit bigger. 1, 2, 3. All right, so those are the actual points that it's using. So if we are sometimes even, you know, we're not aware that we got points out there that we can use. And let's say maybe all we're going to use are the contours to make this surface. So let's do that for a minute. I'm going to freeze that layer of points. I'm going to go to view and I'm going to freeze layer by pick. Again, it's available up here on the toolbar as well. So I'm going to freeze layer by pick, and I'm going to come down here and just pick one of those pink points. And now those layers, those have gone off, gone away. I'm going to erase my shrink wrap. I'm going to draw it one more time so it ignores those points. So I'm going to draw shrink wrap entities, keep the same settings. And so now you can see, what did it do? Why did it do that? Why didn't it include that? Did I not? Oops, it's a hatch. I don't want to have it. Here it is, to draw a little birthday present. None across gaps. Set across gaps, and it didn't. Yeah, it didn't include that because that was a closed boundary, that's all. So it went around to all these open gap lines. It got to that end location of that line right there, and it so all these in between, it saw all those in between, but it kept, so those would be triangles if I were to build that as a surface with that set as it is, with no perimeter reduction. So what we really want to have happen is when we draw that shrink wrap, if we were to draw it ahead of time, we would change it from none. Let's make it a high reduction. So very high reduction on our data. So we'll select this like this, and you can see now it goes in and hugs the data a lot tighter because it took a lot of additional edge triangles out. Sometimes that takes too many out. You can see up in here where it's just going to the ends of these lines that we're using. Okay, and so it's jumping in and doing that reduction. So you want about a happy medium with that. Sometimes you just have to look at it and see what it looks like. And you can do it. See if I draw another shrink wrap and change it from high, you do medium or maybe a low. And then we've got something like this. And you see, well, it didn't quite close up enough in here. Well, remember, when we're doing this stuff, these things are just polylines. So I can actually select that, come in here and hover over that midpoint, maybe even convert it into an arc and shape it up here so it does that. I might want to say, you know, remove that vertex if I want to come out here and include things here, or using another point or another command, which is on my polyline toolbar. But here's why I use that toolbar, because it's under Edit, Polyline Utilities, Remove Polyline. And that doesn't mean erase the polyline. That means these are commands that involve removing stuff. And I'm going to remove a polyline vertex. So you see it's buried pretty deep. But you notice I've also got a little icon telling me it's on a toolbar somewhere. It doesn't say which. I'll show you how to find that out here in just a minute. And it tells me also down on the status bar what it does and the typed name of the command, RMVERTEX. So if I remove that polyline vertex, I just select the polyline and I see these little blips, and I don't have to snap. I'm just, whichever one I'm nearest to is the one it's going to get rid of. Okay, so I could do that and work my way around, maybe take out these little inflection points in the bottom. I could do that, you know, until I was happy with it. Now, does it cause any problems if it's doing that? No, all this is doing is going to be used to set the boundary of my surface. So it doesn't have to be that. In fact, I don't even have to shrink wrap it. I could, and let's just do it this way. Let's just draw a 2D polyline. Zero elevation. I'm just going to draw something that looks like this, and I'll close it. So I'm going to choose this option to close. So there's now a closed polyline. And now if I go back to my command, surface, triangulate and contour, and
That would
this
have to
time,
be that would have to be a 3D polyline. It wouldn't be like with LDD where you'd have just a polyline for a boundary, right?
no, it does not have to be a 3D. This can be a 2D. In fact, I drew a 2D polyline.
Okay.
Okay. So boundaries can be 2D. You can also make them 3D. It doesn't hurt, but it's no necessity. So, so now when I go back to my command under surface menu, triangulate and contour, instead of using this shrink wrap reduction and set it to none, again, that did it all in memory. I'm going to turn on to use the inclusion exclusion areas. And then you can choose to whether you want to trim the edges at the boundary or remove any crossing edges so you get rid of the entire triangle that might cross it. I'm going to trim so it snugs right up to the boundary. I'm going to say okay. Okay to overwrite the existing file, yes. And so now it says select entities, but instead of grabbing everything at this point, read the line above it because I changed the switch. It says select the inclusion parameter polylines or none, or enter for none. So I'm going to select that yellow one that I drew with shrink wrap, and that's all I'm going to use right now. I'm going to say, okay, now it says select entities. Well, don't get excited and grab everything again because it's asking you for any exclusions. So I'm going to say none for that for right now. And now it still says select entities, but it wants you to select the points and break lines to triangulate. So I'm going to grab all my data. And that's another reason I use a 2D boundaries on there, so I'm not picking up the elevations of those lines as I do it. So now I've made the surface, and now if I look at my surface in the surface viewer, I see that, or there's what it would look like, and you see all those edge triangles are now missing where I snugged up that polyline. Up here you can see those little jig jags, and then you see where I made the curve. Okay. Now, the other thing is, let me go back and draw one more 2D polyline. I'll just do a thing over here and close it. If I repeat that command again, the triangulate contour command, so yes, it's okay to overwrite. Select the inclusion perimeter polylines. I'm going to select that first one I drew and also this second one I drew. So notice there can be plurals. Now there are no exclusions. So I'll say, okay, and now I'm just going to grab all my data. It's going to build the surface. There it is. I go back to view it. And here's what has happened. You see, it's limited everything to be only within my inclusion boundaries. So if you're working on a big site and you're only working on a part of it, you can just draw these polylines. You don't have to use shrink wrap. Okay, but that shrink wrap is a helpful tool if you need to use it. I'm going to now take these back out. And we'll do it one more time, surface, triangulate, and contour. And this time we're going to, yes, overwrite, use that boundary. And it says joins, we've already done some elevation there, so it's just concrete pad. I'm going to click that building. The canopy might be one because they didn't see under it, so maybe I'll select that one. And then there was a piece of one down here, but it's only a corner of it in our boundary. So now I'm finished with those exclusions, I think. Did I get them all? I got 1, 2, 3. Yeah, the boundary there. Here's another canopy. I knew there was something I had missed. And I say, okay, and now I grab my data. Off it goes. I go to view my surface. And there you can see the outline that it's showing you. It's showing you that it included those. Now it's just taking the outside edges. You don't see the interior ones there, just in my preview. But when I look at it there, so now my surface exists everywhere except where I've made those exclusions, okay? Including that little corner down there. Now, while we're in this, let's talk about how we view things. Let's talk about what these tools over here do. First of all, on this right-hand panel, I've got 3 tabs. I've got view control, which is where we do most of our work. Settings, and these are things where you can display triangle edges if you want, on and off. You can display the contours and you can set the contour interval. Let's see, 1 matches our original. And it looks similar to it, but look at this area up in here. These contours didn't exist out there in that other data, and also these contours down here, you see how they normally should have come down here and come up into this corner and down, but they flattened out. Okay, that's that flat problem that we talked about. All right, so those are different ways to, okay, I'm going to go back to view control and let's talk about this. I got a bunch of icons in here in the middle. I've got some lock controls down here on these rotation axes. And if I unlock that axis, for instance, and just start moving the mouse around, I can spin it around all 3 axes. I'm going to come over here and get this rightmost bottom icon and go back to my zoom extents in plan view. And with that turn, I'm going to lock that Y axis. And this is why I'm going to keep that one locked, because it's this icon right here next to the hand, which is just panning the view. And these zoom in and outs, and those kind of view controls you can do with the wheel on the mouse, just like you do in the CAD system. Press and hold the wheel to pan, roll it in and out to zoom. Okay, so the one that I'm going to use to control my viewpoint is this one here that looks like that 3-dimensional cube and a little circular arrow around the base of it. So if I choose that, that's going to be my main control. And so when you do that, the icon will change shape. If I'm off the data, it's going to be a Z looking icon. When I get, and it's not exact, like see, it didn't recognize the exact edge, but once I get over a portion of the data that excuse me, that I know that I'm over top of, it changes to an XY. And what that means is when I click the mouse and the left button and hold it and move it, it's going to move on those XY axes. But now I've locked my Y axis. So if I go left and right, you see, it doesn't roll it like if I had that unlocked, it would roll it back and forth. If I keep it locked, and then even if I go left and right, it doesn't do anything. It only goes up and down this way. Okay. Well, that's important for us. When I get off of this data, it turns into a Z axis. So that's going to be spinning around the Z axis. So if I click and hold the mouse and go left and right, it spins around that Z axis. If I try to go up and down, you see it doesn't really have an effect because it's only working that Z axis spin. Okay, I'll go back to plan view. And this button next to that plan view, by the way, is if I'm zoomed in and maybe rotate it up. If I hit that, it puts me back to plan view, but right where I am. It doesn't do the zoom extents like that does. Okay, those 2 buttons are similar. This arrow button lets you sort of point to things on what you're viewing, and look down here at the status bar and you see it's reading the elevation of where it's pointing to. And you've got some other controls here, like you can clip things. This is clip the near items, clip the far items. So it's going to pull the bottoms out from under it first. Okay, so you got some, to be honest with you, I don't really do that a whole lot, but it lets you, let's say you're zoomed in to an area. Let me put this view back. Let's say you're zoomed in, you're looking around in here, but you want to look at this up here, and this stuff is in your way. You want to sort it. So at that point, you can clip these near items and you just slide it up to where it gets to where you want to look at. So it's just a little thing, but I don't tend to use that one very much, but that's what that is used for, these down here. This button that looks like a little fishing net that's all colored in, if you click that, that's just a toggle. Go back to plan view. And that colors in, I don't know why it's keeps changing my perspective, but let me put that back to zoom extents. Okay, now when I click that toggle, yeah, see that shouldn't keep changing that, but anyway, let's see. No. Yeah, there we go. I click this plan view, and then if I toggle this on and off, it's coloring in all the triangles. It's just a toggle. And those triangle edges that you see here, that's the actual surface that you built, and it's reading all of those triangles and displaying them for you. They're really just 3D faces. In fact, if you drew 3D faces out in the drawing and selected it and then jumped into the alternate 3D viewer, you would see that same possibility, okay? So sometimes you want to turn that on and off. And you also have at the top, you can say this color by elevation. And so that can show you, you know, low elevations on the bottom here and the mediums and then the highs. And that's another good QA/QC tool that you can look at it in case you've got maybe you've got a bad data spike and it's like sitting up here 500 feet too high. Well, you'd see everything looking blue except for this one little spot that looks red. And of course, you would zoom it up and see there'd be a problem there. So that's a nice way to also help you verify what you're looking at. Okay, so you can turn that on and off. You also have things on the settings tab to do like this bounding box. Right now it says none. I'm just going to say box only. And so that puts a little bounding box around all the data that you're looking at from low to high and left to right, top to bottom. So if you had a straight point somewhere, this box would be, you know, like way down here and it would show up as that straight point. So that's another good way to turn that, to look at that as a sort of a little QA/QC tool to help you find some potential errors. Okay, but now for the navigation. And first of all, when you're looking at 3D face data like these triangles, this little thing here, that sets your light source. Now, typically, I would keep it up in the upper left because thanks to advertising and drop shadows, we've now been subconsciously conditioned to think of things as casting shadows down and to the right. So our light needs to be up and to the left. So that's what makes this pond look like a pond. Notice if I pull it opposite to that, it looks like it's inverted. This looks like it's raised up high. This looks like it's raised up high. This looks like it's depressed, or at least to me. So, but really, you know, that's what it is. Now, you know, you can let your eye, you can trick your eyes into thinking that's inverted, and this is coming out. You just have to realize, okay, my shadows are casting this way now instead of the other way around. So that's just helping you see a little more contrast. And you've got sliders for, you know, brightness and contrast that you can adjust the view to sort of fine tune it. So now, and you've also got, by the way, this vertical scale. So if I make it, if it's like a really flat site and I wanted to see some of the relief, I'm going to put it up here to 5. And you see that really exaggerates that vertical scale. I'm not changing the data. This is just our viewpoint of the data. So I'm going to put that back 1. Now that setting, by the way, sticks between sessions. So keep your eye on it. If you've got one, you might just, you know, be showing something a little too severe or not severe enough. So we've got this done, but here is the way to navigate your way around viewpoint wise to look at any particular thing you want to look at. And you set it up in plan view, zoom extents if you need to, and then zoom out a little bit like you're looking at it here. Make sure you've got this little icon with the cube on it selected. That's our little cursor. You can see how it changes. And what you're going to envision is that you're standing in your driveway and what you're looking at is your garage door. And you want to raise up your garage door. And it's one of those that it's all, you know, it's not articulated or hinged. It's just a solid slab, but it's going to raise up and go up into the top. So if I position my cursor to where it's XY, make sure it doesn't say Z, but XY, and get down toward the bottom part of it where it still says XY, click and hold the mouse and push it up. So you're going to raise your garage door up and go back and get another chunk of it if you need to, and raise it up to where it's mostly oblique. You don't want to raise it up too far, just sort of something like that. And once your garage door is up, put it down, put the cursor down at the bottom now, and use that to spin yourself around and look at what it is you want to look at. And then just point to it and use the wheel on the mouse to sort of fine tune those areas. So if I go back, I'm back in plan view, zoom extends. If I want to look down this road edge right here, I'm going to zoom this up flat. I'll spin it around to where I'm sort of looking down that edge, and then I'm just going to zoom in, and there's my edge of my road with all those funky looking flat areas. Okay. Now, so that's the essence of this viewer, and how to get around in it is you use that garage door thing, and that'll soon become second nature. You'll be able to figure it out. There's one more tab over here called the model tab, and that allows you to go back out to the drawing and select things in the drawing. So if I go to that and choose it, and if I select all this data, for instance, and then come back, now you see the drawn contours that were out there are now superimposed, and those are those spot elevations. So that lets me sort of mix drawn elements with a surface model. And you can see you can control the layers and all of that. You can even add additional surfaces into this. As long as they line up in coordinate space, you'll see multiple surfaces. You can turn them on and off and compare them, see how they relate to each other. All right. So let's exit our viewer now. And by the way, if your viewer, you know, comes up like this, and you can put that on a different screen, you can maximize it, do whatever you want to do with it. All right, so let's do a little bit more grad. See, we froze off our points. Now I'm going to go to that same viewer, view, 3D view, but instead of surface file viewer, I'm going to use a drawing viewer. And here's the difference. It now prompts me to select things in the drawing. So I'm going to select all my data and hit enter to finish. And so it's going to load that up in the viewer, but there's no surface. In fact, if I click on this little thing here, I'm not turning on and off any, you know, anything here. I don't have any 3D faces. All I've got are these things that I selected in my drawing. Okay. And I can see them. I can also, on that model tab, again, I can choose this and I can turn off various layers and different things, or I can even add a surface in just like I was in the surface viewer. And there it happens to be superimposed under those drawn entities. Okay, and there's where you can see right in here, you see those flat areas that were the problem with the contours. Okay. So, and then you can, over on that model tab, you can open up the surface and you can see, and there's a checkbox at the bottom. If you double click, it's going to toggle its visibility. So I'll turn it off, turn it back on. You can right click it, set properties, and you can give it a different color. You can make it, you know, you can turn its opacity down to make it somewhat transparent. You can even set a texture for that surface. Maybe that was, let's look at concrete 1, for instance. So that's going to look like concrete, you know. So there's a number of things you can do in here that we don't really do a lot of necessarily. But they're there to help you if you want to do that. Now, viewing that surface by texture was part of that closing exercise that we illustrate here. Let me go up to it from here, putting it all together. that was how this image was created. Was I just viewed that surface, applied a texture of rocks, and then did a screen grab and made that part of my, just an image to put in part of the training guide. So again, a lot of options, a lot of things you can do with it. It will all become second nature to you, and I hope you'll use it as you're evaluating things. And a lot of nice things about this is when you spin this thing around to look at stuff, when you exit, you come back out to plan view. What I've been doing before is holding the shift key and running things up, but now I have to go back to plan view with this. And also from the viewer, and let's just grab a little bit of it. So there's that part. If you set something like this on the settings tab, there is a button right here where you can set the CAD view to that current view. And then when you exit, now you see it's matching that same perspective. So I'll go set it back to plan here, because that's what we're used to seeing this in. All right, now to evaluate a couple of things here. Remember I told you about those flat contours. If we were to look at a profile down that little ditch line there, we have a tool in Koga or in Survey, it's on our center line. No. I want to profile. It's under, it's under surface. In civil, it's on the roads menu, or it's under the profile menu. You don't have a profile menu in Survey, but under this surface menu, you see this tool called Quick Profile that lets you cut a profile along the drawing and evaluate something. So if right now, I don't have a surface file that I want to look at yet necessarily. I do, but we'll get to it. So if we look at our screen entities as what we're going to choose, ignore 0 again. So I'm going to say, okay. And it asks me to either pick a starting point or use a centerline file or pick a pre-drawn polyline. Well, I'm just going to come down here. I'm just going to grab that nose point of that contour. And I'm going to run it down, this edge. So I'm sort of cutting those contours there. And I've finished that. And there now is that in a split view. And I can see this profile. Now it's a little bit, I missed where I was going for. So I'm going to adjust that. I can't from here. Let me see. I want to adjust that. So if I quick profile using screen entities, I'm just going to pick a point, say in there, and let's come down to, say, that point. So we're running down those. All right, so now it's going to look at everything. Still missed picking those up. Oh, no, this is correct. Yeah. So if I'm looking at this as it crosses screen entities, notice it looks like a pretty smooth profile. Okay. But I'm going to exit that. If I do that same command, and this time, instead of screen entities, I'm going to look at a surface file. Now it keeps the names of 2 different files from the last time you were in the command. We're only going to look at one. So I'm going to go to this second file. I'm going to hit the second button. I'm just going to hit cancel to clear that out. I hit the first button and I'm going to find our surface that we made from contours. I'm going to open that up. So now I'm pointing to that as a surface file. I'm going to say, okay. And now I'll do that same thing. I'll come down here and just grab this point, come down here and grab this point and hit enter to finish. And now you see how I get these little flats coming in here. And I've got an adjust alignment because I'm using a surface file, so I can just click near. And as I move this around, you see it's in real time showing you what that surface looks like. I can come up in here and where I can put this down, click it. Now, if I adjust alignment again, I can click near the endpoint. I don't have to snap to it. I'm just going to adjust that endpoint. I'll click adjust alignment again, get near this endpoint, and I want to sort of stretch around that. See, there's a retaining wall right there. But if you look at, as I'm tracking here, it tracks here in my horizontal view. So if I'm over here, coming along, and then it hits this, whatever it does in the surface file, and climbs up in the air, goes across the top and back down and out this way. Now, what that is when I built this surface from contours, all it read was these contour ends. And so when it got to ends of these contours, it looked across and saw this contour, and it made that little sort of a ski jump looking area because I didn't have the break lines shown for that wall. Okay. So if I go back to my 3D viewer for my surface and look at the surface, you can see that right up here. There's that little ski jump area, and you can see it, you know, it sort of made that across there, and that shouldn't be there. Notice something else. There's supposed to be some curbs and stuff around their road and their parking lot. They're all but completely missing. I don't see them here because, again, I just read the contours. That's all I used. So we're going to make it the correct way now is we're going to build this surface, but we're going to use the break line data. Now, so I'm going to turn those layers back on that I froze. So I'm going to go to view. Let's say thaw/on all layers. So now I've got not only the break lines, but I've got these little points down here that I'm going to use. And if I look at that in my 3D viewer, look at my data, the drawing viewer, select all of this, you're now going to see all of those little points, and you see also the contours, but you see all of those raised edges. There's your curbs. So all of that would be functioning as break lines. And as you can see right in here, for instance, these contour lines come over, hit the face of the curb, climb up to the top, and go out the back. In that particular curb line, I've also got things down here. Let me come back to that. Whoops. Raise up my garage door, spin it around, and look down those flat areas. And you can see that that edge has already been drawn in there for us. So I don't have to put it in. It's already there. Okay. So let's do that. Now, also notice the shrink wrap that we put together from the contours. They don't go out as far as all the data does. And that's because when that company delivers contours, they don't, they compile out to this edge, but they trim off the contours to, 50 feet or whatever that distance is, because they're aware that they're not as sure of the data out in here because it's off that model a little bit. So I'm going to just select that and delete it. And I'm going to let the data create the shrink wrap. So if I go back to surface, triangulate and contours, now let's change the file name. So I'm going to say write the triangulation file, choose select. And I'm going to call this one EG from BKLNS and PTS, break lines and points. So that's my real preference to doing that. I'm going to uncheck this use inclusion area, and I'm going to let it do the shrink wrapping for us, but I'm going to change it from no reduction to low reduction. Choose my setup. I'll choose it as a 2D. I will draw it, and I'm going to put it on that same layer I had before, which was that V topo boundary. Say okay, and I'll say okay. And again, I'll say okay. Now watch what happens. You're going to get a lot of errors. It says select the points and triangles, or points and break lines to triangulate. notice I still have the contour lines on. Now, the errors you're going to see are going to be all of these crossing break lines. So I have like one here is like 2 feet off. Here's 0.6, and I can zoom to and zoom in, sort of, you know, find my way around to try to fix some problems. It points to where it crosses. So here's a place where this is a 3D line. This is the contour line that they clipped off at that edge, and it actually crosses just a little bit. If I can zoom in far enough, there it is. And they're at a different elevation. They're half a foot apart, so that, you know, the resulting interpolated contour crosses the actual data. So, you know, you could go through and spend a lifetime taking care of all of these little, I've got 442 crossings. I've got one T intersection. I've got 2 vertical edges. All right, so that should tell us is if I've got this 3D line work, as well as the contours, I need to not use the contours and use the 3D line work. So let's do it again, but let's freeze. We go to view, freeze layer by pick, and I'm going to pick one of the intermediate contours, one of the index contours, might as well get the label. But I'm also going to see I've got some other contours, and they're in this, you see that word obscured. So they used 2 different layer sets. So I'll include one of those and one of those. Now, all of my contours are off. I'm going to view my 3D data now. Just to verify that, okay, that's what I want. That is the minimum, or not the minimum, but that is a complete representation of that surface using all of the 3D information in that file. It doesn't look like a contour map yet, or even a surface. I can't color those in. They're just points and lines. But that's what we're going to use. And you can even come up here and let's, you know, put this little arc back in there. If you want, you could straighten those out. I'm not going to go to that. Also recognize, like we said before, you could simply draw a polyline. You don't have to use shrink wrap. But this one was done by the program. It shrink wrap with low reduction, got it to within something I'm happy with, okay? So now let's go back to surface, triangulate and contour. And this time, instead of letting it recreate that, I'm going to check to use those inclusion areas. I've already got it drawn, so I'll leave it there. And make sure you have this erase previous contour entity set to off. Otherwise, it will erase that line because that's a previous part of that previous command. So I'm going to say, okay to overwrite the existing. Yep, I'm going to grab my shrink wrap inclusion. There are no more inclusions. I'll hit enter. Any exclusions. Now I could go through and get the buildings. I'll not do that, but you get the idea. When I'm through with the exclusions, I'll hit enter for none. Now grab the data. Off I go, off it goes, and it still is going to give me a couple of errors. And they are actual errors. I've got crossing break lines and vertical edges, and I've got one here that's 3/10 difference. I'm going to zoom in down there, and this is a little head wall structure. Okay, so I've got a 3D polyline right in there. I'm going to make its color red. I'll get this other one. Oops, let me escape first. Get this other one and make its color green. And so now you see they actually do cross. And if I look at that sort of in, let's look at it in 3D here real quickly. They just miscompiled it. Those should not have crossed. And so you could, you know, readjust where they go. This is supposed to be all outside and this one's supposed to be all inside. You know, you could adjust those, or you could ask the people that supplied the data to build it for you. These other ones, I've got some vertical edges where one line is right over top of the other line, and there's a 0.04 of a foot difference in there. So I might, instead of right there where the vertical edge is, see, I've got, there's a little drop there that's vertical, a little discontinuity in that line. Then you could clear that out if you want to. We'll leave those, they're close enough. We're just going to say exit. And let's go back to plan view. And now let's repeat that now that we've cleared out the head wall. Triangulate and contour, leave everything like it was. Say, okay, yes, overwrite. Pick the inclusion, no exclusions, and now get the data. And now those crossings are gone, but I've got another crossing. And again, it's just where one edge came down here and just snuck a little bit past the line. So you could trim off that edge and do that if you wanted to clear it. It's 8/100ths of a foot. I'm just going to leave those alone and take them like they are. Now let's compare this surface with the other one. So let's go back to our view, 3D view, surface file viewer, and this time let's choose EG from break lines and points and open that up and look at the difference. First of all, my boundaries trimmed off. I zoom this up and I look down my road edges here. Wow, they're nice and crisp. And I even see this raised sidewalk out here. I see out here, my curbs are all nicely defined right in there. Okay, so it's all, I've even picked up these retaining walls out here. Let me come back to plan view here, reset. And that area where there used to be a little ski jump, there's that retaining wall. I think it's a loading dock actually. Up here's another retaining wall across the street. And you see where all of that stuff is really defined, that surface. And now that's a good surface that I would be comfortable handing off to somebody to say, use this as your existing grade and do your designs with, because they can query that information, find out what those elevations are, and they can, you know, just really do with it what they need to do. Okay. So hopefully that'll give you a bit of a whirlwind tour on how to look at that stuff, how to evaluate the data, how even though you didn't get an error on those contours, you still had errors in the modeling. It didn't represent what was there. Now, one last trip around the horn. Let's turn on all our layers. I'm gonna thaw/on all layers. And they're now on. Now I'm going to isolate layers. So I'm going to view, isolate layers, and I'm just going to pick the contour line. So one of the intermediates, one of the index, one of the obscured intermediates, one of the obscured index. And so now here's my contour lines. So if you're ever stuck with the prospect of having to build a surface from contours only, let's say the only thing you have are contours. This would also apply, Frank, if you choose that SiteNet methodology in Civil, and you tell it, okay, these layers define existing, I'm going to make existing. And so it's going to use this as if you selected it, and then, you know, selected all this data and it would build it from the contours. But there's a couple of little things we can use, or at least one, to help us in particular with those flats. And if you remember in our settings, Carlson configure, side ops, take off side ops settings, one right here that said minimize flat triangles for existing surface. So if I'm taking that, and you don't have to have that set the way we're doing it, that's if you're using side ops, and your data comes from contours. But let's go back to triangulate and contour. So surface, triangulate and contour. We'll write a third file now. We're going to select, and we're going to call this EG from CTRS with help. All right. So we're going to make a third surface now. And one of the selections things down here is that we have right here, there's this little faint outline around this box, and it says adjustments for source data of contours. So if you only have contours as your source data, you want to minimize those flat triangles. You don't really, interpolating ridges and valleys doesn't really work all that well. And these other kind of things that can do a little tweaking, but this minimize flats is going to give us the biggest help. And we'll say, okay. And now inclusion, now I've frozen off that area, so I'm just going to hit none and none for exclusions. I'm going to grab my data. So I'll still get those triangles out there, but I just want to illustrate a point. So it wrote the file. Let's view the file. And now here's that existing from contours with help. And now look at the difference when I said minimize the flats. Like I said, it's not 100%, but it minimized them down here. It still has some of them up here, but it minimized the ones out in the pavement, except for that one up there. So that would be a problem. And a lot of people's approach would be, since you're looking at a surface, let's choose the arrow, and we would say, add a break line and maybe do a break line from there to there. And so, and then one from there to there. You know, so you could, and then if we did one on the backside from here to here, you know, so you could go through and chase those down, chase your tail around in a circle and keep doing all those edits. And then when you exit, save changes, we'll say no. But you can see at least down that one edge, it really helped out. Now let's take a look at that with a quick profile. Again, under surface, quick profile, we'll use surfaces. And this time we're going to set as our first surface, we'll use the good one. We'll say e.g. from break lines and points. And our second surface, let's look at that very first one we did, just e.g. from contours. We'll say, okay, and we'll start here. And we'll go down this edge here. Let's go out in space and just sort of visibly make sure I'm down the noses of those contours in there. So there we go. Now you see the difference of what we're looking at. The red, you can see here in my profile view, you see all those flat areas that have been, let me see if I can swing that a little bit out into, there we go, a little bit better place. So you see down here now in my profile view, you see how it's made the one without the minimized, it incorporated those flats. And the one with the white was our good surface. And that's what it really looks like flowing down that curb line. Whereas if I take it with the contours only and don't do those flat minimizations, I'm going to get these stair steps. Okay. Now, here's what to do with that knowledge of the fact that that works. First of all, you would want to try to minimize the flats, but here's something else to consider. Let's say I'm building a surface that's as big as a county, because I'm going to do a hydrologic study on that, just tracking major flow lines. I may not care. I may not want to take the time to try to find all those little trivial edges like curb lines and such. And I'm willing to live with that a little bit chunkier surface. Okay, and that's fine if that suits your purpose. But if you do need those sharp edges defined, you want to have those included as break lines, or at least minimize the flats so that it goes through, and when it encounters those little flat triangles, when it builds it, it says, oops, I really need to look somewhere else instead of across to myself. So that's, again, sort of the whirlwind tour of doing that as some surface modeling. Okay. Now, one last thing to do, we'll take our mid-break. I wanted to show, Frank, you talked about that CADNet rubber sheeting issue. So now, Chris, you're not going to be able to follow along with this part of it because you don't have those modules, but I do want to show Frank this issue. If I go to view and I'm gonna take thaw on all layers, I turn everything back on. And now I'm going to freeze by pick. So where is it? Freeze layer by pick, and I'm gonna turn off the break lines and those masked points. And I'll just leave that as my, I'll even take the boundary off. So that's my basic delivered plotted map that I got from the client. Now, this happens to be in a particular location. If I go to settings, drawing setup, I'm at a 20 scale, and I'll put that back to 1 just for yucks. And the projection of this, right now it says none. I'm going to choose predefined, and then I'm going to define the projection. And I'm looking for Pennsylvania South, NAD 83, and it's the 1986 projection. If you don't see that in your list, hit the add predefined, come over here and search for Pennsylvania, go in and find that one there and say, okay, and that will now come back in your list. Then select it and say, okay. And then we'll say, okay. So now, let's see what this MSLT scale is set to be. Yeah, see, that was predefined. That's region off. So that's just line type scaling. There's no big deal for that. All right, so now I've told it where on the planet this thing is, and it's using the state plane coordinate system in Pennsylvania South. Okay, as long as you have that defined, I'm going to switch now to the GIS module, either from the toolbar or from settings, Carlson menus, GIS menu. I'm switching to GIS. I'm not going to use any kind of fancy GIS data. I'm just going to go to images, and I'm going to place a Google Earth image. Now, if I had ortho-rectified photography with world files, I would do that instead, but it's just going to be a Google Earth image. And I need to give it a file name of the image it's going to create. So I'm going to just call it site aerial. So I'm going to spell it right. And notice of these options up here, I can choose, let's make it a PNG. And I'll save that. All right, so that's the file it's going to create. And now it says, you want to pick from the screen or pick from an interactive map? I'll just say from the screen. And I'll just come down here and say, pick out here and pick out here. Now it's going to go out within that frame, look for Google Earth imagery, and it's going to let me choose aerial, hybrid, terrain, or road. So I'll say aerial. And the resolution. And sometimes you're too big a site and high resolution is not available at that elevation. So you'll see what you want. So let's just choose a high resolution. And we'll say, okay. Place in the background and say, okay. So it's going to go out there and download that image and place it into our site. Did I hit okay? I guess I did. Okay, there it is. Now I'm going to select that image. I'm going to come over to its properties and I'm going to set its fade level to 50% so it's not quite so bright I can see my data. All right, now, there's where that is. It actually, if you've ever driven the Pennsylvania Turnpike, this is that Breezewood interchange. The turnpike comes off up here and then loops around, exits here, and then this takes you up I-70 out toward Washington and Baltimore. So, so I see my image, but if you zoom in, you'll see, well, look at that parking lot corner. It doesn't exactly match. My road edges don't exactly match. So how do I get that to match? And that's where that rubber sheeting comes in, because Google imagery is not survey level accurate. It's really kind of, compromised all over. So I don't have that match, but I can see the image and I can see points that are going to need to line up. And so if I do that, I'm going to now switch to my CADNet menu. So I've switched now to CADNet and I've got a menu there called raster, and there's a tool under there called rubber sheet. right here. And you got all these other adjustments, etc. But I'm going to rubber sheet this image. And so what it's going to ask me, I'm basically going to, I'll use the inverse distances. That'll be fine. You got all kinds of finesse you can do here. I'll just leave that as a default. I'll take OK. And now it's going to prompt me to pick the origin of a control point 1. So I'm going to pick a photo point and then show it where it's supposed to be in my data set. So I'll zoom into this parking lot corner here, and I'm just going to sort of eyeball close to that back corner. And now it wants to know the destination of that control point 1. It'll be that back of the curb right there. Okay. And I'm going to get, you need, a few. So I got that one. And let's go over here and find this one. I can sort of pick right there and go right there. So I've got it. I've got a minimum of what I need now with 2. Let's maybe find one other place. And curb corners are the most visible. So down here's one, like right in there. I'll sort of pick right there with a concrete back, and I'll go up to that point. Now I've got 3 points. I'll just hit enter and let it go to work. And it's going to actually warp all of the pixels in that image to match those 3 points. And you saw it shift when it came back in. So we can zoom up here and see it's now lined up in there. It's lined up in there. It would be lined up where we pointed to, but we still have some misses out in here. Let's see, see that curb, the curb in the photograph doesn't match this curb in here. I've got a few more. So if we repeated that process, and the more you add, and especially if you get across the site in different places, that's going to help you really identify. So one of the things that I found is if I can see some of these inlets, you see the inlets. And try not to use like building corners, like in the photograph, you'll see the top of the building, but the compiled data is actually on the ground. And you've got some vertical displacement involved here. So this outline is the actual
But once you
building.
set the curb corners that you did before, they'll
Those,
stay. And then when you go to different areas, you can stretch the other ones.
yes, you can add some additional to it, or you can just add them all up at the first time. I'm trying to find a couple of places. This photograph's a little blurry. Let me find a couple like in here. And see, there's a car and a shadow, so I can't find the back corner of that.
Okay, that's great. That's just what I needed.
Yeah, so you would do that here. Here's an example. So I would say that point and go into that on the back of that curb there. So set that point there into there. So you basically just, walk around and sort of find easily identifiable points that you can use to line things up. And if I had my brake line data on, I could see these retaining walls over here right now. I've got them frozen, but you can see how that would apply right in there. Oh, that one fits pretty well.
I do a lot of forensic engineering for the insurance company and attorneys, and you don't
Perfect.
want to. It's easier to combine survey data with
Yep.
aerials, but from Google Earth, but the accuracy isn't that.
Yeah.
But
Yeah.
this helps out a lot.
That'd be an excellent tool. Let's see, maybe. Oh, did it strip it that far out? Let me try that. If I click in the middle of that inlet, if that is an inlet, I may be warping it more than it is justified here. Yeah, let's see what happens. It's going to do something here, maybe incorrectly, but we'll see. There, it shifted that to, yeah, so it pulled it in, but it missed those. So anyway, you would find, enough points to try to, now you see how, because it pulled it too much, and I would really need to go back and redo that from these corners and, set the ones that you can find, and you want to spread across the site of the data and use it accordingly. Okay. So that's how that works.
Thanks.
You bet. And again, that's our basics of doing all that modeling. So we're going to take our break. Let's come back at say 20 till, and we're going to then step through that, putting it all together workflow, and it's going to back up and help us, or it's got enough exercise steps in it that are going to sort of reinforce everything that we've learned the last 2 days as we've been doing things along. Okay. So let's, you don't need to save this file. You can if you'd like. And we'll come back to that, to the next exercise, which will be this one right here in your book on page 37. We'll come back. All right. So I'm going to stop our share. I'll pause our recording. Oops, right here. The resumer. And Chris, while he's on his call, we'll just sort of set the stage here. We're going to go through this little exercise here on page 37 and sort of find out what we need to do to build our little stockpile, compute some volumes. We're going to create a little borrow pit out of our stockpile, modeled everything, put the surfaces together, see how we draw some contours, and then we'll design a little haul road to come into it, look at our existing grade, we'll set up the road grades, and then create the top of the road surface as 3D line work, put it out on our model, add that to our surfaces, and bring it all together, and that will create it all in a combined little project. Okay. So that's going to be what we do. Let me see, we'll get things back here where we start. So we'll wait for Frank to get back. Frank, just let us know when you're back if you're not, once you're done on your call. I guess while we're waiting. And so what we're going to do is do this and sort of put together a bunch of tools that we can use, and sort of reinforce what we've gone over. So we're going to open up a drawing called example1.dwg. I'm going to choose open files. I'll find my example1 DWG. I'll open that up. If you get this message, go ahead and just set it back to the 86 adjustment. I don't think these are at any particular state plane. I look at my status bar and see they're not. They're probably down around, 10,000, arbitrary. I'm going to also open that example1 completed. And that's really, what we're sort of working toward is to have this, the 3D model, and those are just the contours. I don't think there's anything. Yeah, there's the edges and the contours are all shown on the pads and stuff. So, that's really where we're headed. Look at that in my 3D viewer. For instance, you can see we're going to be putting this road bed into our little borrow pit area. All right. So what do we have in our drawing here? We see a bunch of points there. I'm going to, just because I'm so anal retentive on those point styles. I'll set that to be my Calibri light. All right, so I got a bunch of points. And I see just by inspection, I've got a bunch of points B, B, B,
How
B.
did, how did you pull those points in again?
I opened this file called example one.
The DWG. I did
Mhm.
that. I got the line work.
No, not the example
Oh,
one.
not size. Example one.
Yeah, just plain old example one.
Okay.
Okay, so now this is what we're given. Surveyors came back, they gave us these points, and they've got all these points called B, 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 and some around the edges called B toe. Well, by casual inspection, we'd say that represents our toe of our slope. We know this is a stockpile. So we need to create a surface of this stockpile to maybe we're going to compute the volume of how much materials in this stockpile. Now, there's a couple of approaches to this. One is that we can make a surface out of all these points, but then to compute the volume of that material, we need a surface to compare it to. We need to know the ground underneath the stockpile. Well, we don't have any points that show that or what the ground used to be before the material got placed on it. So what we need to do is think about computing that volume as this surface compared to a surface that just goes from edge to edge without any of the points in the interior. So that basically will make a flat-ish edge or surface rather across the base of the material if we just use the exterior points. And then we also use them and the interior points to create the top of the stockpile. So that will give us two surfaces to compare. Now I'm going to go back to survey, and under surface, I don't think we have this here. Now, here's one thing I do want to point out. When you're in civil, Frank, you've got a little bit of an additional tool under surface, and you see this stockpile, pond, and pit volumes. You can calculate a stockpile volume, and it basically does all that stuff for you sort of on the fly, but we're going to do it under survey is we're going to choose a volumes by triangulation. And you see here, there's two options. So we can make two surfaces to get the volume. That's what we'll wind up doing. But you could even do it as a single surface by itself. And the option there is, well, I'm just going to choose one of the old surfaces. It's not going to apply here. But here you have to declare a reference surface, and you can either give it an average elevation if you're at flattish ground. This is not flat ground, it's on a slope. So we would say we'll use the 10 perimeter, use the outside edges, and it does in memory what we're going to do manually to get that base. So that's that additional tool that you could use to calculate that, even if you only built the one surface. But we'll build the two so we can just follow the proper procedures, all right? So what's the first thing we need to do is we need a boundary around our surface, and we can let it create it, or we can draw it for us, or we know we're going to be working with these points. So let's take a list of these points and see if we can glean anything from it. So let's go to the points menu and choose list points, and lo and behold, it's asking us for a coordinate file. We don't have a coordinate file. We've got points in the drawing. They're not in a file anywhere. So that's the first thing I need to do. So I'm going to go to my new tab. I'm going to call this just stock pile points. So I've now created a stockpile points. And if I list all my points, I see that I have 0 points, even though I've opened the file.
So the first thing I want to do is to get all of these points into that file. So where would I do that? And that is either from the bottom of the points menu, this point utilities, you can update the coordinate file from the drawing, or you can do it from the coordinate file utilities multi-tool. It also has update the coordinate file from the drawing. So we can take all of the points, or you can put wildcards in to limit it to the descriptions. And we'll just say, okay, and now select all of these points. And it reads Carlson points, soft desk points, which is your old LDD format. You saw maybe some various ones. Now, if I list those points now, I'll see that there indeed, I've got BTOs. Looks like all the BTOs are together from 2000 down through 2028. And then I've got 2029. Everything else are those interior points. So they are in order, and that helps us out a little bit here for one thing we can do. So now let's see, if I look, yeah, see, here's the points. It could be Carlson points, land development desktop, soft desk, which is just a later version of LDD, then inroads, Eagle Point, geodometer, Leica, or microsurvey. So it reads a bunch of things that might be in a file that you get. All right, so now we've got the points in a coordinate file. Now, to draw this perimeter boundary, because we started at point 2000, which is down here as BTO, we know they're all in order. We could just draw 2000 all the way around to the last BTO, which is 2028, and then close that. So that's the quickest way, because we verified that they do go in order. Now, they go in order numerically, but one of these might be, out of position. Like 2000 could be here, 2001 could be up here, and then 2002 back here. So we don't know that they're positionally sequential. We can just try it and see. So let's do that first. We'll draw a 2D polyline. So we'll draw a 2D polyline. Let's uncheck the current properties, and let's put it on a layer here called, I'm just going to type a new one here, stock, or let's see, SP for stockpile dash perimeter. And we'll say okay. And it wants to know the points are point numbers. And we know we went from 2000 to 2028. And it looks like indeed they are positionally sequential. So that would be good. Now we need to close that. So you can either snap up here to it, but that doesn't mathematically close it. So we need to choose close from our options. So then now there it is. I'm going to change that layer to be a little more visible here. Turn on my line weight visibility. There we go. So there's one way of doing that. And I'm going to use that as my inclusion perimeter so I don't get triangles out in these little inset areas. Okay. So you could do that. And then an alternate approach to that, I'll just select that and delete it, is to draw a 2D, or not draw a 2D polyline, but you could do a draw shrink wrap. And if you did it that way, you could do that. Let's put in, if we said no reduction, let's put that on that same perimeter layer and said okay, and we set across gaps with 2D, and we do that. There it is. And so you see it doesn't snug up in here and get those. There was that no reduction. So if I repeat that draw shrink wrap and change it from none to high, for instance, we do that, select our data, and now there it goes. But look what it does here. You see it jumps in too far. There was too much reduction. So you could do something like, by inspection, just come out here and remove the vertices that don't apply. There could be some in there, like there's one.
Now, when I try to, there it is, so I remove that vertex. So toe to toe to toe to toe to toe, so you could verify your way around there. Now, here's another tool we haven't discussed yet, but it sometimes is helpful. And that's on the draw menu, and you're going to draw a polyline, which would be basically you're just drawing a standard polyline, so it's right down here. But you're going to do it by nearest found. Okay, and so when we do that, it will, wherever it starts, it's going to go to the nearest nearest found point and start drawing the polyline. And if you have this set for, I'm gonna set my layer back to that perimeter so again you can see it. And if you have the description match set to asterisk when you do that, it's going to wind up, let's see, select by the screen, we'll select our points. So you see how that's obviously not going to work, but if we do that same command and we change that description match to be, instead of star, let's put star toe. So it finds all of the points and only the points that have toe in the description. We'll select by screen. Now we'll select this. And now you see it does connect all of the toes, and none of them were closer, so it doesn't cross itself. So all I would need to do is select this and go to its properties and change it from being closed no to closed yes. So that's another way of doing that. Okay. Now, here's going to be a little trick. We could, when we're going to make these two surfaces, there's going to be the stockpile top and the stockpile base. When we make the base, normally, like we would say, use those points, use this as an inclusion polyline, and then and it builds triangles across the bottom of it here to make that flat type, or the edge to edge as the base of the stockpile. And that's if we keep that as a 2D polyline. Now, one of the things that we can do with that line, instead of having it as a 3D, and I'm going to erase it again, and I'm going to draw shrink wrap, which is on my draw menu, shrink wrap entities. And this time, instead of a 2D, I'm going to use a 3D polyline. And when I do that, I'll show you the advantage of doing that. So I'm going to select all my data here. There it is. I've still got those extra little close-in points. Let me I'm going to select that and remove these little non-applicable points. I'll just sort of work my way around, make sure it's only pointing to toe, 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 toe. There's a base, so I want to remove that one. I have to do that one twice because that's where it started and stopped. So now it's toe to toe to toe to toe to toe, all the way around our perimeter. So now we have it, but it is a 3D polyline. Okay, so now when we make that base surface, remember it's going to read anything with elevation. So those points all have elevation, but I could even do this if let me go to my points manager for a minute, point group manager. I'm going to create a group called toe points. Unchecked include. By description, it is starts with anything and includes toe. Save that. There's now all my B toe points are there. There's a group. I'll say okay. And I'm going to go to points, and I'm going to erase points by group. My toe points, say okay. From the coordinate file, no, I'll keep them in the file. Delete the symbols, yep. So now I've got this polyline, but it has elevations at all of these vertices. And you see in my properties, if I step through those vertices, and you can see where the little marker is, it tells you those elevations, and those would directly correspond to those points that we saw earlier. Okay, but it is a 3D polyline, and because the triangulation process is going to read the elevations of that polyline, that's really the only thing we need to select to make the surface. Okay, we also need to select it as an inclusion boundary, otherwise it fills in these little gaps. So let's go to triangulate and contour on our surface menu, very first command. We'll take that, we're going to write the file. So we have that checked. We're going to choose select, and we'll call this SP-base, stockpile base. We'll say save. We want to turn on to use the inclusion exclusion area because we're going to use that as its own trim boundary. We'll ignore zeros, minimize flats we don't need because it's not a source of contours. And I'm going to densify these break lines. So I'm going to go every 5 feet and drop points. So it's going to put additional little triangles in there. And you'll see how they work here in just a minute. And I'm going to go to contour, and I'm going to make sure that's unchecked for right now. Labels is off, selection, nothing checked. So I'm good to go. I'm going to say okay. Reading the prompt, read the line above, inclusion perimeter polyline, more than one possible. I'm done with that selection. I hit enter. Now, again, read the line above, select any exclusions. There are none. I just hit enter. And now select the points and break lines to triangulate. Well, the only thing I need is that 3D line that I just created. I did it. I selected it, hit enter. It made the point, or made the surface. And I can view that surface in my 3D viewer just to verify. And there it is. And I can turn those on and off, and you can see all along here, you see every 5 feet, it's placed a little point. That's that densification. Okay, so it has densified those. Now it still made these long triangles across here, and it made this long flat, and that's okay. It's sort of a, it's to be the flat part of our surface. That's going to be our little base. Now you're going to find that when we do our volume comps, you may get a little bit of cut instead of total fill just because of that little turn up on that point. I think it's got a bad elevation on it, really. But anyway, we'll take a look at it. Let's see. All right, so now we've done that. Now, let's repeat that command, surface, triangulate, and contour. And let's change the file name now from stockpile base to stockpile-top. And nothing else we need to change. Although while we're here, let's go ahead and hit the contour tab. Let's have it draw the contours for us automatically. We could do that as a separate command, but we'll do that here automatically. And I'm going to set these on a layer. I'm going to put that on a layer called V-surf-CNTR-MINR for minor contours. I'm going to go every 1 foot as my interval. I will also draw the index contours, meaning I'm going to put them on a different layer here. So V-surf-CNTR-MAJR. So I'm going to do that. I'm going to leave my smoothing off, none of these adjustments. And I'm going to look at the labels tab now and turn that on. And I'm going to put this on a layer called V-surf contour. I'm going to change it from, that's if I labeled the minors. So minor label. The label style will be this contour label. The index layer is V-surf contour major LABL label, a style called contour label. Now, none of these things exist yet. And that's the beauty of this, is that it creates them on the fly when it needs them, and you can go back and modify them later. There's it label text size scalar. So it, whatever my scale is set in my drawing, I think it's correct. It's going to be 0.08 of an inch when plotted at that scale. Now, all of these different things down here, you can control how this works. You can actually physically break the contour it generates at the label, give it a buffer distance, and then you can also tell it a layer name. So if you draw the broken segments, you could put those on a layer that you could freeze layer and turn those off. However, much like we did the points on the little subdivision, we're not going to break the contours. We're just going to come down here and hide the drawing under the label. So it's going to make a text with a wipeout behind it so that it hides the contour line underneath it. And we're going to say label those index contours only, align the text with the contour, and draw them on the real z-axis. Again, I like to see them up where they're supposed to be. And then you've got your intervals. You can set specific numbers per or a particular distance interval. And I'm going to set this at a distance of every 200 feet, let's say. And I'll say, okay. And now here's my inclusion boundary. No more, no exclusions. I now select everything. So I'm going to also get this base, which forms part of the top, as well as the points in the middle. And I do that, and it not only builds the file, but it draws the contours for me, okay, on those particular sizes. Now, those text sizes are a little big, so I'm going to fix that. I'm going to change my drawing setup. Instead of being a 50 scale drawing, let's make that a 20 scale drawing. And I'm going to change that LT scale to 1 just because the way we're going to treat those. And I'm going to say, okay. And so now, and I notice my changing here hasn't changed the annotation. And I've also got this particular style, which is, if I choose that, and of that group, which is the text and the wipeout, if I choose the text, it has a style called contour label. It is that annotation scaling, and it's a paper height of 400. So that's because of the way it created it earlier. So I'm going to recreate those. So I'm going to go back to the surface menu, and I don't have to build the file again. I'm just going to contour from the tin file. And I'll choose my file. There's that SP top. And again, you can restrict this as well with this inclusion exclusion areas. I don't need to have it on there now because it only goes out to the edges. But let's say you only wanted labels to appear in a certain part of it. You could draw another polyline and do that if you wanted. Well, that's fine. So go to contours. They're there. I go to labels, everything's there, and I'm going to be at 0.08 now that my scale is set correctly in my drawing, but I'm going to go back to the triangulate tab, and I'm going to say erase previous contour entities. I'm going to pull that down and choose either current surface or all contour entities. That's fine. I'll just say erase the previous, and I'll say okay, and it didn't erase the previous. All right. So it should have. Let's see. Maybe because it was off when I created it the first time. So if I want to get rid of those particular pieces of text, I can select them, select similar, or let's choose another command we haven't used yet. It's called edit erase by layer. Notice the icon, and that's on our layers toolbar. Very good, useful command. So I can either type the layer name, select it from the list, or select it from the screen. So I just pick one sample. There's the labels, and let's might as well, in case we've doubled up on, we got 2 sets of polylines there. So I've identified those layers, and now you can restrict it to certain things or just all things on those layers and say, okay, now they're all gone, which is what I expected to have happened earlier, but it didn't. So now if I go back to surface and contour from tin file, choose my SP top, open, and now say okay. Now they go, and now my labels suit my size a little bit. Now, one thing I may want to do is, like, I don't need these points anymore. I can either erase them or I can even do this. Now, this is one that I want to point out, but I could say freeze points, for instance. And let's just freeze all points. Whoops. Let's see. Let's freeze points. All points. Our description match would be asterisk. I would say okay. And freeze the symbols. Okay, that's fine. Any text. So now they're still in the drawing, but they're frozen. Now, what it does, I'm not sure exactly how it does it, because it doesn't, if I look at my layers, you see there's not a frozen layer. So it doesn't put it on a different layer and freeze it. It just freezes those points. So that's sort of a temporary command, but if you don't remember to go back and pull down the points menu and you choose freeze point or thaw points, if you don't do that, I don't know what happens to those if you save the file and come back in. They may reset themselves. I'm not sure. Okay. But I'm going to, since I don't need the points anymore, I'm just going to pull down points and erase the points. And I'll say from the screen, and I'll just grab everything here. Erase the points. No, don't take them out of the drawing. Take out both. All right. So anyway, that freeze points, just be a little wary of that if you use it. All right. So now, what have we done? And here's a reason that I said we're not going to break the contour line, because if I select this line, you see how it continues right through those wipeouts. The reason I'm not going to do that is because I can now also do this. Go to Surface, Contour Utilities, and I'm going to come down here to the next to the bottom and choose Move the Label along the contour, because I've got some labels in some weird places. So I'm going to choose that, and I'm going to get this off this corner. So I'm going to select that and just choose that. And so I can now move this, and I'm just moving the mouse. I'm not snapping. So I'll move it out to here so it's more there, and I keep going. Here's another one in the corner. There's another one that's sort of on the corner. Let's put it up here a little bit further away. That looks okay. That looks okay. That looks okay. And notice it rotates automatically. If you were to move it around to here, you see how it moves itself where it needs to be accordingly. Okay. So with that, and the reason you didn't get a label down here was in that contour from 10 file, we had on the labels, there's a switch that says a minimum length to label right here. So if it's not long enough to label, we can control that. And so I'll cancel that. All right, so there's now our contours. Notice they came in red and white. That's the default if the layer doesn't exist. So let's change those layers. I'm going to go back to View, Layer Control, or choose it from my toolbar, or go to your layers palette on the AutoCAD side. And let's change those. Here's my contours, my major contours and labels, and my minimum contours. So I'm going to change their color. Instead of red and white, I'm going to make these, the majors, I'm going to make this 253, that gray one there. And my minor, I'm going to make 251, which is 2 down from that. So they're going to change color. So they're going to look more like that. However, you might want them to be dashes. So again, because their line style is set to by layer, you could change their layer name or their layer type or line type, I'm sorry. For major, I'm going to look at continuous. Well, I've only got continuous and -2. And now this is pure CAD stuff. So I'm going to come down here and load. I'm going to load up some layer or line styles that I have. And right now they're pointing to this icad.lin file, but I could, scroll down and find all kinds of different ones, Carlson, different ones you've created. So if you don't see that, if you don't see the one here, just hit browse, and you're looking for a one called iCAD, or you should see, I'm not sure, you might look for the Carlson in the AutoCAD version. Let me see what that's going to be.
I look at this index contour, my line type, it's not there. I load. I'm looking at acad.lin, but I don't think it has the one I'm looking for. It does not. It's a contour. But you can find this, the various dashed ones. I would get like dash, dash 2, and dash x2 and play around with those and see how they fit what you, how you would like to have that displayed. So back to us. Now I'm going to load from this ICAD file that's given to me these two particular line styles, and they are just dashed lines, but they're called contour and contour 2. So I'm going to select both of those, load them into my list of availables, and now I'm pointing to the major, so I want the bigger dash, which is contour. So longer dashes, I'll say okay. And my minor, I'm going to make contour 2, which is the smaller dash. I'll say okay and okay. And now there it looks like if you regen. Now, remember I set my line type scale to 1. So it looks like my dashes are awfully close together, but I need to also couple that with setting MSLT scale and turn that on. And now if I do a regen all, they spread out to be a little bit nicer for what we're looking for. Okay. And I can even do something like this. If I keep my global line type scale set to 1, but if I want these to all be, now I've selected one of each, I'm going to right click and choose select similar. So it gets all the contour lines, and I'm going to come up here and just for those lines selected, I'm going to set its line type scale down to 0.5. Okay, and so now they're a little tighter, a little smaller together. Notice, and if you had something that looked like this, where every time it hit a vertex, it recreated the start of the line style, and you see how that goes, that, all solid pieces. So you want to make sure you have the properties set for line type generation. It needs to be set to on. And I think it does that automatically when it creates these. But if not, if you notice that as a problem, then you can fix that. And here's a case where it goes through this little gap. See, the line is actually defined in there, but it's just fell within a gap. So you can adjust the line type scale. In fact, if I get at least 2, select similar, and let's tweak that down from 0.5 to let's make it 0.35 maybe. Now you can see a little bit more of how that goes through that corner. All right, so that's, and it's pure cosmetics, but that's how you can set those. All right, so now we have that done. So how do we compute the volume of material that's in it? Well, first of all, let's take a look at our surface file. And again, view, 3D view, and we got these two different viewers, which is really the same viewer. One loads up things from the drawing, one loads up things from a surface file, but they can interchangeably add these different things to it. So if I choose my surface file viewer, notice the icon tells me it's on a toolbar. I don't know what toolbar it's on. However, you see that command surface file viewer? Here's a little help for you. You got a command you use. Let's say we're going to use this command that's on my polyline utilities, and I want to use this remove vertex. I don't know what toolbar that's on, and I want to know where it is so I can have that toolbar active. If I go to the help menu, there's a thing here called command search. And when I do that, it's going to bring this up and basically show me every command. Well, that was remove polyline vertex. So I just start typing remove space POL. Now I say I've got arc segments, vertex, and blips. So if I just select this one here, vertex, it tells me what menu it's on. It's on the edit menu. It tells me it's on a sub menu called remove polyline. It's available in all of the modules. Here's the typed name of the command, and here's the name of the toolbar that it exists on. So I would turn that toolbar on, which is up here, and it uses that same icon. Okay. So some of these you'll see some commands and it might list it, it's on civil only, or
GIS only or something. And if you don't have that module, then you're not gonna be able to use it, but this lets you find any command and find out whether it lives on a toolbar, and if so, which toolbar it is on. And if it is not showing, you just do like we did the first day, you show that toolbar, there's Carlson, we come down, there's our polylines toolbar, which is sitting right up here. Okay, so same thing on that view. If I did that command search, that was my surface file viewer. So I'm going to type surface file viewer. There it is. I've got one here, one here. One's called, it's on the view menu. One's on the surface menu of civil, but it's also on all modules on the view menu, and it's on this toolbar called surface, the Carlson surface toolbar. And it's called cube surface is the type name. So I would do it that way. So civil has it actually in two different places, one on the surface menu and also on the edit menu or the view menu. So it's on that surface toolbar. That to me, and you can actually run the command from right here. So if I run it, it's going to just run it. So there's my SP top. I'll open that up, and now there's my stockpile, not very tall. You can see underneath it there. I can give it some vertical exaggeration if I want to see it exaggerated. So, okay, well, I see, what it's looking like. I'll put that back to 1. Again, on our settings tab, we can display the contours. And you can even, let's say instead of 1 foot, you want to say let's go over 0.2 feet. So that would be contours every 0.2 feet as if we had drawn those at that interval. Again, it's just doing it in memory. So and that would look just like the contours that it created out here in our model that we drew in the model. All right, so we got a file. If I go back to that viewer, I'll load that up. So there's that viewer. I'm going to go to my model tab, and I'm going to hit this load surface button, and I'm going to load the base. So you can see that. Now it's a different color. Now you can see a little bit. I'm going to spin this up, and you can see there's the base, and you see how that base sort of leaks through the existing over here, and that's because of that little turned up corner. So when we do our volumes, you're going to get a little bit of this material in here that's going to show up as cut material instead of all of it being fill, but you just have to be aware of that. And you could go through and fix the point that caused the problem and all that. So how much material do we have in the stockpile now? So again, on the surface menu, we want to choose volume by triangulation. We have 2 surfaces, so I'm going to say 2 surface triangulation. And it says select the existing surface, and that's going to be our base. So it depends on which order you choose these. So I'm going to say from the base. And then it asks me again to pick a surface, but reading the top line here, it says select the final surface. Well, there's going to be the top. Okay. You can also limit it to different inclusions. I don't need to select any. It's just going to go to the edges, any exclusions as well, shrink and swell factors, whether if you want to use tonnage or different stuff. I'm just going to say okay and get my numbers here. All right. So that's why I've got just that little bit, 1.5 yards of cut. That's those little tweaks up in the corner. But to fill that stockpile from the base up to the stockpile, I've got 3,200, 3,287, 3,250, whatever rounded yards of material. Now, there's a couple of other things in these volume reports. It converts it into an equivalent area and shows you in cut and in fill, those in daylight. And then it also computes this average as if it were a cube. So on an average of 3.6 feet, and it gives you the cut to fill ratio, which is at this point 0 because it's all fill. The import volume, that's what we would bring in to make the stockpile. Now, notice that next 2 lines here, the elevation change to reach balance and the volume change per 1/10 of a foot of elevation change. So right now, if I wanted that fill volume to be 0 compared to the base, I would need to raise that surface up by 3.5 feet, that 3.5, or not raise it, but lower it. Because every 1/10 of a foot, it's going to generate 93 yards of material. So we use that not in stockpiles, but in terms of trying to balance a site. Let's say we designed a site and we've got all of our design, our final grades, and we think we're a little bit heavy, we have to bring in too much fill. You can run this real quick and see that, and if it'll tell you, just change the elevation of that target surface by this amount and you'll reach a balanced condition. Okay. So you could do that in that regard. Now, there's a couple of other tools in Civil that you can use to help you exactly match those things, and it does it through an iteration. We'll talk about that when we do our borrow pit. Okay, so now we're going to design a little borrow pit area out of our stockpile that we're going to say we're going to use that to take stone out of and haul it off to a site. All right, so in Survey, under Surface, we have this thing called Design Pad Template. And that's going to be where we set the edges of this outline that we're going to give it and say, take that outline wherever it happens to be and generate a surface either inside or outside. So we'll create that design pad. Now, in our case, we're going to draw a closed polyline. It's going to ask us for that elevation. That'll be the bottom of our fill, and it will go out to the outside and lay back the banks at a certain slope. But design pad template as a command, if I choose that, I see up here at the top that, and I'm going to be targeting a surface file, not screen entities or a particular elevation. You could draw it and target a specific bottom elevation or top, whatever. But this says slope direction from closed pad. So in our case, it will be closed, and we're going to go either to the outside or the inside. But this, and that should clue you in right there, design pad template doesn't have to be a closed figure. I can actually have an edge of something like the edge of a parking lot or the back edge of a curb, and I want to tie that down to the existing ground. I can just take that line, that edge, and say, tie that into that ground at a 4-to-1 slope or whatever, and it will do that. And it will do it whether it's in cut or fill. It will create all that line work for us that we can then use to build that additional part of that surface. So that basically the tie edges. So that's useful for doing things like, let's say you put a ditch line in that represents the bottom edges of a trapezoidal shaped ditch. And you've got it in, it's certain, it's a 3D line, you laid it in the file, and now you're going to use design pad to take the edges and you're going to push them up to hit the surface at a particular slope. So it doesn't have to be a closed figure. And I'll show you how that works with a real quick example here. Let's draw a 3D, well, no, let's just draw a 2D polyline. No, I'm sorry, let's draw a 3D polyline. We'll draw a 3D polyline. Let's prompt for the elevation and slope, and let's also use a surface model from a file, okay? And at this point, let's say, okay, let's going to change the layer name. We'll put this on ditch. Set the color to be bilayer. It'll be white when we draw it. So we'll say, okay. And now it wants to know the surface that we want to use. We're going to use the SP top. So now it's going to show me as I draw around here, you see, as I move, it's reading the surface. So it shows me what that is. So I'm going to say, draw a point from here. Now, you see what it said? It read the surface elevation down here at the bottom at 398.3936. Well, I'm going to do an adjust on that. And I'm going to drop that 2 feet under the ground, so -2. Now I'm gonna come down here and put this ditch, say down over in here. It read that elevation, and I can either accept that elevation, or I can put in the slope that that's going to be, or I can adjust it or whatever. So I'm going to give it a percent slope. So I'm going to say P, so the slope I want is going to be a minus 2.5%. So now that's done, and I can hit enter to finish. So now I have, if I look at this stuff in 3D, in my 3D viewer, you're going to see that 3D line sitting underneath the ground, 2 feet deep up there at the top, and it goes down to the 2.5% slope. Okay. Now, using design pad, well, let's first of all, we want to make this a 2 foot wide bottom on our ditch. So how do we do that? If this were a 2D polyline, I would just use a standard offset, and I would offset that 2 feet. But because it's 3D, I can't do an offset. If I tried to do a standard offset, I'll just choose my offset tool over here in my modify, and I pick that, it's going to complain to me. Let me see, let's offset. Oh, it's looking for a distance. Let's say a D. All right, specify a distance. We said a 2 foot. All right, so 2 feet. Now select the entity. I'm going to pick that, and it says, we go off to here, we tell it which side, but it says, I can't offset that object because it's a 3D object. It won't let you. But Carlson has a way to do that, and it's called a 3D offset. And it's also on our polyline toolbar, or it's under Edit, 3D Polyline Utilities, Offset the 3D Polyline. Now you can offset this polyline by different methods up here. You can say, if you want to offset that line a certain distance and then lay that along the top of this, along that surface, you could target the surface, or we could go by interval because we want to go 2 feet over. That's our interval horizontally, and we want to keep it the same elevation as this line. So we'll say a 0 vertical. So our interval method, we'll say okay. It's going to ask us on the command line, horizontal offset amount is 2 feet. Now the vertical offset amount will be 0. Now pick our line, pick the side. So there's the bottom of our ditch, but where does it come up and tie back into the existing ground? And that's where we're going to find that target. So you can do that again with that offset 3D. If you target a surface and say, okay, we're going to pick, let's see, rounded corners, yes, but there won't be any corners. And we want the slope to be defined by a ratio. We're going to use a 1-to-1 side slope. We'll say ratio, pick a polyline to offset. I'm going to pick this polyline. It's going to target my SP top. And if I want them to be 1-to-1 or 4-to-1 or 3-to-1, whatever it is, it keeps the last one I use. I'm going to say just 1-to-1, and 1-to-1 if it's in cut, and I'll pick this. Now pick the side to offset is over here. Select another polyline if you want. This one, same. Let's make this one 4-to-1. So you can see it's a little further out. Okay, so now those are lines that if I were to look at this again in my viewer, notice, and let me go to model and add my surface back so you can see it. Those two lines are sitting right up there on top of the surface because I targeted that. The bottom lines are down there. So if I were to make a surface now out of those 4 lines, that would be that ditch, okay? But here's what Design Pad does for us a little bit differently from this. I'm going to select these and get rid of them. And let's go to Design Pad Template, which is under Surface, Design Pad Template. I'm going to now target a surface file. And I'm going to go by ratio. It won't matter here for the outside or inside, 'cause I've got a non-closed figure. And I'm going to come down here. I want to draw these side slope polylines and color them. And they'll color them blue if it's in fill, red if it's in cut. And I can specify a spacing of how often I want to see those sidelines. I'll put them every 5 feet, every 10 degrees around the corners. That won't have any effect for us. Shrink and swell factors, etc. If you want subgrades, there are all kinds of adjustments you can do while you're doing this. Trimming other contours that are drawn within the perimeter. Again, it's not a closed figure. And finally, a layer. I'm just going to call that ditch dash grading and say, okay, now I'm going to pick this polyline, this surface, and I'm going to go ahead and use those 4-to-1s again. And I'm going to go to this side. Now, do I want to adjust that and redesign it? So if it was too much, I could say, yep, let's do that. Let's change it instead of 4-to-1. Let's go with 2-to-1 and 2-to-1. No adjustment on the top. Offset the top, no. So now it's straightened that back. So now I'll say no, and I'll repeat the command, making sure you do not have erase previous pad entities checked on because we want to keep those. And we'll say, okay. And we'll pick our pad polyline, which is that. We'll pick our surface, which is our top. We'll keep it as a 2-to-1 and a 2-to-1. We'll pick the side. So we'll go out here. Now, what we've done, and this is nothing more than just visual aids. So if I were to select everything here and view it, I can now get a real good sense of what that looks like. And even if I add the surface model to my view, and let's open up that surfaces here, right click and set properties, and let's make it about half transparent. So now you can see that that ditch would sit underneath that surface and it would come up and tie into the existing ground right along those edges. Okay. So then what do you do with that? Well, typically you would isolate the layer, build a surface out of this, call it ditch. And once you had that surface, and I'm going to restore my layers, you could then go to your surface menu, triangulation file, utilities, and load up that original file. Go into the next area here, turn my colors back on, and then you would choose merge 10, and you could take that ditch that you made as a surface and merge it into this, and it would become one continuous surface at that point. Okay, so that is the technique that I use to do things like parking lot design. I'll design my parking lot edges edge to edge, and then I'll draw in 2D, I'll draw any interior islands that form part of that parking lot, you know, part of the parking spaces and the islands and stuff. And then I'll drape those 2D lines on that temporarily created parking lot surface. And I'll do a 3D offset, and I'll set the top of curb and the back of curb. And then I'll make a surface out of just that curb structure, and then I'll merge it into my parking lot curb, and now it's all one contiguous surface. But I don't have to do all that stuff in one single step. I just do these in piecemeal fashion. And that's the way we're going to do our road. When we put our road in here, we're going to tie into the ground based on these cut slopes. So I'm going to erase all this stuff. I just want to show you that Design Pad will do these different types of things for you as well. So I'm going to erase by layer. Remember, that's my little pencil eraser over my colored layers. Now, notice my list shows things that I previously had. So make sure you hit clear if you want to keep those. Well, I did. So I'm going to select from the screen. I'll just pick one of those layers there. Let's maybe do a little crossing to make sure I get the ditch polylines as well. So it gets ditch and ditch grading. I'll say okay, and now all of that stuff's cleared out just based on that layer erasure. Okay. Now, let's design our borrow pit. So I'm going to draw a 2D polyline, just a 2D, and I'm going to put this on a layer now called borrow dash pit. And say okay. And what you want to do is let's draw a line that looks sort of like this. I'm going to sort of parallel that back edge to there and come out this direction, maybe in here, and then come down to right in here, come back sort of parallel there, and then let's close it to that. Now this is going to be what I'm going to excavate within this to take out material to make my borrow pit. Okay, so it could be that I'll need to adjust this and bring it in a little bit. I might be too close to the edge out here. Remember, this stuff is material that's higher above it. So I've basically just drawn the bottom of my pit, and I'm going to take design pad and tell it to push out to find that surface, whether it's in cut or fill, and then adjust things accordingly. You know, to draw those lines that I can then make into a separate surface and then merge. So let's go to our surface and choose design pad template. And this time, instead of ditch grading, I'm going to call this one borrow pit. Don't need all this extra stuff grading here. Just call it borrow pit. And we're going to go from the outside because I'm going to tell this it has a certain elevation and I want it to climb out and hit the existing ground. So I'm going to go to a surface file and I'm going to go to the outside. And I'm going to say, okay. And now it says pick the pad polyline. Well, there it is. It's 2D at this point. Pick my surface. There's my top surface. And let's put these out at a little milder 3-to-1 side slopes. So cut and fill. And now it says, what's the pad elevation? And it suggests 395.19. And what it has done is it's walked all along that perimeter and says the range of existing elevations along that pad range from a low of 395.19 to a high of 404.40. So that just as a reference point, and the suggested elevation is 395.19. And you could take that or you could set it to something even lower or higher. So let's set that instead of 395. Let's punch it into the ground a little bit. So let's just call that say 2.5. So now you notice what happens at warning point such and such is off the surface, and that was back here because I was too close. So you can adjust and redesign. So you can either steepen up the slope. So let's do that. I think we used 2-to-1. So if it's going to be too steep. I'm going to say, no, let's not do it. And I'm going to erase by layer again and clear, select from the screen. There's that borrow pit. Actually.
So at that point, when you're just erasing entities, they're not really, they're just entities, they're not surfaces.
That's correct. We have not made a surface file. So now I'm going to do this a different way. I'm going to isolate that because I managed to put this on 2 different layers. I've got, or put them on the same layer. I should have named my pad layer a different layer. So I'm going to select all of this. I'm going to shift click on one of those and then erase that. So I'm going to keep my original. So that's on borrow pit. So this time I'm going to run, or when I run it, I'll change the layer name. But what I want to do is to bring this off of that edge a little bit. So I'm just going to select it and right click move. And just move it down a little bit off the edge and see if that's enough to do it. Okay, so now let's go back to design pad template. And let's change that from borrow dash pit dash grading. We'll put that back in now. I'll say okay. We'll select our pad polyline, we'll select our surface, we'll give it, we'll keep the 3-to-1, 3-to-1. And so that was enough when I pulled it back in here, and it kept that elevation because it already adjusted that line. So no, don't need to adjust that. I'll verify by a quick peek into my 3D viewer to make sure everything looks the way I expect it to look. Maybe add the surface for a little bit of context and give it a little bit of transparency so I can sort of see through it. And I see there, now that looks like what I might want to have. All right. Okay, so now the next step is let's make a surface out of just that. So let's isolate that layer. I'm going to view, isolate layers. I'm just going to pick one of these sidelines. So again, just like Frank asked, all I've done is create line work. But now I want to make a surface out of this. I've already got the boundary created for me as part of it. So I'm going to go to my surface menu, triangulate and contour, and I'm going to go to my contour tab now and turn that off. I'm not going to draw the contours. But back to triangulate, I'm going to click on to write the file.
Is the boundary is that boundary a 3D polyline at that point?
It is, yeah. But
With
it doesn't,
elevations?
yes,
Where
but
it hit the surface?
well, yeah, I mean, it hit the existing ground right out here, but it is a 3D polyline. Everywhere it walks along that, it's also on that existing surface. Now, it wouldn't have to be. I could make that a 2D, and then it reads the endpoints of these red lines, which are 3D, and they end down there at that intersection point. So I can leave it as 3D. It's absolutely fine to have that as such. So now I'm going to call this my, as a surface, I'm going to call that my borrow pit and say, okay, I will turn on to use the inclusion areas. Ignore any zeros. I don't really need to densify the polylines because I've got points every 5 feet or whatever I settle on there. So they should be fine. So I don't need to do that part. And I'll say, okay, reading the prompts, inclusion. There's the inclusion, no more inclusions. Now, I want the surface to include this floor, so I'm not going to treat that as an exclusion. So I'll just say no exclusion. Now select the points and break lines to triangulate. I grab it all there. It's done. It wrote the file. I look at the file to verify. There's my borrow pit. And there it is. And you can see with the contours turned on, or you can even turn them off. Show the triangle edges. You see every 5 feet it made those edges. You could also, go back and select things out of the drawings, and it will superimpose them. And there's the surface that it built. Okay. Now, one of the things too is if I were to build that as an actual borrow pit, I've got it at a flat level elevation. I might want to put a little downslope to it. So as part of design pad template, you can choose to use a slope pad design, and you set a slope percent, and you can give it a direction and all of that. We'll just keep things simple and just keep it flat for now, but you could have done that already. And then you would see contours that cross it at that represented slope. So now we have this target. I'm going to now restore my layers. So that was the button beside the isolate layers, or view, restore layers. And I've made a surface of my borrow pit. I've got a surface called top. And if we wanted to put those into, well, first of all, we could calculate the volume, see how much material we get out of that. So under surface, volumes by triangulation, a 2 triangulation surface volume. Our existing surface is our top. The final is our borrow pit. And no need to set this as an inclusion because it ignores this because they don't overlap in that area. So I just hit enter, take my defaults here, and here's my numbers. So I have
3,116 yards of material in that borrow pit that I just designed. Now, with that, let's say I really needed 5,000 yards of material instead of 3,000. Well, I'm going to look down here and I say, well, if I were to raise that or lower it, every 1/10 of a foot, I'm going to get basically 53, 54 yards of material. So if I need another 2,000 yards, and every 1/10 of a foot, I get 50, so 2/10 would be 100, and I need 20 of those. So I would raise that, or not raise it, but lower it an additional 4 feet, and that would give me that 5,000 foot target. Okay, so that's one way of doing, to use these numbers to, and they're not going to be totally exact. This is if it is a cube, what you would have to do. You would do the math and figure out how much to raise or lower it to reach it says to reach balance. If I raised it up 5.8 feet, it would be a zero, it would balance 0 to 0. But if I wanted to go from 3,000 to 2,000 or 2,000 more to make it to 5,000, I need to look at this and I see every 1/10 of a foot, I get 50 yards of volume change. So if I need 2,000 more, so 2,000 divided by 50 is going to be 4 more feet. So if I drop it an additional 4 feet, that would give me that 5,000 cubic yards. Now that's really going down. We're already down below the base of our stockpile to begin with, but you see the idea of how we're going to use that. Now, what I want to show you, Frank, is the civil version of this tool. So save your drawing and then switch to the civil module for a minute. And if you're using civil, under surface, you've got not just design pad, but you've got edit pad template. So if you choose that and now pick the pad polyline, so there's that pad polyline, this little control comes up and it reads the fact that that was set with 3 to 1 cut, 3 to 1 fill, and it has an elevation of 92.5. Now you could do things like you could move the pad. And if you do that, I'm just going to move it from here down to here a little bit. So that's where it's going to be. And I'll now reprocess that. So it changes it and recomputes it. And you see it reads me, I've got 3,012.6 cubic yards of material. And it kept that elevation there. Now I could, I can move a corner, I can rotate it. Do all kinds of things to it. And one of the things I can do is balance. So if I choose this balance button, now you have to have run process at least once. Once you've done that and those numbers come up, now I choose balance. It's going to bring this up. Now here's where balancing is typically 0 cut, 0 fill, but we want to haul out of there 5,000 total yards of material. So I can set my balance target to be 5,000. If I say okay to that, well, then that, of course, I ran off the edges. So that, and it changes the elevation to 389.2. It kept the side slopes at 3 to 1, 3 to 1. I can use slope groups and say on this back side here, there's 3 to 1, 3 to 1 for slope group 1. I might pick this segment for slope group 2. I'll pick in there, pick for slope group 1 would be this. I have to pick each of those segments, but then I could say slope group 2, let's pick, sit on their current, and we'll pick from and to, we'll go from this point to this point on this back side, and we'll set that to be a 1.5 to 1. And we'll say, okay. And now we'll reprocess. You see how it pulled that slope in differently? And it kept all those others at 3 to 1, but it kept that at 1.5 to 1. So there's a lot more additional editing that you can do on this and have it automatically calculate all this kind of stuff and reach not just a 0-0 balance, but a targeted amount of any of those given things. So in survey,
That's
we had
very
to-
useful.
yeah,
Very
so
useful.
yeah, good. So in survey, we had to look at that report and see how much change we get out of 1/10 of a foot and decide, and then raise it up and recompute it and recheck it and that kind of stuff. So civil gives you that additional tools. Okay. Now, and then you can write the 10 and do all that kind of stuff. Now I'm going to just exit and I'm going to undo my way back to where I was before. Oop. If I ever get there. So one thing I don't like about IntelliCAD is I can't pull that down and choose the point. I have to just do it sequentially. Well, I'll tell you what we'll do. Instead of doing it that way, because I think I ran out of my undo buffer space, I'm going to erase my layer again and pick the pad. I think I lost my original polyline. How many things do I have in there? Oh, there's 2. But they're both on grading. All right. So if I select everything, unselect one of them, and then erase it. That I want to put that not on borrow pit grading, but just borrow pit. Oh, it was frozen. That's why I didn't see it. Ah, that's stupid of me. So now I still have, all right, there's the 1. And let's set it, this elevation back up to 392.5 where we had it before. We're in a slightly different position, no problem. Let's move it back a little bit off of this corner here because I need to get a road in there. And now let's go back to survey and let's recreate that. So design pad template, keep everything like we've had it. Say okay, pick my pad polyline, pick my surface, 3:1. There they are, no redesign. Check my volume here. Going from my top to my borrow pit. Oh, nope. What have I not done yet? Remember, I recreated that in a slightly different place, but I need to remake that surface, right? So don't lose sight of that. So if I recreate the surface first, triangulate and contour, I'll keep that set to my borrow pit 10. Everything's the same. I'll say, okay, yes, overwrite. Select the inclusion, no exclusion, select my points. And now there's my surface. Verify it real quickly and look at my surface, go to model, add these things, make sure my edges all line up and everything looks fine. All right, so we're good. Now I restore my layers and now there's my borrow pit. Now I can check my volumes by triangulation to surface volume. I'm going to go from the top to the borrow pit. No inclusions, no exclusions. Take the defaults, and now I'm back to close to what I had before, a little over 3,000 yards. All right, so there we've successfully done that. Now, how, if we want to put that and merge that into this surface to have a new surface, would I do that? And we would do that with our surface triangulation file utilities. And it's going to pop this up. Now, again, it's a floatable, resizable window. So if I load my 10 file, I'm gonna load the outer one. This is that top. And you can turn those on and off and spin them up much like in the viewer. But I need to go from this screen to the next screen. And now don't choose add. I'm not going to add that surface to this surface. I'm going to merge it. Add means to add a numerical value to it. So we would raise that surface up and down. That's another way. Remember that every 1/10 of a foot change, if I needed to raise it negative 4.5 feet, I could do it this way to that surface and then had to adjust the edges where it ties in. But anyway, so I'll turn this back on, spin it up a little bit. I'm going to merge this surface. Now you have different choices on how they work. Usually this default is going to be fine for us. We're going to say the second 10 is inside, the current 10 is the outside boundary, and then we're going to transition to between them. And set my color for inclusion and exclusions, and we'll say okay. We're going to choose now the surface to merge into it, which is our borrow pit. And we'll set that up, and there it goes. That's what it would look like now as a combined surface. But to get that surface, I need to make sure down here under output, I'm going to choose insides, the border, and the outsides. So the insides are the green, and the border is this wraparound, and the outsides are the white. So I'm going to have those all on, and I'm going to do a save as, and I'm going to call this SP dash pit dash merged. Okay, now I've saved it. I can exit that. I've got it and can view my surface file viewer, SP pit merged, and indeed there it is. Let's go back to our surface properties and set that opacity back up. And I'm going to use the color from the file. Let's see if that, no, it doesn't. Let's go here. Let's just make it a color. Set color, we'll uncheck that and just say that. So now it's going to show up like that. Did I get the transparency? Yep, that's good. So that now shows me, and you can readjust your light sources as such. Turn on your contours if you want to see what they look like. And that would be the completed total surface. Now, what do you do with that as a surface? And I'm going to freeze by pick this pad polyline layer. I'll just leave that one in there just to remind me where that is. But if I wanted to contour, if I want to do a grading plan, which surface would I contour? And the answer to that would be just the pad. Those are going to be my proposed contours. So I could do this in this particular way. I could go to surface, contour from 10 file, choose my borrow pit pad, just the pad itself. And on the, I don't need the inclusion, but on the contours, I'm going to draw the contours. I'm going to change the layers now from V to C to mean proposed or civil. Labels, I'll do that same thing there. And actually, I'm not going to label the contours. We'll just let them tie into the ones we got. So I'm going to say okay. And there they are. And you can see that red one. So if I take these proposed contours now, and those particular layers, those are my C layers, I'm going to make that instead of red, let's make these solid white. We'll make the design, now let's make that also white. And let's change their line weight. So make it like 0.3 and 0.05, maybe 0.3 is a little too much. Let's see, 0.2. Let's see what that looks like. All right, well, no real distinction. Let's do the majors. Let's put that back up to 0.3 and see if we can see that. There we go. So there's our index contours. You see how they tie. So that would be 400. That would be 399, 398, down to 395, which goes all the way around it to here. But, you know, as it goes around here, it hits 395 and then walks its way all the way back around to here and around. Okay. So that's one way you can draw those contours. What's another particular method? I'm going to erase by layer again. I'm going to clear. I'm going to select from screen. I'm going to select one of the majors and one of the minors. So now they're off. There's just my outline of my, let me change that to, there we go. It's my pit. Now, another way of showing those contours is if you went to surface, you contour from tin file. Let's take it from the merged file. Now, if I were to do this, it would draw all of these contours out here as part of that merged file, okay, because that surface does go all the way out here. But if I use this inclusion exclusion, here's what I can do. Now choose the inclusion areas. I'm going to use this as the inclusion boundary. No exclusions. Oh, actually, that's not going to work. I need to have on my pad outline, which was out here. That's the one I want. So if I now contour from tin file, the merged surface, I'll turn on that inclusion boundary. I'll say okay. And now to set that inclusion, I'm going to say only contour within that space, even though the surface exists out here. I'll say enter no exclusions. Now you could have, you had a straight contour across the bottom, you could restrict that. So now it's drawn that accordingly. I can now go back and freeze my pad geometry. And there now is the very same thing as when I contoured just the borrow pit. That was fine. But if for whatever reason you didn't have the surface, you've done something to it, you can use all of that geometry to limit what you're doing. So these contours actually belong to the total merged surface, but they trimmed off at that boundary line. Okay, so the very same thing happened, if you will. All right, now let's put our road in there as our last step. So the first thing we want to do is create a center line. And the easiest way to do this is to just simply draw the darn thing. So I'm going to draw a 2D polyline, which is draw 2D polyline. And let's put it on a layer called C-road-CNTR. And we're going to start up here on this edge. Now well, let's just start, let's say shift nearest. If I can find it, there it is. So I'm going to start here and I'm going to come off in this direction, say this way. And then I'm going to come down here a bit to sort of be midway in this major area in here. I'm going to click there. Then I'm going to come down here. And then finally, I'm going to go perpendicular to that blue line. So I'm going to shift, right click and get that perpendicular. So that's now is going to be my center line, but I haven't put any curves in it. And again, you can do fillets, or you can turn it into a center line file and add the curves like we're planning to do. And that's going to create the center of our haul road that we're going to do. And you could even adjust this. I may be a little close right in here. Let's pull this down a little bit like so. So let's go to the centerline menu and let's change polyline to centerline file. And we'll call that Hall Road. And it says select the polyline that represented, should have been drawn in increasing stations. That's fine. We did it. There it is. We'll start with station. Oh, let's choose a beginning station of 10 plus 00. It made it. And now to put the curves in, I can just double click it because of that linking. And I'm going to select on any one of these. Let's get that incoming tangent. Let's put a curve in there of a certain radius. So let's fit a curve and see what we can use. Can we use, and this is going to be bad road design. I understand that. But so a 25-foot curve would come around that corner there. Okay, so this one, I'm going to fit a curve, and I think I may be able to make that one a little bit bigger. Let's make it, say, 35 feet. Now, if you put in a number like 150 feet, you see it says it's too big. The maximum is that, and so it sets it back to that maximum. But I'll keep it at 35 and say okay to that. And so now that would be that curve right there that you see. Okay. We'll come on down to this line. I'm going to fit another curve in there. And really it should be bigger, but I'm going to set this one back to 25 and see if that gives me, yeah, see, that's a huge, it's still a huge curve. I'm going to edit that curve and change its radius. Now I'm going to hold the PI points. So I'm just going to change its radius, keep it tangential to previous elements, and I'm going to make it, say, 15. And see what that looks, that's a little bit smoother looking for the total. I'll save and exit, and you'll see the center line changes shape. Now, on the layers, okay, there's my C road center line. Let's make it also magenta, and let's set its line type to be center line, which I haven't loaded yet. I'll come down here and find any of these centers. I'll just load them all up. And I'm going to use center, see, finer dashes. Let's see what that looks like. All right, so there's my centerline file. You could also go to the centerline. You could station that particular one. If I stationed that, I'm going to load up those settings I had yesterday, the training settings. Choose OK, choose my file. There's Hall Road, and there now is the stationing from 10 plus 00 around the curves. There it goes to 11, and it ends at 11:54:65. Okay, now, so we've got a center line, but how do we grade that into our site? Now in Civil, and I won't demonstrate this because we're coming down to the wire on our day, but in Civil, you could create an entire road cross-section template with subgrade depths and all that kind of stuff and tie it in. It's really a lot of sophistication, but if we're just laying this thing out so that we can grade the darn road in, we can do this sort of piecemeal between centerline work and on the surface menu profile work. So in Civil, we have a tool called Road Profile Editor, and that's a separate editor, and it's got a lot of great tools and controls in it, but we're going to use just the standard profile editor when we do this. But the first thing we need to do, and again, Civil does this for us automatically, but we need, as a reference to design against, we need to see what the profile of our existing ground is going to look like along that center line. So I want the profile from a surface, and the surface that I want to profile is going to be that merged surface. So I can see as it comes around here and goes down the bank and all that. So I'm going to profile from a, let me try it again. Let's see, surface, create profile from, not surface entities, because that would take these drawn lines, but a triangulation surface. So I'll choose that. And now I'm going to use that merged surface as my ground. I'm going to say, okay. I'm going to use a roadway centerline, so it's using roadway curve definitions instead of railroad. Linking the profile to triangulation, it can automatically change the profile if that existing grade were to change, or you can not link it or have it prompt you. Station it by other references, etc. You can do offsets, etc. To get like road edges. It doesn't create the edges, it just creates them as profiles if you did offset. So all I really want is the existing grade along that profile. So I choose that. It says now choose a profile file to write. It doesn't exist yet. So I'm just going to call that Hall Road and say FG for final grade. Or not, oh, I shouldn't have called, I should rename that. So I'm going to use a centerline file. So I will type CL to pick the file, and I'm going to choose my Hall Road centerline, and now it's done it. But I want to actually change that name to existing grade, not final grade. So under Surface Profile Editor, there's that one. I'm going to say open, and you see the existing grade. I'm going to go right to down here where it says Save As, and I'm going to change that to EG, save, and then exit. All right, so now I've got that one done. I've also got the finished grade, so I'm going to design on top of it. So I'm going to go back to Surface, and I'm going to use my profile editor this time to design the finished road grade. And I'm going to, instead of choosing this as existing and trying to change all those points, I'm just going to hit the new tab and also keep that same name as Hall Road FG. I'll say open S to replace it. Okay, so now I've just got blank information. I can choose down here the different types of profiles that I want. I want a road profile, but notice these down here, I've got a reference profile, nothing's set yet. So I'm going to set and choose my existing grade as a reference to design against. There it is. I've got a reference center line. I'm going to set that to be my Hall Road center line. So now it's going to tie everything to that same thing. So my reference center line, you see, goes from 10 plus 00 to 1154.65. The reference profile from 1000 to 1164.55. And it just, or 1154.64, 1154.65-ish. It differs in the 100 spot, so that's no problem. I'll just keep that. We'll stop it at 1154.64 will be our total on everything here. So now we want to start putting in our vertical curves. So we're going to start at their starting station here and go to the depth. We want to set that depth of being 0, so it starts right on the ground. And I'm going to go to that ending station. That station should actually say 10. And then I'm going to go out here to my last place and say, what was it, 1154.64, and set that depth to 0. I guess I didn't, it's not 10, it's 10 plus 00, so I need that. No, let's see. Put that depth to 0. There we go, that's what I was looking to do. So I start at my starting station of 10 plus 00. I go to 1154.64, and I have a depth of 0 at each of those places. So I've now established that I'm going to start on the ground and end on the ground. And you can see that profile, and there's that bank, which would come down that bank right there. Okay. So now, what do I want to do with that? I want to put in some vertical curves here. So I'm going to come down here and I'm going to sit here and I'm going to add a row. So I'm going to sit on that row. I'm going to add a row so it goes above it. And I'm going to come in here and I see that station value you see up there at the top line. That's going to be station 10 plus 26 point something or other. So if I just say 1025,
let's say 10, 25, and you could either give it an elevation or a slope from let's put this to 0 here and see what we get. All right, I just put it on the ground there with a depth of 0. It screwed up my sloping. All right, so coming into this point, if I want that slope, instead of being 2.2%, let's say I wanted that to be at a minus 5% slope. What have I done here? This should be 10, 10. Not 10, 10, 10, 0. Good heavens, I'm sorry. 0. No, don't shift. All right, so 10, 10. And now the slope, I'll make, let's make it not quite so severe, minus 2%. I don't know why this is treating me like this. All right, so now there's that. Let's go back to this and put that depth back to 0. All right, so now in this station, that slope, see, let's set that to 0. All right, so my vertical curve, I'm gonna get a vertical curve length there. I'm at station 1025, so I'm gonna just make a 25-foot vertical curve. And you can see up there, there's where that curve's gonna start. Now I'm gonna change that number 2's elevation. Let's bring it up to 395. So 395, tab out of that field. Let's make it a little higher. 390, make it 396, 396. Yeah, there we go. It's a little high, but we'll leave it like that. All right, so 396, a 25-foot vertical curve. Now I'm going to use that to then start coming down, but I'm going to put, I keep having to reset this. This is why the civil editor is so much nicer, because it holds all that stuff together. So I'm going to set another point down in here as I start to come down that bank. I'm going to come over here and I want to sort of make that flat in there. So I'm going to make a vertical curve back here at station that looks like 11 plus 28. Let's make it 1130. So I'm going to sit here. Oh man, this is screwing everything up. Let me. My depths are 0, 0. The elevation. Here. Let me exit this a minute and redo it. No, don't save the changes. Let me try that again. It's all right. Let's do our profile editor, new, finish grade, open. Yes, I'll replace it. I'll set my reference profile as Hall Road FG, no, EG, and my reference center line is Hall Road. My road type, all right, so at station 1000, 10 plus 0, 0, a depth of 0. At station, I want to say 1154.64,
also a depth of 0. So now I want to add a row above here. So at station, let's just go in here-ish at 1050. Let's say 1050. And let's put that elevation at, say, 395, and we'll adjust it here in just a minute. And we'll give it a vertical curve distance of, let's say, 50 feet. So that'll be 25 feet either way. Now, and see in the civil editor, I can just drag that up. Don't have that tool, so I'm going to adjust that elevation right there. From 395, let's put it up to 396. All right, so that's a little better. So that's now setting that. Now I want to come down here. Again, I got to come back to this and keep resetting this. So now I'm going to come over here and set a vertical curve in, let's say at 11 plus 10. So I'm going to sit here again and add a row. 11, 10. And let's set that depth also to 0. And then let's delete this row. Move that row so it's good. So now I've got my point set there with that elevation now. We want to be that elevation. We want it to be like what that one is, like 392. We'll call it 394. Depth of 0. Boy, this is a tough editor. That needs a distance. That needs a vertical curve distance. That's a 40-footer. All right, now let's come back to here. There's a 50-foot vertical curve right here. And let's change its elevation to 396. That was fine. If I set that as a 0 slope. Oh, man. I don't want it to be up in the air. Why is it giving me that? It's these slopes. Oh, there we go. We edit the slope to change the 2 elevation left to right. That's what I want. I think that's where it's killing me. So my 2 elevation, not my, yeah, my 2, edit the slope to change the 2 elevation from here to here. There we go. So now if I edit that slope and make that say -2%, there we go. And now that slope, let's come back to this and set that depth back to 0. Oh, it doesn't like this for whatever reason. Station from station, so 2 elevation left to right. Okay, 0 to 0. There's the first point. There's the second point. There's the PC. I want that to be -2%. The 2 elevation left to right, that should be okay. Then it's at a 3.3, and then it closes back up. Let me save this and exit, see if that clears out this bad condition. Let's repeat it. All road, finished ground. There we go. We just smoothed it out. I don't know what was going on with that. So if I change that slope instead of a -2, let's put that up to just a -1. Yeah, see, that pulls it up a little bit. Let's even make it a +2% up. There we go. So 2% up. There's a slope down. And I'm going to come down here, see if I can set that back to 0. That's good. And now if I set my slope at this point, see, it's everywhere. Every time I do that change, or I set the slope here, I'm going to change my 2 elevation right to left. And I want that slope to be just 0. Now let me save that and exit. Look at it again. There we go. That's really what I was looking to do. That behavior didn't happen until this particular version. Yours, Frank, may not do that. It may be a bug in the version I'm using. It kept screwing that up. But anyway, I've got a defined profile now. It starts at the start on the ground, comes up and it comes around these vertical curves, and it ends on the ground out here at that 392.5. In fact, I could even, change that to be exactly 392.5, but I've got a depth of 0. So I'll just leave it as such and save and exit. So now I've got that profile made. So what do I do with that profile? I need to get it out here on the ground as a 3D polyline. So I can then use Design Pad to set the edges, or use 3D Offset to set the edges, and then Design Pad to tie into my existing ground. So under my surface menu, under these profiles, I want to draw the profile, I think. No. Oh, right here underneath. Draw a profile would actually draw a profile grid like you see in a profile view. I want to profile to 3D polyline. So I'm going to convert my profile file into a 3D polyline. And I'm going to put that on C Road Centerline 3D as a layer name. There's that vertical curve resolution we talked about. We'll say OK. We're now going to choose the centerline file that it's going to follow. So we choose that as our haul road. Say open. Now we'll choose the profile that we designed. There's our little preview. Choose open, and now there it is. So that, if I view in my viewer, I see is that road profile starts on the ground, goes through that vertical curve, goes through that vertical curve, and winds up landing right there on our bottom of our pad. Okay, so far so good. Now let's create our lane widths. So we're going to offset that center line. We're going to offset it. Let's say we'll make a 12-foot wide haul road. So we're going to offset it 6 feet each direction and push it down at 2% from that crown line. Okay, so that's going to be that 3D offset. So I'm going to go to Edit, 3D Utilities, Offset 3D Polyline, this time by interval. Say OK. So the horizontal amount is going to be 6. The vertical amount I'm going to do by P for percent. That's one of my options there. So P for percent. I'm going to go -2%. I'm going to select that polyline, get the 3D polyline, and choose B for both sides. So now there's my lane width 2% down from the crown slope. Okay. I'll hit enter to finish. Now, how do I tie those edges back to the ground? Design pad. So I'll go to surface, design pad template. I'm going to change this from borrow pit grading to road grading. I'll say, okay, I'm going to choose this pad polyline. I'm going to choose my merged surface as my target. So I'll open and I'll put, let's just put 3-to-1 side slopes on that, see if it fits. 3-to-1, 3-to-1, pick this side. And there it is. So it's slightly under. So I got a little bit of fill right in there. It's in cut right here. So it's over right there. It's in cut right in there. So that's good. We'll say no. And then I'm going to repeat the command. Say okay. Pick the other polyline. Pick the surface again, the merged surface. We'll keep the same side slopes, 3-to-1s. And we'll go to that side. And you see how it's done here. I'll say no, no need to redesign. All right, so now what does this look like? If we isolate, oh, I'm sorry, let's isolate the grading and the centerline edges. And let's view that in our viewer. There it is. And you can see what it looks like. Let's go to our model tab, add a surface, which is that merged surface. We'll go to that surface, set its properties to get some transparency on it. And that would then be, and you see as it comes through that bank of their borrow pit, it actually lays back those slopes as part of that work, okay? Now, we haven't built this as a surface yet, and I could build each half of these. See, that's a closed polyline, that's a closed polyline. I could do that, you know, half to half, but I'm just going to draw a 3D polyline. So draw 3D polyline. I'm going to pick the layer I wanted on. I'm going to pick that grading layer. And, oops, sorry, let me repeat the command. I'm not going to prompt for elevations, and I'm not going to use a surface. I've got road grading, that's fine. I'll say, okay, I'm going to take that. It's going to read that surface elevation. I'm going to climb up to the crown, and I'm going to close back to here. I'm going to close this guy off, the same deal. So I'll repeat that 3D polyline from there to there to there. So now I've got everything enclosed, and to build this into a surface, I'm going to shrink wrap this, but I need a continuous line around it. So I need to draw that shrink wrap. So draw shrink wrap entities, and I'm going to choose this time bounded line work only. And I'll say, let's call this, instead of SP perimeter, we'll call it road perimeter. Say okay, and we'll just grab all of this. It now creates, there's our inclusion closed polyline. Let's build a surface. So surface, triangulate and contour. Let's change the name. So we'll write the file, we'll select it, and we're going to call this Haul Road. Say that. We will use inclusions. I'm not going to contour it at this stage. I'm going to say okay. I'm going to select that close polyline for my inclusions, no exclusions, grab my data, off it goes. It tells me I've got a crossing break line problem right here. It's pretty, yeah, just right in there where that sort of doubled back on itself due to the geometry. And let's see, you could fix that by, here's an easier way to fix that is, let me just exit that, select, I'm going to choose to add a vertex to this polyline. There is the perimeter polyline, and I'm going to add that point. Oop, it was too close to that edge, so let me undo that. Let's see, what do I want to do with that? I want to, oh, there it is, 2D polyline rather. Now if I add a vertex, I'll just add it that way, and I'll just manually drag it up and set that now so it rides over there, and then this is where it crisscrosses. So I'm going to take this 3D polyline and bring this guy back to and point right in there, just a little bit off the edge, but it's still on that 3D. Now I'm going to verify that I haven't screwed anything up by viewing it in 3D and looking at that area. I'll turn that around, zoom in there tight. I say, yeah, okay, that should work. Didn't have any major problems. So now let's go back to triangulate and contour. Again, keep everything like we had it. We'll say, okay, yes, overwrite the file, pick the inclusion line now. No exclusions, grab the data, and now we should have cleared that error. We didn't, apparently. I have one slightly crossing, but it's 0, so I can safely ignore it. I can view that surface, again, just to verify. There it is. I can turn on, turn on the contours. So there's what you can see the crown contours, everything looks good. Okay, restore my layers. Now freeze by pick. I'm going to freeze off the little edges. Let me do that one more time and get that perimeter off. And then I can put those contours in here. So I'll go back to surface, triangulate or contour from tin file. Let's contour the road now, the haul road. And I'll draw the contours. I'll not label them. Everything's set to be the same, making sure I do not have the erase. I don't need to use the inclusions. Okay, that should, yeah, erase. Let me set that to off. And now that I've drawn those in to match what those would look like. And finally, go to my surface triangulation file utilities. Let's load a tin file. Let's load up the merged file that we had. Let's go next, and let's merge into it this second file, which is my haul road file. And everything would look like that. It's going to give me a nice little thing. I'll save as, and I'm going to call it total. I'll exit. I'll view the surface. And there it is with the drawn contours. We've got our borrow pit. You got nice crisp edges where everything has been built and created. You can see the crown on the road. Now, if you could have gone to the effort, you could have put a curb and everything out there. Again, it's just a haul road, so we're not, putting curbs on it. You got a little bit of tie-in out here on the beginning where we offset. We're a little bit past the surface here. You could dress those up. You could shave off these tops if you want their little peaks on our surface. Let's come back to this surface and change the visibility, the opacity back up to being solid. You can also see where that crown shot down, so it dropped it a little bit in here. I could technically adjust this line and the outside line to bring that up to meet right on that floor instead of changing that, instead of having it, offset all the way along its length. I could just take those one particular points. And you could even do it if you're so inclined. You could edit that point elevation by doing a 10 file edit of that point and set the elevation up there. Let me see if I can do that. Let's set the point elevation. I don't know if it's going to let me pick, but if I pick that point there, that low spot, yeah, I have to type a number. It doesn't let me pick that number. So if I type that point, that's 392.5. So that's when I'm going to copy it. So now I'm going to come down here and double click that one and set that to 392.5. See, I pushed it back up there. Same thing here on that point, 392.5. So it pushed up those edges. Now it's still coming down and then, trying to push things back up. So, just little tweaks that you can do. And again, if I were in civil, I've got ways to flare out those points. Now I would then, need to also set this point to that 392.5. So you see, I can keep chasing this back to crown, or I could just put see if I added that as I don't think I can add this as a break line from here to here. Yeah, no, because it's crossing these too many. Yeah, so, again, any number of ways. The way that I would have normally fixed that, instead of trying to chase these down, point by point by point, I would go back to this 3D polyline and I would change the elevation of that point and that point to be the same as this crown at this point. So if I do that, I'm going to look at my vertices. There's my first one. I'm going to go to the last one. You see, I'm there. So I go to that one there. I'm going to set that as 392.5. Dink, dink, 0.5. And go, in case it's doubled up, it was. So 392.5. All right, so that's good for that line. I can go to this line, do the same thing, go to the end, set that to 392.5. And if that's doubled up, I'll go back one more. It's also doubled, so 392.5. All right, so that sets that. Now, let's fix that one that was on that layer. Would have been, that cross piece, but I'm not going to worry about that. I'm just going to take these 3 lines. So I'm going to isolate the 3D line work there. I'll shrink wrap that now. I'm going to draw my 3D poly from here to here. Oops, yeah, to here. Okay, so brought that back. Let me change that. Okay. So if I come back to this line now, I'm going to change those vertices to be 392.5. Go next, 392.5. All right, so that should work. I'll rebuild my road surface. So I'm going to triangulate and contour again. Write the file, select road, or haul road rather. Right there it is. Save, yes, okay, overwrite. Use inclusions. Did I have the inclusion set? Anyway, I've got everything set off here a minute. Let me isolate here again. Let me escape that. Let's isolate the road grading and the center line. Now, let's triangulate and contour. Do I have, oh, I need to draw the shrink wrap. Let's draw shrink wrap around the bounded edges. And there it is. Now let's triangulate and contour with my haul road surface using inclusion. Yes. Okay, to overwrite. I don't know why it's turning that back on here. So road perimeter. There's inclusion. And no exclusions. I want to select this data, but deselect this. Again, I don't know why, so I'm going to hold the shift key and click. I don't know why it's turning those back on. I guess they're on the same layer. All right, so that looks like everything that I want. I said enter for that. Oh boy, they gave me some. Okay. Well, let's try it one more time here. What layer is that on? Insert contour. Let's erase the contours. That's the easiest way to do it. That's clear. Select from screen. Get those out. Now, let's build our surface. Triangulate and contour. We'll say OK. Overwrite. Select our inclusion. No exclusions. Grab our data. There it is. Okay, that was because it was set to do that. I've got some T intersections. Okay, yeah, because I tweaked that line up because those were still pushed down to that old elevation. So the simple way of fixing that, let me go back and re-erase the contours. So if I erase by layers again, just keep those on. So this line, that line there changed from here to here. So if I get rid of this line and this line and this line and this line, that should, let me see where that line goes from there to there. So nothing in between. It's still using the points in there, so I won't get those errors. Now let's build. Okay, yes, overwrite, choose my inclusion. No exclusions. And now grab this and hopefully, didn't follow my prompts. Sorry, one more time. Say, okay, that's overwrite. Choose my inclusions. No exclusions. There we go. Now, still gives me, still got something in there that I did not elevate. Let's erase by layer again. Get rid of the contours. This line, those particular points. All right, so if I got those, let me take a look at them in 3D, see if I can find what's going on. Yeah, there we go. See, those red edges were down where they used to be. So I need to get rid of those red 3D polys. That was part of that original grade line, so I'll delete those. I got a little bit of a tweak right in there where that went out to that edge. I must have got that to that edge. So if I take this and erase that vertex, what is that? That's also that one. Let me erase that whole thing. That needs to go now down to that. There we go. I just missed it when I snapped it the first time. All right. Finally,
surface, triangulate and contour. Yes, right. Choose the inclusion. No exclusions, and now get your data. And hopefully, and still got, let's see where it shows us. Still got some things going on in there. All right, let's take a look at that right there. I look at that in 3D. There we go. So if I set my settings, set my CAD view to that, okay, and exit. Now I'm going to zoom in there and fix that geometry. So what I need to fix is this line here. I need to bring that vertex up to there. And that'll take care of that. And I'm going to fix this one by bringing this guy up to there, and that'll take care of that one. Now I've probably, let's see, that should be fine. Go back to top. I'm going to erase those contours by layer again. Triangulate and contour. Yep, overwrite. Select the inclusion. No exclusion. Select the data. Hopefully, and still got, but they're too small to register. So wherever they are, it's not even going to let me look at them. So now I've got that surface back to triangulate. Let me turn that back. Turn my layers back on and then freeze my pad grading. And get rid of my site boundary. And if I've graded this, I've graded the existing, I need to merge that surface now, go back to triangulation file utilities, load up the original stockpile pit merged, go next. I'm going to merge into that the road, the haul road surface that I've now resolved. Look at it there, and it's going to be nice and smooth. I'll save that as total again. There it is. Yes, overwrite it. I'll exit. I'm going to view it. And let's turn off these edges. There's the contours. But more importantly, look at this road edge right here, how I brought that edge up to meet right on that edge of the pad itself. So originally those lines were 2% down. So I'm 2% down everywhere else until I get right here to the end, and I just bring those up, and that now has fixed that little discontinuity right through there. It's really not even enough to worry about. Now, I'm not going to fix this out here, but you could do it by the same method. I would then take these lines and drop them right on the surface, bring this one up to the surface, trim it back. Because you can see what happened is that when I offset it, it's a little bit off the surface here, and it's a little bit off the edge in here because I'm not perpendicular to the edge. So no big deal, but that cleaned that up. Now, that being said, now we're actually, a half hour past our day. So Frank, congratulations. You're going to get an extra hour in your PDHs. So hopefully they'll count for something.
Sounds
And
good to me. No, thanks for the extra knowledge. It helps a lot.
You betcha. And and again, we can go back to draw the contours. You can draw the pad contours or the borrow pick contours, just like we did before. You can, turn on and off or erase even if you no longer need. What is that? It's my road perimeter, so I can get rid of the perimeter line. So now there's the tied in contours. So if I draw the I need to turn on the pad, the borrow pit gradient. I need to turn that on to recreate contour from tin file. And I'm going to, actually, I wouldn't even need to do that. Let's just undo that. And let's just contour from the tin file, and let's contour now the borrow pit. Same thing there, no labels. No need for an inclusion there because it's only going to go out to the edge. So there now is my grading plan. This is a little bit of wackiness right in there. So this merged right in. See, this bank is coming into this bank here. So I would probably just take this contour line and just trim it off. You know, where it hits right in here, I might say that. And let's trim that. And, you know, there's now my grading plan, as well as everything else as part of my design. Okay, so again, the civil tools though, and that's what, you know, in the civil class, for instance, we go over a lot more detail on those road designs. But you can see how that all works. I've got that similar to this 395. I got a little bit of a contour goofiness in here. Because this 95 slope comes down, this 95 slope comes down, and it sort of crosses in here, and contours don't really do that. So really what I need to do is to trim this out. Let's trim those, erase those, and then we'll do a fillet, the radius of 0. And I would say this one would be what I would do is just get rid of that one so it ties and rides. So that would be, you know, just a little bit of the cosmetic cleanup to go around. And there's your finished work. Okay. So if you've successfully followed along at home, you've got a file now that you can compare to the one that I've got included. And I say I need to do that same thing with that contour in here and in here, just like I did this one. Yeah, in fact, the reason I did that is that those would not have been shown if I had merged the surface and drawn the merged total contours and had the boundary that, you know, just went around the road edges. In fact, real quick, let me get rid of the contours one more time, and let's do this to keep from having it happen. I'll go back to my triangulate file utilities. I want to load up the borrow pit, just the borrow pit. I'm going to go next, and I'm going to merge to it. So the second 10 is inside, no, remove from the current 10 where it overlaps the second 10. There we go. And I'll say, okay, and let's choose the haul road. And now that is just going to be that as a single surface by itself. I'll save that as, and I'll call this one pit dash road. And now I'll contour from tin file. I'll use my pit road. And now when it goes, there it is. So now that trimmed out those discontinuities because I merged the road to the pit, and I didn't have to try to worry about inclusion parameters around here to try to trim it off. It's still just trimming it. So, you know, think your way through some of those spots, and you see like the reason that contour came across was I drew the contours for the pit first, and they did all cross.
And then I drew the road, and that's why I went back and manually erased them. But now you can see the actual results. And this actually comes in here and hits this contour line, and then it goes over and crosses that. So it doesn't really quite connect in there, but it connects back to this line, each of those. So that's exactly correct as to how it should look. Okay, you can then view that in your 3D viewer and also go to the model tab, and let's add in the total surface. And that now would be what you have. What is that line? Oh, that's the existing contour. So if I wanted to turn off those existing contours, I can take these two and freeze off those layers under the layers category. And so there now would be what your design is complete. You had a stockpile, and remember we started this with just a file with a bunch of points dumped in it, didn't even have a coordinate file. So using all of those tools, we were able to generate, you know, a nice little surface. The road comes up here, it's above the ground, it tapers down on the edges. I've got a slight couple of spots right in here where it has to cut up. We're actually down below it, so it comes up, it's in cut. Everywhere else it's in cut in here. It's in fill just a little bit right in here to meet those edges. So you see it followed our design intent very nicely as to how we did it, okay? So there we go. And there's your work. And we will stop our recording.